because I don't know exactly.
Mohammed, where you from?
Look. I am joined
Okay, Habib.
this room because this is the first time I use this application, and I just need join in any room and don't know what's about what talk. I don't know what's about you talk and just join.
Okay, welcome, Mohammed. Your English is very good, Habib.
Uh, Thank you, thank
Yeah,
you.
your English is good, Mohammed.
Okay. You do need to practice more.
Yes.
No one here is Arab, right? Because your accent is not Arab. Just one say with me like he is Arab.
Well,
Yeah, he
there's
left.
another person. Yeah, you're the only one now. You're the only Arab.
There are some Arabs that come in here, though, Mohammed.
What?
There are Arabs that come into the room to talk sometimes.
Okay.
What about N7? Are you flat Earth? Are you globe Earth?
You talk with me?
No, there's another person in here with the name N7. Haven't heard him say anything.
Okay. Down. Okay.
I wonder how flat Earth is viewed in Muslim majority countries. I bet most Muslim majority communities have a higher percentage of flat earthers than especially like secular groups, which is most of America now, I feel like. So probably more flat earthers in Arab countries than predominantly white countries.
Why would you say that?
Several reasons. First, I think religious people in general are more likely to be flat Earth. I think that's definitely true. I don't have any like statistics to show you, but just from my intuition and my interactions, I found if you're atheist or more like even more like leftist type, secular type, you're more likely to be like flat Earth is crazy. These people are crazy.
Yeah, I would agree with you.
And then as far as like Muslim majority countries, which are Arab countries, I feel like Muslims, even more than Christians, are more into like I don't know how to say it, but like not as I guess West. You know, it's not Western science. So like Christians are Western science based, and Arabs are more Eastern. I guess Middle East. You know, what they are Middle Eastern based science. So it's just different. It's more like spiritual, more like.
Yes, I agree with you.
Yeah, it's just a whole different culture. They don't do
Yeah.
the cancel. Like Muslims don't cancel other Muslims. It's not even a thing they think to do.
Yeah, but they cancel Christians.
Look, we believe in science, but not all science. Like the Big Bang, the bomb is behind the all in university beginning. Uh, in Islam is the uh, it's happened like, but God make it, but not every and like in the human it's a monkey in starting the earth. That is a big uh, it's not a truth. It's not true
Yeah,
because God make the human in the earth in the first like Adam and Hawa.
of
I
course,
don't
of
know
course.
what's its name in Christian. Uh,
I mean, in your countries, there's a bell that rings 5 times a day. They do that. They're shouting prayers. They're doing chants. They're all bowing down, like doing these things. That it's a completely different world. Like if you grow up in that environment, then it's just a given that like God is the creator of everything. It's not like a question to go
yeah, it's
fight with
not
your
a
parents.
question. It's
Yeah, you
Yeah.
don't
it's
have a
true.
choice, right?
What?
Well, I wouldn't say because there still are people who do dissent. You know, I'm just saying the culture as a
Yeah,
whole.
who?
Which,
I am from Iraq, and in
Yeah.
Iraq it's have
What's the
different religion. We have the Muslim, we have the Christian, we have it's we have the religion. It's you don't know. It's it's his name is
Assyria?
Yazidiyya, Syria. Yeah.
Yeah.
And about uh, 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 هذا and we have Jewish but not now in the past.
What's the punishment for apostasy?
I mean, that depends on what country you're
No,
in,
I'm not
what
asking
group you're
you.
in. I know you weren't.
Muhammad.
I
What?
wasn't.
What's the punishment for apostasy?
Can you say again? I cannot understand you.
What's the punishment for apostasy?
What the punishment of apostasy?
You got to explain to him what the word apostasy means. Muhammad, apostasy just means that you've gone against your religion, you've rejected your religion. You could even like blaspheme against Allah or something like that. Like it depends on the severity. It's just like any other thing. It's not like
What's
they
the
kill you
punishment in the
instantly.
Quran?
They're not just
What?
gonna murder you.
What's the punishment in the Quran for apostasy?
This is
I am the punishment in the Quran. Look, the punishment I know is the series. The
What is the
character in
punishment
Marvel,
for turning
but
away
in the
from
Quran I
Islam?
don't hear this thing in the Quran. But it's maybe it's in the Quran, but I know in
You haven't read
You-
it?
Arabic,
You're Muslim, right, Muhammad?
right?
If you turn your back on Islam and you turn away from Islam, what is the punishment?
You say in the anyone in Islam and it out of Islam, like that.
Yeah, that's what
You mean?
apostasy means. It means you leave and you talk badly about
Uh,
Islam.
this thing is very hard. I know in Islam it's we
What does
should
the
kill
Quran say?
anyone out of Islam. But if he's Muslim and out, but if he's not Muslim, we don't kill anyone. But this in the past, now in the future, no one call anyone, no one kill anyone. If he's
Yeah.
Muslim or not Muslim, if he's out of Islam, but just anyone Muslim and out of Islam. But you are not Muslim already. We don't kill you, but we invite you to Islam.
So it's death, right?
No,
Ev-
he just
yes,
Yes.
said,
death, but
man.
just
Okay.
for Muslim out.
Yes,
Any
only for
Muslim
Muslim,
out
right?
of Islam.
Yep. So it's death, right?
Yes, death, but
Yes.
anyone out of Islam. If I now
I
go
just put
out
it in
of
the chat
Islam,
for
I will
everyone.
death. But if you're not Muslim, you will not death. We invite you to Islam, but we cannot kill you.
Yeah.
Anyone who's not Muslim.
And if you don't convert, you pay a
It's
jizya,
like
right?
look,
Pay
the
a jizya.
jizya.
Yeah. And then if
The
you don't pay
jizya.
the jizya, what's the punishment for that?
I don't know
Death.
what's the punish of the anyone don't pay the jizya, but the pay the
Yes.
jizya of the just non-Muslim and he is live with Muslim.
Yep.
But that in the past, not in the future.
Yep.
We
If
in
you
Iraq
don't
have
convert,
many of
if you don't convert, then you have to pay the jizya, right?
yes, jizya.
Yes. Yeah. So you've got to pay to stay alive, right? If you don't pay the jizya, you can be subject to slavery or death. Correct?
I don't know.
Yes.
Uh,
Sounds
so,
like I know the
any-
Quran better than you do.
look, I am read
Anyway,
the
back to the
Quran,
topic.
but
That's
but
all I wanted people to hear. That's fine.
I am
Yeah.
look. Uh, in the Islam, it's have people know everything about Islam, and people not it's not هذا know about everything. Like me, I am don't know everything. I just
That's good.
uh, doing what I
You
just
don't need
do.
to
Like
believe this, man.
What
I
is
don't
it?
know why we're like grilling him on Islam. I mean, people do the same thing to Christianity. They bring up out of context quotes from the
Is it out of
Bible, try to
context? I
like
just
corner.
posted it in the chat. Why is it out of context?
No, I didn't say what you posted was out of context. I'm just saying people do that. They'll bring up
Okay,
stuff out of
find me
context.
something. Find something in the New Testament that says that.
No, I'm not saying that the New Testament says that.
Well, you just did.
Well, that's not what I meant. I'm just saying a lot of people will like if somebody outs themselves as
I'm
religious,
just
like
saying
Christian
that
or
we should
Muslim,
probably move on
they-
back to the subject of
and
the
like
room.
they're limited in the religion, and it's like this dude never tried to push. We had to ask him if he was a Muslim or not. You know, he didn't bring it up.
All he was doing was asking a question, right?
You can only execute people for apostasy on a flat Earth.
I
That's what
told
we're
you
supposed to be
guys,
doing, talking about the topic of the room.
this is the first time I use this application and just want join in any room just to talk with you English, just to talk English and
Yeah,
join. I
we
am
normally
don't know
talk
what's
about
for
science,
you.
Mohammed. We normally talk about
What?
science, and we normally talk about science and
Yeah.
geometry. We don't talk about religion.
Okay. I will stop talk about religion.
No worries, man. We don't want to offend anybody in that sense. Religion is personal.
Yeah.
Unless you believe the Earth is a ball. If you believe the Earth is a ball, then that's a religion too,
Yeah.
because
What?
religion requires belief.
Uh, Look, it's have many people. Muslims say uh, the world is flat because
I know. We talked to many of them.
it's reading the word it's reading in the Quran is the flat. But
Yeah,
have
we
the
The
talked to
people
Quran
many
say
says,
it's not
Muslims,
flat.
and they say that
listen,
the Earth is flat. Also, they agree.
Yeah.
the Quran says that the earth is rolled out flat like a carpet, like a rug, like one of those nice rugs that you pray on. They say that the earth is rolled out like one of those.
Uh, can you speak slowly? Low?
Yeah, the Quran. I've read a part of the Quran that says the earth is like a rolled out rug, you know, like a prayer rug. Like it's rolled
I
up,
have
and then you roll it out,
I have a
roll it out.
theory.
Uh,
I have real
like the Alad.
theory. Can I say my theory? I think the earth is flat because my dick is flat. You know?
It's just rude for you to bring that up. We're having a like decent conversation here, and then you gotta like bring in your weird sexual
It
stuff. It's,
no, it's not sexual, bro. I tell you.
it is. Well, it is
Is
because
anyone
that's
here is engineering?
No. But why you think the earth is flat? Give me.
Because the surface of water is flat, and if 70%
But
of the Earth is made up of water, that
okay,
means
but I have a
70% of the Earth
question.
is flat.
I have a question, okay?
Uh-huh.
Why is the ball why looks the ball like a ball? Not like a
It
earth ball.
doesn't. It doesn't. The cartoons that you get shown in NASA images, that looks like a ball, but you've never seen a ball, not on Earth.
Okay. But it's illusion.
Remember, the Earth is too big to see curvature. Remember,
I know, I can understand. But you think not
the
only the
Earth.
earth
No,
is
no, no,
flat,
no, no, no,
other
no.
planets
Listen,
also
listen,
flat?
listen, listen, listen,
Okay.
listen. The Earth is too
Mhm.
big to see curvature. Correct.
Correct.
Right. So you've never seen a ball.
I see a ball. I play with a ball. I play basketball.
Well,
I
you
play
play the ball.
soccer.
You've
It's
never
all a
seen the
ball.
Earth as a ball.
But it's okay. I understand. I understand. What do you mean? But I have a well, okay. But I understand. Um, if the ball not a ball, it's if it's flat, must be also all everything flat. It's then also fake if you say the world is 3D. Is it right or it's not right?
See, this is why it's rough having this conversation with people who aren't fluent in English. It's just difficult. But I guess that's true with any
No, you
topic.
just got to break it down in simple terms. Like that's called an all or nothing fallacy, Bell. Basically, you're saying if one thing doesn't work, then all of it must be wrong. So therefore, everything must be fake.
I didn't say that. I said it's more difficult. I said
Yeah,
it, and
both
that's
is
I
true.
wasn't
true.
It's
talking
better.
to you. I
But the
wasn't talking
body
to
of
you.
the human is 3D.
Yeah, look. The
It's not
Absolutely.
top
flat.
of the Earth. Listen. The top of the Earth is flat. What shape it is, I have no idea, but the top is flat.
Okay. Okay. But do you think all planets in the universe is flat, or only the Earth is flat?
Well, the Earth is not a planet. So all the planets in the universe, they
What is
look
the
round,
Earth?
but the Earth is flat. The Earth is home. The Earth is the floor.
Okay, I understand you. Okay, I understand you. But you say we don't live in a planet. It's our home.
Yeah.
Correct.
But
He's saying planets aren't the same thing as Earth. Yeah, he's saying Earth is different than the planets. They're not the same thing.
did you think in another planet or another in the universe
We're
it's
not a
living
planet though.
any other guys?
You got to take your mind away from this being a planet. So the idea is that you're not on a planet. Those things that you see in the sky that are planets, that's not what we are. So yes,
Okay, but
it's a different.
another guy, maybe an alien. I said no alien living in another planet, another home.
Well, there's no evidence that an alien is living on another planet, right? And you got to understand something, Bill. A planet is something that's in the sky. The Earth is not a planet because the Earth is not in the sky.
But okay, you said the Earth is not on the sky. You said the Earth is not
No,
in the universe.
no,
If you
it's saying that a planet. You keep saying another planet, like it's another thing like us. The idea is that we are not a planet, so there can't be an alien on another one of us because we're
yeah,
not a planet. It's on a planet. It's not on Earth. Earth is not a planet. Earth is a different thing. It's flat, and we can look up in the sky and see things, and we call them planets. But it's not what we are. We're not just a thing floating in space. Space isn't
Yeah,
even real, Bell. The
you
the
you can't
crazy thing.
say you can't say that we can go and land on another planet because you look in the sky. Tell me what other than a sphere, because if the Earth is not a sphere, what else in the sky makes a planet look like Earth? Are there trees on the other planets? Can you see the trees? Can you see water? Can you see air? Can you see any
yeah.
of these things on the other
Okay.
planets?
I can see water. I can see air. Air. I can see
On
everything.
on other planets, on other planets.
Nah, but because I living here because
Right,
I am not an
right. It's
astronaut.
only on
I
Earth.
can,
You know,
it's impossible. It's
I read a
impossible
news
for me.
article, right? I
Yeah.
read a newspaper article that said trees are so rare that they might only exist on Earth and nowhere else in the whole
Mhm.
universe.
Mhm.
So if trees cannot exist anywhere else in the universe, how can life exist?
I don't know. Tell me.
If plants can't exist anywhere in the universe, how can life exist? When I look up in the sky and I look at Mars and Jupiter and Saturn and Venus and any of the other planets, even the moon, I don't see trees. I don't see bushes. I don't see animals. I don't see humans. I don't see water. I don't see oxygen and
But you
air.
can't. You
I
can't
don't
see
see
it.
any of those things.
Yeah,
I
because you
know, but
you
it's only here on
it's
Earth.
impossible for you.
It's only here on Earth.
Okay.
You
But
have to get rid of the idea that everything could be up there because there's no evidence that it is.
uh,
It's just in your imagination.
okay. You think the other Venus, Neptune, or
I don't
the
think you can
moon?
go there and land on them. I don't think they're
Yeah. Okay. This okay.
I don't think
This
they're
one.
solid. I
Yeah.
think
Okay.
they're light.
This one understand. Okay. This one understand. Okay. But
Uh,
do you think this is exist? This all
yeah, I see them
moon.
in the sky.
Yeah, but
Yeah.
moon. You see the moon. You see the sun. Did you think
Yeah,
it
I see the
exists?
moon, I see the
Neptune,
sun.
Venus,
Yeah,
Mars.
they all move across the sky, correct.
Mhm.
Yeah.
Mhm.
That's all they do. They twinkle and they move across the sky. That's what they do.
But why is the stars in the sky so round? No.
because that's
But
the
it's
way
not
they look.
flat.
Yeah, because the Earth is not like the things in the sky.
Yeah,
There
okay,
is
but
nothing in
if
the
you,
sky.
yeah,
There's nothing in the sky that looks like the Earth.
yeah, but okay, you can't see the Earth and another, uh, you know, if you want,
So why
if
would
you
you think that?
if you land,
Why
no,
would
if
you
you
think
land,
that
yeah,
then? If you can't see the Earth like the planets in the sky, why would you
no,
think that the Earth is like the planets in the sky?
okay, I know, okay, it's good.
Has anyone discussed actual like measurements of the surface with him?
No,
I don't
not
know if he's
yet. We're
been here
just
a
trying to
while.
get him to.
I don't know if he's been
He's
here a
been
long
so
time.
far off in the weeds.
Well, he
He
came in
knows
trolling,
water's
so
flat. He knows water's flat. I asked him if water was flat on the surface. He said, yeah. And then I said,
But
well,
okay.
no,
the Earth is
water is
70%
So he's been here
water.
a while. Yeah,
but
I
the
figured.
water is not flat.
Oh, it isn't? Can you prove that?
No, the water has deep. The water is
Water
deep.
at rest.
Water
Oh
has
gosh. Okay, we're not
waves.
talking about under. We're talking about the surface of water. I know this is hard for you, but water
Nah,
at rest
but
is flat.
if you say to me the water is flat, it's not exist
Water's
waves.
surface is flat at rest.
Mhm.
Yeah, when you look at frozen lakes and frozen seas, frozen water, the water on top.
Frozen, please.
Yeah,
It's
it's
This
at
frozen.
is how we
rest.
use water levels because water is flat at rest. Yeah.
Yeah, but
It's really simple. And you talking about
no,
waves or whatever you're talking about is just it's I don't know, it's some kind of weird cope, you know? I don't know why you don't want to deal with the topic.
why is so aggressive, man?
Yeah. When they show us pictures of the Earth from outer space, it has all this blue stuff all around it, right?
I can understand this, but I think also the
And
pictures of the Earth
it
fake.
looks curved, right?
But
Do you agree?
yeah,
Or do you want to talk about something else?
no.
So Belle, if water is flat at rest, and we know that the Earth is approximately 72% water, at least the known Earth, how can we have a 72% flat ball?
Again, please.
If water is flat at rest and the Earth is approximately 72% water, how can we have a 72% flat ball?
Tell me.
We can't.
It's flat.
Mhm. Okay, I understand.
we measure the surface of the Earth is flat.
But why we living in the Earth if the Earth is flat? Why we have round things in the Earth? This
Why do we have
I
round? Okay,
understand this.
name something on the. Why do we have round things on the Earth if the surface of the Earth is flat? Is that really your question? Do you want to try that again? Like restate that or something?
Yeah.
Because that's kind of a dumb question. So I think I must have misunderstood you.
I'm gonna step
Okay.
away over fences and call my wife. I'll be back.
Okay, cool. See you in a minute. So, Belle, we're not claiming Earth is a flat planet in the solar system, right? You understand?
Mhm.
So we don't think that Earth is a flat planet in a solar system, and then we're surrounded by these other spherical planets. Do you understand that?
Okay. Yeah, I understand it.
Okay. So if we measure the surface of the Earth as flat, what is it?
Tell me.
It's flat
It's
because there
flat.
is no curvature. Yeah, we don't measure any curvature anywhere. No.
Okay. I don't think so, but it's okay.
Okay, so tell me what investigations you've done or if you have any evidence of surface
The
curvature.
right.
Or did you just come in here to troll and you don't really know anything about the topic, which is fine. I mean, we get that a
No,
lot.
no. I
But you don't
think the
actually
Earth
have any
is round.
evidence for your beliefs, right? I mean, you have a lot of beliefs, but you don't have any evidence to support those beliefs, right?
Okay. Yeah. Why so aggressive? This is the next question.
Do you have any proof of surface curvature?
Yeah, the horizon.
The horizon is proof that the surface is curving?
Yeah.
You realize the horizon is an apparent
It,
line where the Earth and the
if you
sky
fly with
meet.
the
That's
plan,
an
you see it.
apparent. If I what?
If you fly with the plan, you see it.
No, that's not true.
Why? Can you tell me why?
You don't see Earth curvature from a plane. That's not true. Have you not ever been on a plane?
I was, but I see it. It's
No, you
round.
didn't. You don't see Earth curvature from a plane. You couldn't, even if the Earth was a sphere, you couldn't see curvature from a plane. No, I've been on many plane flights. I've never seen Earth curvature out the window of a plane ever. So
Okay.
I don't know if you just deluded yourself or if this is what you've been told, but that's not what you see. So and if you thought you saw it, and then we measured the surface is flat, it doesn't really matter what you saw because we took a measurement of the surface.
Yeah. Yeah. Okay. It's enough for me. It's enough for me.
Okay. Yep.
Okay. Thank you.
Okay.
You're the best.
Ciao.
Thank you.
Come back if you
The Earth
have any
is flat.
proof.
The Earth is flat. I
Well,
understand.
you know what?
I am
You
no.
know,
No.
come
I
back when
think.
you have any proof of surface curvature and we
Okay.
can talk about it. But until then, you
Okay.
know, it's kind of a pointless conversation, right?
Okay. Okay. I understand. Okay.
Yeah, I
Sorry,
mean,
Mom.
you came in talking about your physical problems, so I didn't have high hopes.
Okay. Okay. Understand. Okay. Goodbye. Thank you.
Goodbye. Have a good day. Is there anyone
You
else
too.
in the room who has any questions or commentary? I think, let's see, we had somebody. I guess he left. Let's see, who else is there here? Oh, I don't recognize N7, but other than that, I think I know the rest of y'all. So if anyone has any questions, comments, whatever, feel free to unmute and talk about it.
Hello?
What's up, Bill?
Where's the girl? He was aggressive to me. I'm sad now. Sheep dog. You tell me chilling. You know. I like you. I like you. Tell him.
Well, there's a reason why we're flat earthers, Bill.
Bro, your
Because we
headset
were
is so
told
shit,
that the
bro.
Earth is
I
a
think
ball.
your headset is also flat.
Right. Well, they told us the Earth was a ball, and then when we went out and measured for the ball, because the ball is not that big, it's not as big as you think it is.
No. Wait, bro. I don't tell the Earth is a ball because this is fake. But the Earth is like a potato, you know, not a ball, not round.
Yeah, but water is level, right?
Mm, yeah,
And water is equally equidistant from the center of the Earth, correct?
correct.
And so when they show you these pictures from outer space of a sphere Earth or a circular Earth, all that
Yeah,
water is curving around that ball, right?
right.
Oh,
And 70% of that Earth is water, right?
My friend is now in this server, in this Discord server, Flat Earth. He tell me
yeah.
the Earth is round. I have this from him, from Haare nach hinten, you know. He tell me
That's,
he see every day in the horizon a curve
no one's
Yeah,
ever
this is
seen a
right.
curved horizon.
I see
because
this
he's
in
astronaut.
Montenegro.
Oh, okay. So show me your picture of a curved horizon. A
Bro,
picture you took.
he can't show it because he's an astronaut and the astronaut has secrets. He can't show you
Oh,
Yeah,
every picture from the
this is
so the
astronaut
big
from
globe is
secret.
universe.
classified.
It's not possible.
The ball Earth is classified then, huh?
Bro, I
Yeah, I like
don't
that.
think so. I don't think so the earth is a flat or a round thing. I think the earth is a potato. You know, like a potato. You
Is a
understand me?
potato curving?
No. Yeah, maybe.
Yeah,
I don't know.
maybe.
Yeah.
I don't know.
If you mean a potato like a chips, it's not curvy. It's a potato.
You know where the potato Earth comes from?
What did you say?
Do you know where the idea of the potato Earth comes from?
Yeah, from the ground.
From
It's
Manuel's.
it's the measurements of gravity all over the Earth. It has nothing to do with the surface measurements. They're
But
measuring gravity.
okay, my friend have a question. He's an astronaut in the Montenegro. You know Montenegro. He was in the universe, and
There's
I
no
have a
astronauts in
question for you.
Montenegro, man.
You know what? Where's
Tell
Montenegro?
me your friend's name. If he's an astronaut, he should be listed as an astronaut.
Haare nach hinten. He's down
Yeah,
under the
write it in the
pillar.
subject.
Yeah, I'm
Frag.
from. Yeah, I question why you think the Earth is flat.
The surface of water is flat. That's why.
But this is
This is only
disgusting, bro.
only the water, because only the water.
Well, 70% of the surface is made up of water, and so if 70% of the ball is flat, the Earth can't be a ball, right?
But bro, I
Why
have a
not?
question. Yeah, why not? And I have a question. You said the water is flat. Why is the water so deep? Is it wasn't flat, but nothing can be so deep,
That's
is it?
because it's in its container. That's
No, bro,
because it's in
flat
its
thing.
container.
Yeah,
Just like
okay,
a
I understand.
bathtub or a swimming pool. The top
But
of the water is flat. Listen to me. The top of the water is flat.
bro, I tell you, nothing on the earth or nothing on the universe can be flat and deep. It is not possible. Flat things are not deep, you know? Ah, tell me. 1-1.
Hold on a second. Hold on.
Okay. Take that. Guck zu, aber sag doch.
So here's the funny thing, right? I'm gonna tell you some funny facts. The Milky Way galaxy is flat. The universe is said to be flat. Everything is said to be flat in the entire universe. Yet
Bro,
somehow you think that the Earth is like the planets in the sky.
Yeah, okay, I can
You
tell
haven't proven
you.
that.
Clouds
Show
are
me where
not
the
flat.
curvature is.
Air is not
Show me
flat.
where the curvature is.
My feet is not flat. My body is not flat. My phone is not flat. Why is
All
the
right, you
Earth?
know what? That's cool, man. You want to be a retard like that? Then go on and be a retard. All right, you can stay on mute. You can apologize in the chat if you want your microphone privileges back, or you can send me a direct message. But I'm not going to let you be a retard and just say, "Oh, because my body looks the way it does, therefore the Earth can't be flat." That's the fucking stupidest thing I've ever heard. People level their when they build their homes and they level their foundation, they level it flat, and they level it using tools like water and the surface of water when they use a spirit level to measure the surface of that foundation flat. Water is the universal level for flat. So stop being a retard. And I'm not going to unmute him. If somebody else wants to talk to him, they can. But I'm not going to talk to somebody that's going to be like, "Oh, my fingernail's not flat. The hair on my skin is not flat." It's retarded. Come in here, "I like you. You got more sense." And then come in here and start making a mockery of me. You're lucky the mute button is only on Discord and not in person. Because there is a mute button in person.
You're doing great, Sheepdog. It can be frustrating, man. You'll be all right.
Oh no. I'm making it known to even the people out there that are listening on YouTube, right? Like, come on, man, let's be honest with ourselves, right? We know how to measure for curvature. But we know how to measure curvature because what it is we draw a tangent that's a straight line, and then we measure deviation from the tangent. If there's no deviation, then that's considered parallel, and we can call it a day. Two parallel lines are two coplanar lines, and two coplanar lines are flat and non-deviating with curvature. Oh, my leg is not flat. Okay, well, you can measure the curvature on your leg. Oh, my head is not flat. Okay, well, you can measure the curvature on your head. Oh, the Earth is not flat. Well, let's go measure for it then. Oh, we can't do that. It's too big. It looks flat. I guess it's flat then. So if you look in the side chat, y'all, I posted an image of potato Earth that everybody keeps claiming. And that's the Earth without the water on the surface. And it's not even about like the surface of the Earth. It's about the gravitational force from the Earth. And certain areas have more gravitational pull than others. And so that's what potato Earth is. It has nothing to do with the surface. And then I posted another image that shows a picture of a table that looks like Jupiter. Someone photoshopped it to look like Jupiter, and then shows you that it's just a circular piece of wood.
facts are subject to interpretation.
Mm-hmm.
Because
That's
you know
what
you
I
have to
think.
start from like first principle. That's why I said if you don't know how to determine the truth, you know. So, for instance, if you try to start and like reconstruct flat Earth versus globe, and you start from the beginning. Hey, dude, I ain't gonna listen to what anybody said. I'm start from the beginning. Okay, so start from first principles. What is the observation of the Earth? What do I see? Looks flat. Okay, fine. What's next? How do I determine whether that's true? First of all, why are you even doubting it? Why would you even doubt that that's what it is? What's the evidence that that's not the case? Like the globe Earth can't even get past that point. The thing is, you can't construct a logical argument for the globe at all because you don't have the first step, the observation. Right? You always have to start with the assumption. If Earth was a globe, what would happen next? Right? You don't start with, man, the Earth looks like a globe. You know, yada, yada, yada. That's why this is that. And that's why this other thing is this other thing, right? So you have to start with an assumption because it's not experienced. Right? So it's constructed in the mind. It isn't perceived with the senses, right? Because we either have our senses or our mind, right? That's the only way we can gather information about the world. Would you agree with that?
Yeah, I'd agree with that.
So the globe's starting point's the mind. And the flat Earth starting point is perception. So when you start with the mind, you can imagine any fucking thing. That's you know, that's all possibilities. Whereas perception is limited to what human beings perceive. So we've narrowed it down. Hey, what do we perceive? But if you start with imagination, that could be anything. And then how do you go from the imagination? Hey, I can't, I think it's this, but I can't perceive it. How do I figure out what I imagine is actually true when I can't get the physical, when I can't perceive it?
I just have also a
See, that's
question.
what I mean by
Is it-
first principles,
Yeah.
because this is a Gordian knot, right? To untangle.
Yeah.
Right, and this is why this topic goes back and forth, and because we're globe Earth versus flat Earth are at two different starting points. If I'm being generous, it's two different starting. Now, obviously, most people just believe it's the globe because they were told it. But if you try to actually take the intellectual, rational position and try to say, hey, we're gonna work through this problem and figure out what's true, then the first principles from which you do your analysis matter.
I just have a quick question as well. For you. Like, who's the most hardcore, like, flat earther here? Would that be like, who would you say is?
Me.
Okay, either. So if I took you up, let's say I took you up to space. We went all the way up.
Every fucking time, bro.
I'm the hardcore one.
I know, but I know.
What if I took you to the beach?
Yeah.
That'd be the best
I-
offer he's had all
Look,
life.
you literally
I don't
saw
really like
flat
the
Earth
beach.
your whole life and don't believe it, bro. But you want to
I
take
don't
me
really
to
like the
somewhere. No, you've seen a flat Earth your whole life and don't believe it. But you're saying you could take me to this imaginary place, and yeah, if you see the globe, you should believe that. Why don't I just deny that the same way you've been denying flat Earth?
I do, but go with my question a little bit.
I think I gotta see the globe every day. How old are you? For 29 years or whatever you are. I gotta see it every day
I'm
for
20.
29 years. Then I'll believe it's a globe.
Okay. I just have to ask you one question though. Like, go with the analogy real quick, or the hypothetical situation. So I
Yeah,
take you
if
up
I-
to space.
and you see around Earth, you know, it's a globe and everything. And then you come into here and you say, I've seen the truth. It is a globe.
I've seen the truth. No,
Yeah.
say,
Yeah.
hey, I went to
Oh.
space. I looked at the Earth and it looked like a sphere. That would be the truth.
Check the side chat,
right.
Stitches.
You see what I said? It looked like? Just like the Earth looks like it's flat, but you don't believe it is flat? I can play the same game. I could say it looks like a sphere, but actually, it's just a sphere that's so big it's actually flat, right? So a sphere of infinite radius is flat. I'll just say that.
Just reverse the idea. He took you up into space and you saw the Earth being flat. What would you do?
Then I'd say it's flat.
Yes, what's underneath it?
Yeah.
Only from space. See, you can only determine what reality is if you go far away from the Earth. You can't do it when you're here. You got to go to the magical space place.
Yeah, like if I took you all around, like the entire perimeter of the Earth, you know.
Do you understand? Remember when I started? I said the first principles that you have to start in concepts and ideas.
Yeah.
Space, as far as you're concerned and I'm concerned, it's a concept and an idea. It doesn't exist in any reality. And you think that somehow you can go to the place, which is a concept, to prove reality.
Well, let's say it's not a concept for just like this hypothetical situation. It's hypothetical. I take you around the entire perimeter of it, and then you come here and you'll say it's a globe. Would anyone here be willing to accept that from?
I hope not.
Hardcore.
I hope not. I really hope not. Why should they?
They should take one of their most hardcore person's words.
So you base truth based upon the words of a stranger. See, this is the fundamental problem, man. You found the problem. Okay? Regardless of what I tell them, I could go up to space, see the Earth as a ball, come back down and say, hey, Jedi, I went to space, I saw the Earth as a ball. Now, Stitches, would he know the Earth is a ball, or would he just believe it?
I'd say you'd know because it's a first-hand experience and you've been up there.
Now, I would know if I went, but he wouldn't know.
Then we'll just take Jedi with us, you know, for fun of it.
Oh yeah, and then he'd come back and tell somebody else, and then they won't know either.
Then
This is the fundamental problem is it's a belief system. The globe is a belief system. You just pointed out the fundamental problem is that you don't think that you can figure it out yourself and that you have to believe the claims of strangers.
What if we get a video of it as well and it shows it being round?
Yeah, but then you have to believe things about the video.
What if the video is undoctored, it's unedited, and it's...
How can you tell that?
Factual?
What type of analysis can you do to video to figure out what's in the video actually depicts reality? Nothing. There's nothing you can do.
We can see if there's any jump cuts in it. We can see if there's any AI detection. We can see other things of that.
Yeah, but there's look. The biggest way to fake video and pictures is to just label them wrong. Right? You take a real photograph of a painting and then say this. Look, you take a real photograph of a painting. So say you have a hyper-realistic painting of Morgan Freeman. You take a photograph of it and you say, hey, look, dude, this is a photograph of Morgan Freeman. No, it's a photograph of a painting of Morgan Freeman. It's not Morgan Freeman. You understand? All I did was caption it wrong. Now I could take a photograph of a globe, a painting of a globe Earth, and it would be a real photograph. 100%. You could examine it. You could examine the fucking film. You could look at it with a microscope. It would be 100% real film. But it doesn't mean what's on the other side of the camera is what I say it is. Okay? But you know what we can do? If we take a photograph of the Earth, can we test what's in the image in reality? Like check this out. So say we went to New York City and someone showed us a photograph of the Eiffel Tower in New York City in the middle of Central Park. We could go to Central Park and see if the Eiffel Tower's there, right?
Yeah.
And it wouldn't matter anything about the photograph. We ain't got to prove the photograph's fake or anything. If we go to Central Park and there's no Eiffel Tower there, we know whatever that thing is, it doesn't represent reality. Right? So we can do the same thing with their photos. Whatever the photos are, we can check to see if what it shows in the photo of what the Earth is actually exists in reality. And you have a whole bunch of evidence, which you just said, to show that the curbing water, the curbing ocean, all that stuff doesn't exist in reality. Exists in imagery. That's all. That's the only place it exists, in concepts, on screens, in picture books, toys in the corner of the classroom. But with a place where it has to exist is out there in the natural world. That's where it needs to exist. And no matter how many people, if I go do my own tests and I go, hey, dude, there's no fucking curvature to the water. I don't care what the fuck they show me. They can show me pictures. They can show me math equations. They can show me whatever the hell they want. Doesn't matter. Is it going to falsify the observation? So I'm looking at nature. I'm not like going into this abstract concept of like ideas about what the world is, right? When I don't have the basic natural evidence that's in the natural world to support my ideas. Science always comes down to empirical observation. It doesn't matter what fucking people say. Do you understand that we invented science and the scientific method so that we don't have to deal with bullshit like this? People claiming they did stuff. People saying they got this result. It has to be testable, repeatable, verifiable. So that means if someone says, hey man, I mixed these two things together and it exploded. Okay. I should be able to mix those two things together and it explodes. If I do the exact same thing as them, right? Has to be testable, repeatable, verifiable. But ultimately, if that person just wrote down an equation with the two substances and said, boom, two things go together, go boom, that would be even less valid because they wouldn't even have even in an empirical starting point at all. Science is empirical. It's not based upon ideas, thoughts, rationality, theories, explanations, just those stories or anything like that. It's based upon tests done in the natural world. And this is where I think the Western civilization has really gone wrong in the last 100 years, is because we've gotten away from experiment and gone into fucking la-la land of theoretical physics. I mean, we've had Jedi can attest to this. We've had people in here with science degrees talk to us that don't know what the scientific method is. It ain't our version of the scientific method. It's the scientific method that's in the fucking textbook. We had somebody last night. What did he say? He said, the first thing you do is an observation and then you start modeling it. It's the fucking dumbest shit I ever heard. Science isn't modeled.
To hear this,
Well, I mean, not enough scientists took the philosophy of science. You can't do science without certain prerequisites, right? You need logic, right? First thing. Do you need logic to do science?
Yeah, I'd say you do. You need some form of intelligence.
No, actual logic, not just intelligence. Reasoning, logical reasoning.
Yeah, I'll agree with you on that then.
So the reasoning, the logic comes first. You can't do science without it. And the reasoning behind science is empiricism. is that facts about the natural world are known by testing the natural world. It isn't, they're not known by thinking about what should happen in the natural world. They're known by actually doing it. So if you have some theory or some hypothesis about something that happens in the natural world or some fact about the natural world, the only way it's considered a scientifically valid theory or hypothesis is if you do the experiment. Until you do the experiment, you're just talking.
I see what you mean.
You agree with that?
Yeah, I agree. You need actual verifiable. You need to do the tests.
Yeah, or it's not science. Anyone can sit there. Me and you could smoke some fucking weed and just talk about, oh my God, what if this, what if that? Well, that's not science. Speculation isn't science. Imagination isn't science. The scientific part is the actual experiments. That's the scientific part.
It is rather fun though to speculate as well. I can't lie. I do love thinking of theories.
That's fine. But the thing, when we get to this, the main problem is in modern day, because of just in the modern society, when people hear something is based upon science, they hear absolute truth. That's what they hear. Oh, it's the scientific consensus. They hear that's the absolute truth. They hear it's scientifically proven. They hear that's the absolute truth. Not knowing that the real science is the experimental result. And though you have an experimental result that does something, I do some tests, I get some result, I have measurement data, all that crap. That ultimately has to be interpreted by a human being. Okay? And then you have your assumptions, right? Your presuppositions about what that data might mean. And it could mean, and it could fit your hypothesis, but that doesn't mean exclude other hypotheses. Just because you have a story that fits, it doesn't mean all the other stories are wrong and yours is right. But
yeah, I
this
can
is
definitely see what you mean in it.
yeah, and these are like if you went to the philosophy department of any university and talked to the people teaching philosophy of science, this is all well known. This isn't stuff I'm making up or invented. I'm not being super smart. I just happen to know about it. And it's been known that the modern science uses inductive inference, reasoning, and all of that. Any type of reasoning done doing this method has the logical fallacy of affirming the consequent, right? So, for instance, if the Earth's a globe, ships will disappear over the horizon. Ships disappear over the horizon, therefore Earth's a globe. That's affirming the consequent. I could equally say, if the Earth's flat, ships would disappear over the horizon. Ships disappear over the horizon, therefore the Earth is flat. Affirming the consequent. Almost all scientific claims have this packed in it. But they don't tell you this because it's will to power, man. Don't underestimate that people espousing to do science that aren't actually doing science are really just doing what they do for power.
There's a lot of power in like the sort of things we talk about and the sort of information what we give out.
Well, I mean, which one do you think will get a better girlfriend or a hotter girlfriend? All other things being all things being equal, the rocket scientist or the electrician?
Probably electrician, just based off how
The electrician. Even though the rocket scientist can make like 7 times more than the fucking electrician.
He doesn't
And
come
have
in a light.
status. And have status. That's the thing. Oh, what's your husband do for a living? Oh, he works at Rocketdyne. He makes rockets. He's a rocket scientist. Oh, what's you do? Oh, he works at frickin' Frandan Electrical and fucking wires fucking sockets. There's no status in that. I'm not putting it down. I have more respect for that than the rocket scientist. I'm just saying that there's a power play in this shit.
There's always going to be some sort of power play in any sort of like job. Like electricians,
In
they have the
in
power to
society, well, do you agree? Do you agree that in society, rocket scientists is considered more of an accomplishment than an electrician?
in society, yeah, I would agree.
Yeah.
But I wouldn't agree on a fundamental basis because, yes, rocket scientists do a lot, but we also have electricians.
We're talking about what a woman would choose, dude.
I
We're talking
know.
about what a woman would choose. And status, and
But-
money. All things being equal, they're as good looking as each other, they're the same as each other. The only difference is the job that they have. From a woman's point of view, going rocket scientist. Because it's cooler.
It's cool. And little less riskier than an electrician. Do you know what the most common death for electricians are?
Driving to their job.
I was going to say microwaves.
Suicide, depression.
Suicide.
Yeah, also that. But for like on the job death, it's mostly microwave because the transformer's in there. If it's not turned off, then they release a high voltage, high amperage, high frequency.
Are you talking about near field coupling?
Yeah.
Yeah. You know, and you know that this is a whole other thing. I don't want to go down this road, but near field coupling itself, no, it's known about in physics. It's not really worked out. Meaning, so you have electromagnetic radiation. There's near field and far field, but they're all concerned about the far field radiation, right? Photons and all that shit. Right, speed of light and all that crap. Like, think of anything you hear about science, right, is general relativity and black holes and speed of light and all that crap, right? Lasers, phasers, da 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 da. But that's only half the story. That's transverse waves that have left the emitter. But at the emitter itself, like you said, these alternating currents, they oscillate, right? So what will happen is you'll get too close, you'll get within, it's called 1/6 of the wavelength that's being emitted, and you'll couple to it and you'll fucking fry. It'll transfer energy right into your body faster than the speed of light. I hate to tell you, it's instantaneous.
It's pretty instant.
But they don't talk about that it's instantaneous. It's a whole field of science that's freaking just abandoned.
We do need
It's
a
not
lot
sexy.
more research in things. Not gonna lie. Like, I majority focus on biology than anything else. That's the main thing I focus on. And neurology.
Electricians
love
die of
neurology.
AIDS? What the fuck, man?
Hey, I mean, is there AIDS in electricity? Who knows? Who knows?
Maybe you have to take that back, man. Maybe the freaking electricians are getting laid more than the rocket scientists. They're dying of AIDS. I don't know.
The electrician community is going to have an absolute field day with you. You know that, right? As a carpenter.
No, no, let's not go into carpenters' wood jokes. Not going there.
Okay, so Jesse, your problem is that you're stuck in theory too. You've never looked at what the actual data for the study of terrestrial refraction actually shows. Doesn't show the bullshit that you anti-flat earthers say. It's nothing even close to that. I actually found it yesterday. Shit, yeah. Hold on, I'll read something to you. I found this old post. This is from Simulation Study of the Refraction Effects. K. Beckett, School of Surveying, University of New South Wales, Sydney, Australia. The abstract. The atmosphere and optical environment of electromagnetic observations has an unstable and chaotic structure, which is also seen in the refraction effect of electromagnetic radiation. For over 300 years, hundreds of models were created describing the influence of refraction effects on the results of geodetic observation. So far, no universal solution has been found which fulfills precision requirements of geodesy. Short story is, you have no fucking idea what it does. There's nothing to disagree on. There's no model that makes accurate prediction. No one knows what the fuck is happening, okay? All we can do is make qualitative descriptions of seeing shit. There's nothing quantitative. All the quantitative shit I've ever seen shows that what you guys say is 100% wrong.
Well, I recognized in my opening paragraph that we may not agree that there is a possible way to measure drop over distance, but my question wasn't about refraction. It was saying, if, for the sake of discussion, that there was a way to measure drop over distance, would this be a genuine experimental procedure?
Scientific experiment are looking for causes of phenomena. Now, this is a measurement. Using very scientific tools, we're going to try and be very, very accurate.
I'm going to just ask you the same thing I've been asking all you guys, and I have not got a straight answer in 3 years. What is the justification for you thinking terrestrial refraction does fucking anything at all? Other than that's what you read in the textbook, or you read online, or you read on the webpage.
Does anything at all?
Does anything at all? Yes.
You mean like?
We know there's we know there's refraction like twinkling stars, right? Scintillation. Okay. But you guys have gone further and says like it's bent in a direction. Okay. It goes in one either, it gets bent in a curve. There's no evidence for that. There's no justification for saying that. There's nothing. That's what I mean. You guys say, "Hey, man, I hear this, and I'm sure you've said it with your own freaking mouth. Is you guys didn't account for refraction?" And I say, "Oh, how do you do that?" Nobody knows. Nobody can tell me how to quote unquote account for refraction. How do I do that?
Just apply 7/6R like the globers do. It's easy.
Yeah, exactly. There's nobody can tell me how to do that. So if you can't tell me, if you can't say, "Hey, dude, this is how you do it," you don't know what the fuck's going on, and you have no justification for including it at all. So if you have no reason to include it because you don't know what it's doing, I'll just exclude it. Until someone gives some valid substantiation, okay, to some general refractive condition in the fucking air that's happening all the time. It's just a bunch of fucking hot air. You didn't account for refraction. How? How? And when I say how, I mean anyone can make a model and quote unquote account for refraction, but that model actually has to be able to make predictions, right? Predictions. So before you do the experiment, right, you say, hey, dude, this is the weather conditions. I'm going to punch the meteorological conditions into my fucking model. Blah, blah, blah. Okay, this is this far away. We're going to push the fucking button on the camera, and the image in the camera should look like this. No one can do that. You know no one can do that. Or in the reverse, take the picture and then get the meteorological condition, get the picture and be like, okay, this image is displaced this much. Here's the meteorological conditions that existed. Then go check to see if that was the actual meteorological conditions. Then you would have a predictive model. So no one can do any of this crap. And then there's all the other things, the other problems you guys don't want to deal with, okay? Dispersion, where's that? Vignetting, where's that? All the effects we have that we have to compensate for in lens design, because lens design deals with high refractive elements, and that's what you guys are saying, that the fucking air is this gigantic refractive fucking lens. We don't see magnification. We don't see all these other effects that would happen if refraction was going on. Where are those? There should be other indicators other than something that's higher than it's supposed to be, or lower than it's supposed to be, or flatter than it's supposed to be. There should be other indicators of refraction that we could see, measure, all that shit. But I don't see any of these. I don't see it quantified in the scientific literature. I don't see it anywhere. The only time I've ever seen it is the Bricker fucking paper, where he modeled, hey, dude, there should be this much dispersion over these 147 kilometers, and there wasn't any. What are you showing me, Jesse?
Dispersion, chromatic aberration, or chromatic dispersion.
Yeah, we know what it is. Some lenses do it worse than others.
What's the light source?
One is the sun, and the other is a snowmobile headlight.
Okay, yeah. Astronomical objects have dispersion. Okay, terrestrial objects don't. Your what do you call it? Your snowmobile headlight, whatever it is. Do you think that that's white light? Like the sun?
It's a halogen light, so it's not quite as white as the sun.
It's nowhere close to the sun. Halogen emits a single wavelength.
Well, but I mean by halogen, I mean a
so how would you have
filament.
any dispersion, Jesse?
No, it's not a discharge. It's not a gas discharge lamp. It's a hot tungsten black body radiation light source with a little bit of halogen in there to keep the filament from evaporating so fast. So it's a broad spectrum. It's not just a single wavelength.
I do not think that's dispersion. I'm sorry.
Oh.
Well, I mean, there's a blue fringe at the top and
there's
orange.
also red on the side too, right?
Well, the camera's tipped. So if you were to see how the horizon line of the snow is kind of tipped.
There's red on the side of the light, on the right-hand side of the light.
Yeah, there's some lens dispersion.
Why would it be over there? Lens dispersion.
There's some lens dispersion also, but that's going to happen all the way around. The atmospheric dispersion is because of it only happens in one axis. That's my theory, anyway.
Yeah, I'd have to see the fucking full video for this shit, dude.
Oh, sure. It's lanolins. I'll get it for you.
This is only 6 miles. I thought.
Just give me 1 second. I will get you the video. I time-stamped it to somewhere near there. We're near where I got the screenshot, a little before actually. So if you let it play for a few seconds, you should find it. I did enhance, I did brighten the, increase the contrast, but that's all I did.
How do you know what lamp his fucking snowmobile has?
We could ask them. Halogen lights are, I'm a mechanic, so I know halogen lights are very, very popular for that application. And since he was not using like the very latest snowmobile there is, it's quite unlikely he had any gas discharge, light.
Could be a LED.
And it's also unlikely it was converted to LED, but we can ask him, definitely.
Are you just guessing, dude, or so you don't know, you're guessing?
But it doesn't really matter. It's putting out all the colors. I mean, we can see reds, greens, and it met the fact
it
that
looks just like this looks like regular scintillation to me, man. You just cherry picked a frame.
It looked to me like there was a strong predominance of the blue on top, but anyway.
Subjective. I could measure this in something. So why would there even be this type of refractive effect on a frozen lake?
Well,
especially at 6 miles.
If the ice was significantly colder than the air, which is possible on a clear night, the blackbody radiation could chill the ice faster than the air because ice has an emissivity of almost 1. So if the ice was colder than the air and it formed a strong bottom dense gradient, that would be curving light downward towards the ice, and that would be curving the blue light downward farther, which would make the blue part appear higher.
This is what I'm talking about, this curving up and down. What makes you think light does anything like that?
Because light has been measured to go faster in less dense air and slower in more dense air, and because light travels as a wave
That's great. That's conceptual. I'm not talking about concepts. I'm talking about in terrestrial observations. You guys think, so you guys just, look, bro, the conceptual idea is that there's a spherically symmetric atmosphere with a vertical temperature gradient and a vertical density gradient. And by that sheer fact alone, that a spherically symmetric atmosphere with a gradient, light is just automatically going to curve. Right?
I'm not sure what you mean by a, what did you call it? A spherically
symmetric. Spherically symmetric.
I don't know what that means. I know what spherical means, and I know what symmetric means, but
the atmosphere is curving.
Think like an onion, Jesse.
The density gradient is not a straight line; it's a curved path. Remember?
Oh, you mean on a globe?
Yeah, on the globe. Yes.
Okay.
So it's automatically going to curve conceptually. It has to. And in fact, Andrew Thomas Lunds talks about this, is that it would be impossible to have any type of straight line mathematically. Because if you have it completely horizontally, what would happen is that if you had a ray, it would get trapped at the boundary of the density gradient and form a perfect circle that goes around the Earth. Like say you had 30 degrees and 31 degrees, and at the boundary of the 30 and 31, you had a laser and you shot it. In a spherically symmetric atmosphere, it would duct all the way around the Earth, come back to the same place.
Oh,
mathematically, in the mathematical. Listen, I'm talking about conceptually in a mathematical model. So when you start talking about, hey, light's bending down, that's just fucking. That's because you're assuming spherically symmetric atmosphere and a whole bunch of shit. It's conceptual. What's the data say about what light does? You don't know. None of you globe earthers know, because none of you have ever bothered to go look at the literature. The actual literature. When people have gone out and tested it, it doesn't do what you guys think. I'm sorry to tell you that. And you guys spent years arguing about it. What do you think I did? The thing I just read you, Jesse, do you think I just made that up? Do you think I called this chick fucking 20 years ago and told her, hey, write this down? For over 300 years, hundreds of models were created describing the influence of refraction effect on the results of geodetic observations. So far, no universal solution has been found which fulfills the precision requirements of geodesy. So when you sit here and say light would do X, you're implying that you have some universal solution to what the light does. And that you know what it does. And that whatever your answer is of what it does, it's true. It's just universally valid and accepted. Experimentally, no. I'm ripping the whole rug out on this shit, dude. There's no valid justification for any claim of refraction, no matter what it is. Okay, I mean, Jesse, do yourself a favor, okay? Go on Pablo's Dog's channel. Do you know that channel?
It rings a bell vaguely, but I couldn't say I would know.
He's been going to the same spot in the same parking lot for 3 fucking years, and every 3 days taking video and doing a horizontal pan across Santa Monica Bay. Okay? The shit he's seeing is just it's unexplainable observations. Just unexplainable. Flat Earth or globe Earth, dude. Literally, like one of the observations, it's like an inferior mirage of something that's past the horizon, and an inferior mirage of like a double inferior mirage. There's all sorts of crap he's got videos of. And there's a whole bunch of other people that have, like Keith Carmody and fucking, there's flat earthers that aren't in our little circles. They're out there doing observations, right? Repeated, controlled observations over and over and over again, and none of them match any model of anything. There's no justification for any claim that the light should be doing X, Y, and Z, and that then there's have you ever seen any of the data where they actually take the meteorological conditions and then do the surveying and then try to match them to see if they match up?
I'm sorry, I was trying to find Pavlov's channel. Say that again?
It's called Pablo's Dog.
Yeah, there's a bunch of YouTubers that got that name because it was a famous term. Yeah, thanks. And of course, that YouTube hides the flat Earth ones, so it's hard for me to find the correct one.
Okay, there's that.
Oh, thank you, sir. There, I subscribed to him.
Cool. I mean, not a lot of flat earthers even know about this guy. And there's other ones. There's a whole group of. There's Plain Truth and what's his name? There's a whole bunch of flat earthers that just do observations. They're not really into the. I mean, they got YouTube channels where they post their observations, but they're not into debating or going on freaking Twitter or anything or TikTok or whatever. They're just out there just like doing their thing, dude. So there. Anyway, I'll just bring up this one. Hold on. There's one called empirical modeling by trigonometric heighting. That's one study that was done in Greece. Dude, it's even on McToon's. McToon has a refraction section on his website. Apparently, he's never read any of the papers that are in it. So there are 3 or 4 that are on there where they actually took the meteorological conditions while they did their surveying observations, and they never match up. They just don't match up. Like what they observe doesn't match up to what should be with the meteorological condition, according to the way everybody thinks refraction works, should be one thing that makes their observation this other thing. But they never match up. They're just completely they're uncorrelated.
Could you drop a link to that? I would be interested in reading that for sure.
It's probably on McToon's fucking site. Hold on.
Was that the Romanian Rhapsody I heard?
Oops, hot mic and.
Hey, Wild Bill, it's good to see you.
Hey, Jesse. It's better to be seen.
McToon does have it on his page. Moron. Apparently, he never read it.
Thank you.
That's just one. I mean, it's a whole. Jesse, I don't know why you're just discovering this now.
Well, better late than never, right?
Yeah. Here's a graph from it. This is the survey observation and the meteorological observation. Completely unfucking correlated. Then they tried 3 different models to try and fit it, and it don't work. So what do you got against like a laser test, like going out and doing a laser test like 100 days in a row, the exact same time, the exact same place, the exact same methodology, 100 times in a row, some crazy distance. Because like FE core, that's like one of the things like people, it just like goes right over her head. That's not one test all done one night. and to say there's some freakish meteorological condition that allowed it. Well, it happened again 3 weeks later, and their meteorological stations didn't pick it up because they have different weather conditions each time. But for some reason, each time lets them frickin' shoot a laser 40 kilometers.
Well, to me, the first step of any form of measurement is to get consistency. And the laser tests don't work every time. And in
Give me an example where they didn't.
There was actually, if you watch the FE-Core video, there was one where they could get it to shoot over the observer's head, but every time they tried to bring it down to get it to actually directly hit the observer, it would disappear. But
so Jesse, put 2 and 2 together, mate. It goes over the observer's head by 8 foot. It's supposed to be 600 foot or some ridiculously high distance. Oh, wait up. Refraction, I forgot. Yeah, my bad.
Yeah. So the difference between what they observed and the prediction is 2 orders of magnitude, Jesse. You know that, right? You know how large of a difference is to prediction. If you have a prediction and the result is 2 orders of magnitude different than the prediction, there's a problem.
Yeah, I know. I myself have measured circulating ray conditions and even sharper than that.
Circulating ray conditions. What, in your spherically symmetric atmosphere that don't exist? What do you mean circulating ray? How do you know the ray's curving at all?
Well, when I measure an elevation angle to the waterline on a ship at 7 miles and it's 36 feet above where it should be.
That doesn't mean the ray's curving, though.
Well, so how
it just means that the angle of arrival at your camera was displaced. It doesn't mean the ray curved. It could have moved up and down, left and right, all over the place before it entered your camera.
So how could a straight ray that started out below me...
Because light is not rays, dude. And light in the air is... I've never showed you this. I've never showed you the turbulence, the fucking... Oh my God, I'm almost positive I've showed you this, Jesse. I'm almost 100%. Maybe not. Look for something. I'm looking for something. Just give me a second. Look for a graphic. What's this? Oh, okay. So look at the graphic in the chat, the diagram.
All right, scintillation in action.
Can you hear me?
We hear you.
Okay.
Hold on, dude. We're having a conversation.
Do you believe that the Earth is flat?
Wait your turn, dude. Okay. This isn't simply turbulence. All air is like this. It's packed with these bubbles. And what happens is it's the wave front that gets tilted. Okay? If the rays, so the ray approximation model is only good for short distances. Did you know that? It's only valid at short distances. It's a simplification to make for lens design, like the thin lens approximation and all those things. The geometric optics, it's not meant for long distance stuff. anything like that. It's not like I can give you a professor saying that it's just. So what happens is you have light that comes off of something, and there's a wave front, right, that comes toward you. But as it's passing through these bubbles, it's wobbling back and forth. In the angle at which it hits the camera, if it hits the camera tilted like at a 45-degree angle, an object in the distance will appear higher or lower. The ray didn't traverse a different fucking path. It still went to you straight from the source to you. It went in a straight line, but because the wavefront is distorted, it isn't a direct proportional image to what's out there. And I'll show you another one too. It's from another thing. Now these all are from surveying. The first one came from them trying to figure out how to survey in tunnels, because tunnels have the problem where the walls are warmer than the center, so they have a horizontal displacement, and they had to figure out how to deal with that. And of course, they do a bunch of modeling. Okay, so 1 second. Okay, make sure I get the right one. Okay. No, this is from another paper. This is from the dispersion paper. You see how that says centroid shift? So the centroid would be, say you were on a crosshair, say you're on a bullseye out there.
Right.
But it's going to appear shifted because the wavefront. So say you have a bullseye, and the bullseye is a plane, right? What happens if you took that bullseye now, with no refraction, just normal situation, and you tilted that bullseye at a 45-degree angle backwards? That bullseye is going to look smaller, right?
Is the
The
bullseye
top is going to look like it's lower, and the bottom is going to look like it's higher. I'm just saying hypothetically.
like a target in the distance gets leaned
Yeah,
over?
like a target.
Yeah.
Yeah, like whatever. If you're looking at some plane in the distance, its orientation, say it's 90 degree, you're looking at it perpendicular. So the light from that is coming at you. It doesn't stay perpendicular. The wavefront gets distorted and twisted like this, like in this graphic. And then when it arrives on your camera sensor or your eyeball, it's at a tilted angle from when it left, right? So like the bottom arrives closer before the top or some other thing. But these little peaks of the waves, that's what actually activates the sensor or the fucking the epithelial cells in your eye. It's the peaks of these freaking wavefronts, because that's where the energy is. But what I'm saying is, just because something appears displaced, and there's a guy that worked on this for the U.S. Geological Survey called Fred Bruner, okay, and he gave presentations on it because the ray optic model doesn't work, and it's never worked, ever. In 300 years, it's never worked. So he tried to come up with a different methodology, doing the angle of arrival, meaning if something appeared displaced up or down, that meant that the angle that it entered the camera was different. It was at, like, say something originally would be in the center of the camera. Let's say it arrives at an angle 1 degree higher than the center. What is that image going to appear like? it's going to look at whatever it is that was going to be in the center is going to appear higher.
Right.
But it's not actually higher. It's the angle that it entered. It's the angle that the light entered into the camera.
So I'm trying to understand. Are you saying basically that the light took a straight path from the ship's waterline to me, but then 2 feet in front of my?
No, I didn't say a straight. Look, I didn't say necessarily a straight path. It's wobbling. It's moving around. This wavefront is it's like scintillation. It's shimmering. Like these are oversimplifications. What's happening is it'll go into a bubble of one refractive index. I'll show you. I already did show you. Of what actually happens is that hold on a second, because it was in the first paper I posted. What ends up happening is that the light will oscillate around a mean value, right? So you have the straight line value, but as it travels from point A to point B, it's going through these pockets of air and it's moving up and down, right? And these air pockets, these bubbles. So let's say it goes into the air is full of these like bubbles, like in my graphic here, like in the graphic here from the surveying, right? When it enters into one bubble, the wavefront shifts and tilts. Then when it leaves the bubble, it tilts back, but doesn't tilt back all the way. Then it enters another bubble, tilts, and it's doing this the whole time, going from source to receiver, whipping back and forth. And then you're going to catch it at one point in time, and it's going to look a certain way, depending on how the air is, the condition of when you receive that light, the condition of the air. You know this if you've gone and done observations, that you could come back an hour later and everything looks completely different. I know this from my observations. I got a fucking observation of a windmill where you can just see one blade barely sticking out from behind something, and then an hour later, I can see the windmill completely as fucking clear as day, all its blades, everything.
So do you think on that one day that all you could see was one blade, that if somebody had a laser?
It was an hour later, Jesse. It was an hour later. It was the same day.
So do you think at that moment in time when all you could see was the top of the top blade, that if there had been somebody at the base with the laser, you would have been able to see the laser?
Well, no, because the base is behind trees.
Oh, it's trees.
I'm talking about the top of the blade. Like, look, the one where I could see the whole thing, I could see the hub in the three blades. The one where I couldn't see it, all I could see is a blade faintly sticking out from behind the trees.
What
and there's also radio towers which I could not see at all at first, and then when an hour later when I took the pictures again, I could see two radio towers. They're tall ass radio towers. They're fucking hundreds of feet tall. They're like twin towers that I couldn't see at all.
Okay, so
I did observations. So there was a buoy, and it was rocking back and forth, right? So the top of it was rocking toward me, and then away from me. And when it rocked toward me, I could see it, and then when it rocked back, it completely vanished, as if it was like disappearing behind a fucking wall. It wasn't bobbing up and down. It was rocking back and forth toward me and away as the waves pushed it, right? The waves push it and it rocks forward, and then it goes in the trough and then it rocks back, right? So it's rocking back and forth. And the tip of it's going into whatever, and it would disappear, and then it would rock forward and then it would reappear. Then it would disappear, then reappear, then disappear, then reappear. It's very strange. Anyway, the point of this is this curved fucking ray shit, there's no evidence for any curved rays. Okay? The curved ray claim is the Earth is a globe, there's a spherically symmetric atmosphere, right? So the ray has to be taking a curved path to go around the globe. There's no evidence for that at all. There's no justification for that. It's just like Earth's the globe, that's what must be happening. That's it. That's the only thing there is to that.
So where did the 2.5 arc minutes of upward angle come from?
I just told you. I just told you. You don't understand it, dude. It doesn't mean a curved ray. It just means the path is bouncing up and down, dude. Okay, Jesse. Can you draw a sine wave?
Yes, approximately.
Okay, and where the camera sensor intersects that sine wave, right, is going to determine where it appears on the sensor. So you might intercept it at the peak and then it'll appear higher, or you intersect it at a trough and it'll appear lower, right? That's not a curving line, though. It's a straight line. Well, it's not necessarily a straight line. It's a straight path that's oscillating around a mean value. The mean value would be the straight line, and it's oscillating about that straight line, deviating. And all the evidence says that this is the case.
Oh,
all the measurement evidence.
So you're saying that, tell me if I got this right or wrong, you're saying that the path of light coming from the ship's waterline to the camera was following kind of a sine wave pattern up and down, but otherwise basically straight, and I just happened to be at a portion in that the length of that sine wave that caused me to look up at it, and if I had moved forward or back, a half a wavelength, then I would have seen the opposite angle.
Yes. Now that's an oversimplification. Okay, obviously it's not a fucking pure sine wave.
Well, what's the wavelength of this sine wave? It's steady.
Depends on the size of it depends on the size of the inhomogeneities of the air. You see the I showed you these. Did you not see these? These little bubble graphics. These don't come from me. These don't come from me. These come from the surveying literature. I didn't make these graphics, dude. I'm not making this stuff up. This stuff doesn't come from me.
So, what would be causing the specific
turbulent cells make the wavefront oscillate around a mean? Okay, I don't know else how to describe it.
Is it the density of the air in the cells, or is
it's changes of temperature, density, and they're in motion.
Fuck.
And the thing is, the size of these, it isn't going to be like one size. There's going to be all different sorts of if you could see them, it would look like a foam, right? The air is more like a foam, but there's all sorts of meteorological conditions that affect it, right? Wind, fucking temperature of the ground compared to the fucking air, crosswinds. The point is, it's that the spherically symmetric model has no justification. That's my point. That's my only point. There's no justification for K values or anything like that. What is the K value? It's, hey man, this thing is up 2 inches. And the only way this would be up 2 inches is if the light ray was this much bigger than the fucking globe Earth of 3,959 mile radius. So we're going to come up with a value that's the ratio of that 3959, and we're going to say the light ray curves that much. But that's just bullshit, dude. The light ray didn't take a fucking continuous curved fucking path. They just do that as a simplification. And they even say it, that it's a simplification. But do you know where that's got them, that methodology? Fucking nowhere. Because like I read earlier, for over 300 years, hundreds of models were created to describe the influence of refraction effects. So their methods don't work. You understand that you guys, I don't know why I keep saying you guys, but global earthers, or the anti-flat earthers that argue this topic and bring up refraction, they're literally bringing up a failure to justify the globe. No refraction model can make any fucking prediction, period, other than like Snell's law on designing lenses or something. I got another one. Hold on. What's the name of that? Jesse, you ever see this one?
Let me look. Oh yeah, Taylor was showing that.
Yeah, you see these values? You know, for Mgon, you know how big of a degree for Mgon is? Well,
For
one
Miller
Mgon
degree?
is 0.0009 degrees. The largest deviation in this data set is 4. So that means the largest deviation that they measured as far as an angle of arrival was 0.0036. Now, do you know how much that is at 25 miles? It's like fucking 8 inches. Right? So, but the most important thing is, remember how I said is that it oscillates about a mean, right? If you look at this measured vertical angle, you see the values. You have the 0 value where there's no deviation, and they oscillate about that. They're not skewed to one side. They're not skewed to the other side, because if it was a continuous curve, they'd be skewed in one direction. Right?
I'm not sure I'm following exactly what you're saying.
The 0 is the straight line path. When it says where the blue lines, right, are the measurements of the angle of arrival of what they're measuring.
The absolute angle or the relative to the mean?
The angle of arrival, the deviation of the angle of arrival from where it actually is, from the straight line.
The
0 is no deviation.
From total station position 1 to target 1?
Yeah.
TPS 1 is the total station position 1, right? And then T1
they have more than one total. They have more than one device.
Right? And they also have more than one target, right? And T1 is target 1, right? So are you saying that total station 1 and target 1 were at the same geometric elevation?
No, they're not at the same geometric elevation.
So one's higher than the other?
No, very. Give me a second. T1 is T1, I think, is a retroreflector.
Yeah, all the targets were retroreflectors, I believe. Left by some previous project.
Yeah. Anyway, the point is that the straight line is the zero. All these the measurements in totality oscillate about this zero. If the Earth was curved, they would all be skewed in one direction.
Why would they be skewed in one direction if Earth was curved?
Okay, because you'd have refraction curving the light, right? So you'd always have a deviation in the angle of arrival. Always. There would never be a straight line. It wouldn't be. You see how this is symmetrical? There's an equal amount of subrefraction, if that's what you want to call it, and refraction about the zero. It's evenly distributed.
Are you saying that the zero on this, the 0 milligradians on this chart is
I'm gone, dude.
Jesse,
I'm gone.
if there's a straight line, that's the difference either side of the straight line. If you think you live on a ball tard, the light incoming would predominantly be on one side of the line. You know this. You're acting dumb for some reason. Please stop it.
No, it's just it's been a while.
I thought I wasn't explaining it good.
It's been a while since I read the paper, and I'm trying to remember the context because all he dropped here was the little one screenshot. And if I remember correctly,
Post the paper again if you want.
The paper wasn't about Earth curve or lack of Earth curve. It was about variations to the vertical angle, and so they actually measured the vertical angle.
Yeah.
And then they.
That's right, Jesse. They measured the light, dude. I don't care about the fucking Earth curve. I only care about they're measuring refraction on whether it exists or not. That's what we are trying to establish. Is it justified of saying there's fucking curving rays, dude? If there was a curving ray, all the most of the data would be skewed on one side of the fucking zero. Because the angle of arrival would be higher. It would always be higher. This isn't like this is the only shit, dude. This is what I'm talking like. Remember what I started with? You guys have read the textbooks, read fucking shit online, never looked at the academic research, and even if the papers that exist, very few of them have actual measurement data in it. And then if you actually sift through the fucking 1 in 100 papers that have actual fucking empirical measurements, none of them, and I mean none, match any fucking goal prediction. None. Zero. And I'm sorry that might bust your bubble, okay? And I appreciate you sitting here and listening to me fucking rant, but the fact is, I'm at the point, if someone says to me, you got to account for refraction, I'm asking why. And people need to justify why I should account for it, and just going, because it says so in the fucking textbook, ain't cutting it. I want the data, I want the evidence, I want whatever that says, yes, you should count for refraction, because yes, this is happening all the time, because we've measured it. Here are the measurements. Here's the data that shows, yes, this is happening all the time. Yes, here's the measurement of curved rays. Here's the, like, there's none of that shit. There's none of that. But fucking, dude, we've been arguing this topic for a fucking decade. And some of the fundamental things about this topic that's been argued has never been established to even be true in the first place. Fucking arguing about refraction 1,000 fucking times. Jesse, I'm gonna give you a newsflash. I got into this topic because I was doing work on refraction, specifically negative refraction, not the run-of-the-mill refraction, way more technical level than this shit. And then the Chicago skyline, I saw that shit, and they're like, "This is a mirage. This is refraction." Dude, I've been studying refraction for fucking nearly 3 decades. And I just hear fucking people say this shit that doesn't, there's no evidence for any of this shit. It would be cool if there was, but there ain't. It's just something you guys just say, you're an account for refraction. Flat earthers never account for refraction. Your calculation's wrong. You didn't account for refraction. Okay. Here you go. You account for it for me then. You fix our math. No one will ever fix our math. No, dude. They're measuring the angle of arrival of the light, dude.
But
what aren't you getting, dude?
Well, that's what I'm trying to ask about is
elevation means nothing. Don't say elevation, because the device is pointed straight at the other device. There's a straight line, imaginary straight line between each of the devices.
You have a clear line of sight. They're just measuring the angle of arrival and how much it deviates.
So was that measured angle as it was read by the instrument within a plus to minus 4 milligradient angle?
They're making continuous measurements. You understand? Continuous measurements. They're constantly. I don't know what the polling rate was.
Every few minutes, I think, except they would take a few minutes off to do a self calibration on each unit. But what I'm just trying to understand, if you're saying that 0 degrees was the actual measured angle of arrival for total station 1 when pointed at target 1.
Well, there is no angle if it's 0 degrees. What do you think they're measuring, Jesse?
Well, I think they measured the elevation angle to T1 from TPS1 repeatedly, and of course it's T1.
They're on top of a hill looking down into a fucking hole at a landslide across the way.
Okay, so they've recentered these measurements to center them around the average,
you see,
right?
Look at figure 3, the top image of figure 3. They're on top of a fucking hill looking down, okay? So they got a couple things here. 2, 1, 3, 1, 2, 3, and 4. 4 is a vertical tower of thermocouples where they're measuring the temperature.
Yes, that's beautiful.
The vertical temperature profile. Right, so they're just pointing down into the landslide, dude, and measuring the angle of arrival that the fucking laser hits them, that the laser hits the total station. That's it. It's not fancy, dude.
Okay, so I think we agree that the total stations were pointing down significantly more than 4 milligradians, right? At their targets? At least for target 1?
Yeah, it doesn't matter what they're pointed down. They're only measuring the light. They're shooting a fucking laser off of something and then measuring the angle that it comes back. It knows the direction that it's pointed, right? And they can measure the direction that it picked it up.
So I guess,
Jesse, if you fucking shoot like say you had a pistol, okay, and you fired from the hip, the bullet fucking ricochets off a piece of iron and hits you in the eye. Okay, the angle of arrival is higher. You know that the angle of arrival is higher than when it fucking left your gun. Okay.
Because the shrapnel or the piece of metal is falling
Because
as
it left at hip level and then arrived at eye level.
What's the
So they're
significance of it?
Because they're just shooting straight at the prism, and then measuring the reflected light what the angle was, where it should be versus where it is, or where it appears to be. These are like infrared, dude, bouncing infrared light off of reflectors.
Right, yeah, most of my total stations also bounce infrared light off of reflectors. One of them uses a visible red laser, though. But, so are we in agreement then that the actual elevation angle measured by the instruments to the targets
mean nothing? That's what we'll agree to. They mean nothing. We've already established that.
Dude, I don't care if they're looking fucking down from the top of the Empire State Building.
Well, I guess I don't understand
This
what
would
you're
be
arguing.
even worse. Look, bro. This would be my argument. My argument is here's data, right, of the very little data on refraction measurement data we actually have, right? Because if I ask you to post some, you won't have any. You know that, right? You'll have none.
Definitely not this much.
I posted 2 things. You got 1 thing then? I mean, what the fuck, bro? It wouldn't even matter. Whatever you posted, I've already read it. I guarantee it. Okay? My point is that we should be making claims based upon the empirical evidence, not based upon theory and speculation. Okay? And then we go, okay, let's look into the scientific literature and see what's actually been empirically tested and verified. And then you look at the data and it's nowhere fucking near the effect that they say that is said to happen. It's nowhere near it. It's not even close. But people are going to tell us there's these special refractive conditions that can happen that can make the horizon fucking appear 10 times too far away, that can do all sorts of crazy shit, right? Fine. I have no problem believing that. If you can substantiate that it's even possible, which nobody can do. Certainly not fucking possible to happen every other, every single time we go out. Goddamn flat earthers are so lucky. Oh my God, there's the horizon again 10 miles away. God, am I lucky? Jesse, if you actually are going out observations, I know you've made the long distance observations that bust the globe. You just don't show them to nobody. Just as a sheer probability, dude.
Oh, I've showed them, and I even showed the ones that show concave. No,
they don't show concave, man. They don't show, dude. No, dude. And things are just getting displaced up and down, dude. I don't know how else to describe it. Like, I don't know if a magnifying glass does this.
I have one of those triangular straight glass prisms that's 6 inches long, and it does that. I can hold it up and look through it, and depending on which way I have the pointy edge, it can make everything look higher or everything look lower, as well as rainbowy.
Yeah. Now imagine in between you and something else, there's like 20,000 fucking prisms, and they're all moving around. But they're only moving around a little bit. Okay. Now you're going to end up with an image that would be displaced 1 second one way and then displaced another second another way. I mean, stars twinkle for a reason.
I did not tell you to go southwest. Okay, you just sat here and told everybody that the flight distance is going southwest. That's not pure north to south. That's why you
Well,
ain't
yeah,
going.
because you brought out the actual coordinates and you weren't lying about any more about the
You were just wrong
north
about
to
how
south.
the experiment is being
You said it
done.
was 690 miles from Calgary to Salt Lake
You
City.
were
What am I supposed to
wrong.
believe?
You keep going back to the flight distance and the driving distance, which I told you we have to ignore because that's not pure north to south.
So then,
I
how do
told
we
you that
measure
when I
690 miles if it's not pure north to south?
If it's pure north to south, it's not 700 something miles like you said. It's 690.
How do we know that?
How do we know that?
Hmm? What,
Well,
what measurements of 690 miles over that terrain do you have?
because we're doing like a perfectly straight line, right? We're not going southwest, right? Do you want me to do the math?
No, I want you to give me the
Can
measurement.
I ask you a question? What's 10 times 69?
690.
Ooh, exactly.
Yeah.
So this is
What's 1 plus 0?
So everything I told
What's
you on
1
the
plus
globe
0?
model is 100. This is all the globe model, buddy.
What's
It's
1 plus
correct.
0? Come on, man. I answered your math question. You can't answer mine.
So 10 times 69 is 690.
What's
So
1
if I
plus
go
0?
if I go pure north to south from Calgary
What's 1
to
plus
down to
0?
Salt Lake City on the globe model, it'll be 690 miles. There you
What?
go. Boom.
Surely there's got to be somebody
Done.
else to talk to other than this guy, man.
10 times 69 is 690.
This guy can't even answer one question for me.
But no, you fucked up when you actually Googled it,
I
and
didn't
you
fuck up.
fucking said that flight was going southwest. There is your problem. That's not a
You
perfectly
told
straight
me it
line.
was north and south.
Yes, I didn't say southwest, did I, motherfucker?
No, you said north and south, and they're not north and south.
Exactly.
They're not on
You
the same longitude. You lied.
The 700 something miles you got is the flight distance,
You
right?
you
That's not a
said
perfectly
from
straight line
Calgary
from
to Salt Lake
Calgary
City,
down to Salt Lake
Utah,
City is what I'm trying to
is
tell you,
690
buddy.
miles because they're 10 degrees from
Is that
Polaris.
the flight distance though? Like what you were talking about, like the 720 miles or whatever you said. It's the true straight line flight distance, right? But that's not how
Is it?
Eratosthenes did it. Did he fly a fucking plane? Or did he just go pure north to south?
No, is it fucking a straight line? Is it 690 miles fucking from Salt Lake City to fucking
Because
Calgary?
on the globe model it is. Because 10
Okay.
times 69 is 690.
Okay. From Salt Lake City to Calgary, I got you.
Yeah. And if you go 690 divided by 10, that's 69. So for every 69 miles you travel, the North Star will deviate by 1 degree on the globe model. There you go.
Okay.
We just did the
What's
math.
what's 1 plus 0? What's 1 plus 0?
Who cares?
Exactly.
What's
You
1
got
times
nothing,
0?
dude.
I tried to tell you, man, you were doing it wrong. Okay.
Oh, okay.
I tried to tell you. Why did you just say, what am I doing wrong?
No, you lied.
I told you 1,000
You lied.
times.
You told me
Ignore the
Calgary
driving distance and
and
the flight
Utah
distance.
were directly north and south. What's the distance at 690 miles?
You got that. That's the flight distance. I'm looking at it. Okay. And that's
That's
the reason why I asked
690
you the
miles
question,
flying distance?
which way is the plane flying when it takes off from Calgary down to South? And you
It,
fucked
it's
up by saying
690
southwest.
miles. It's 690 miles flying from Calgary to Salt Lake City, Utah.
And if you're flying,
Okay.
I told you
You
to
show me,
ignore that though.
can you show me the flight path
I
that
wanted to do it the
says
way Eratosthenes did it,
690 miles?
where he went straight purely north to pure south, right?
He
A
didn't do
straight
that. He
line
didn't
down.
do that.
Yes,
What longitude was Syene on, and what longitude was Alexandria on? You're a fucking liar,
do
bro.
it.
You're so lucky I don't have fucking.
You're crashing out now. You're
No, I'm not. Look up Syene and look up Alexandria. They're not on the same
Oh my
longitude.
god. Yes, he did, bro. He did it between two
No,
cities.
they're not. They're like 2 degrees
We are
off.
doing it exactly the same way he did it.
No, you're
From north
not.
to south in 2 cities. You want 2 more cities?
Bro, they're 2 degrees apart from each other. Actually, they're closer to 3 degrees apart from each other on longitude. I bet you didn't know that. I bet you didn't
Well,
know that.
on my model, I'm
On your
correct.
model, just go look. Go find Syene and go find Alexandria and then look up their latitude and longitude and you'll find out they're not on the same fucking longitude.
Hey, is the 69-to-1 ratio supposed to be like globe proof or globe math?
If
That's what he said.
you do it the way Eratosthenes did it, like just going from north to south for every 69 miles, yeah, the North Star will deviate by 1 degree or whatever.
Cool. What's
On the
the
globe
common
model.
denominator? What is 69 a common
Cares.
denominator of 316?
Nice.
No, it's not a common
I'm
denominator
fucking
of that.
tired, bro. I'm fucking tired, bro.
Yeah.
This guy didn't understand he
So
was doing flight distance. He fucking
yeah,
Googled it and I told
no,
him to
he did straight line math and it actually works out because
no, it's a
16,
straight
16 and
line flight
69
distance.
is not a common denominator of 360. And what's pretty hilarious is he gave you the right number. It's about 720 miles. Using the same formula, if you use a ratio of 72 to 1, then you
It's a
actually
straight
end up
line.
with
That's a flight
720
distance.
miles. 72 times 10 is 720 miles in straight distance.
708.
And
It's 720. Yes, if you're going like
72
diagonally
times
between the two
5,
cities, which is what he said, right?
72 times 5 is 360. So that has a common denominator in order to make a sphere. You have the
Okay.
wrong ratio. And
No, I
if you use the right ratio, it actually works with the distance in between the two cities and gives you the proper mileage. But feel free to run around yelling 69 while everybody laughs at you.
Not 720 miles the way there. It's not the way the experiment's supposed to be done.
I just don't know how you're supposed to turn 69 into 360 because it's never going to happen. And this is like, there's no common denominator, dude. You're talking about globe math and you don't have a common denominator to start. You'll never finish the problem. What are you doing?
Do you know what 69 times 360 is? What's 69 times 360? You know it's
What does that matter?
24,840 miles.
So then that math is incorrect.
Well, yeah, because we're not on a globe with that circumference. So, I mean, it would be.
Wait. Is it 24,840 miles? The 69 times 360. Isn't that the circumference of the globe model?
Yeah, dude. Okay, but here's the problem. Yes, the math matches the model. The model doesn't
Whatever.
exist in reality, so you can't expect math from the model to work in reality. That's the problem
I just
you
showed you that
have.
it works in reality. I went on
It
Google Earth
it
and
literally
did like
doesn't, and I
I
just
did
showed
like
you how
I
it
did a
actually
per north
does,
to south.
and how you have the wrong measurement,
I
and
just
how your
showed
math
you.
doesn't work,
I just
and if
showed
you
you it
actually
worked in
plug in the
reality.
correct ratio, that the math works, and you're not
Hey
willing to
buddy,
listen to that.
I said
So
every
I'm done,
69
man. I'm
miles
done,
you
man. I tried. I was nice, and I'm just gonna leave you to founder from now on. You don't hear anything else from me.
Okay. Thanks for the debate.
Why is everyone in here muted?
Welcome.
Because they like to do this stupid ritual. Oh shit! They like to do this stupid ritual where they don't talk.
Because is it because they're retarded or what?
Most likely.
Are they standing together in solidarity?
It's because I just bodied them.
That's facts, dude.
Oh, did you just cook their shit and now they all mute up?
Yeah.
They have to reconvene. They have to say, "Damn, he just walloped our shit. Now how do we come
Sheepdog
back?"
just got fucking walloped.
What are you gonna do
boy.
about that, man? You just got walloped.
Yeah, dude, you got mollywopped. You got walloped. These niggas ate a can of spinach and
Yeah,
uppercutted you.
You just gonna tolerate that, really? What are you, a bitch?
Anyways, if they think the Earth is flat, they can't even describe flatness. Flatness is like nomologically impossible. Anyways,
What?
huh?
You believe in
Huh?
gay? You believe in gay Earth too? Like flat and gay?
Let me guess. You think the Earth is in the shape of a penis?
Yeah,
Like
go ahead,
dick
debate
Earth
them. I'll just mute. You guys can mute, debate these guys. Come on.
in the shape of a dick.
Yo, bro, why don't
Yeah.
you debate? I'll go on mute. You can debate them if you want.
Be honest, man. Like, don't joke around.
Anyways, the argument goes like this, as follows. If you're a flat earther, you're retarded. You're a flat earther.
Yeah,
Therefore, you're
like you think do you think the Earth is like a donut shape? Like at this point, like it could be anything. With this level of logic, like it could be okay. So the Earth is a donut. It's a pizza shape. It's a fucking pear. Like okay, this is like unfalsifiable. Do you realize? Do you know what unfalsifiable means?
Yeah, it
Like,
means it's unfalsifiable.
like your position, like there's no way to prove it. So
It's
it doesn't mean
unable to be falsified.
anything. Because every piece of evidence here, you're gonna say, "Oh, NASA lied about it."
But do you know what re-unfalsifiability is?
What?
Yeah, that's true. Holy shit, bro! It's flat. The
I
cosmolification.
re-unfalsified it.
My meter is actually rising now. My cosmology meter is rising.
Oh, he knows about cosmification. What?
Oh no, it's flattening the Earth. It's gonna flatten the whole
Bro,
planet.
bro's really
like
up on his
Beavis and Butthead in
philosophy.
here.
Too strong. You gotta shut it down, man.
Bro's really up on his philosophy. He knows about cosmification.
You gotta cosmify the planet.
He studied cosmology.
Yeah, we're gonna cosmify it, and then it's gonna be flat. Don't even worry about it.
Imagine that to be the cosmology of Quasimodo.
Oh my god.
We are gonna flatten that shit.
It's very easy to flatten the Earth. You just set K to 1.
Oh my god. I'm dead.
Nah, man. I've been to the ice wall. I get it, dude. I understand flat Earth. You know,
I've been
there's
to
an
the
ice wall, and then there's like a firmament or whatever the fuck. I don't
I've
know.
barely
But
left my home state. This dude says he's been to the fucking ice wall.
there's a fucking ice wall, and NASA is like blocking it, and telling you that you can't visit it because they're using anti-ice wall technology.
Fucking anti-icers.
Yeah. Ice is fake. The moon is a hologram, also. And the Earth is flat. And ice is fake. Ice does not exist, and gravity does
These
not.
guys should change. Somebody should start a room called Gay Earth.
The Earth is
That's
gay.
funny. That's funny.
Sorry, man. Sorry to break it to you.
Flat earthers set up shop in some fucking park to argue for flat earth. Some gay earthers pull up gangbanging. Shut their
You
shit
guys,
down.
you found the tip of the iceberg, but then at the
The
bottom it was
tip,
gay.
wink wink,
You thought it was
because they're
flat.
gay.
Nope. Yeah, it was gay. It wasn't even flat. It was just gay. And they didn't even know.
They're fucking.
The tip of the iceberg is flat. That's the thing.
Flat.
But the earth is definitely flat. In an absolutely non-retarded way. That is factually true according to heterosexual males.
You probably didn't even know space is fake.
Space is also fake. Actually, gay people are fake. They're actually flat.
Okay, but what he
It's for
says
a
is
real simple
not
reason,
true
too.
when he says that we orbit around the Earth.
He doesn't know that to be a mathematical fact.
You don't think so?
This is a geometric. How would he know?
Well, I can pull an app out of my phone right now and
I
tell you
said,
when the ISS is going to
the app
orbit my
doesn't tell me
house.
how you would know, though.
Oh, but it does the math, and the math that it uses
How
is
do
based off
you
of the
know what it
globe
does?
Earth.
You don't have no idea what it's doing behind there.
I don't need to see behind the curtain to know that it works because I can verify that it works.
So what? Lots of things work.
Great, and you don't need to peer behind the curtain of an elevator to justify getting on board an elevator, right?
Epicycles work to predict the positions of planets. So what? But you don't think the
If you're
epicycles
making
are really
claims
happening?
about how the elevator works, bro,
Can't even
yeah,
hear
it
you.
does matter.
Epicycles. Epicycles was the old way of predicting where the planets are. It works better than the current Keplerian model. It works. Is it true?
Okay, give me the app that uses that method and not the globe Earth
Every
method.
planetarium in existence.
Hello, can I ask you?
Every planetarium, the position of planets in the planetarium, when they project the planets onto the fucking dome, they use the epicycle Ptolemaic model to do that.
Okay. When you project something onto the ceiling, it's a little bit different than what's actually happening on Earth, right?
How do you know that? It's the same view.
Because I can use these apps that aren't projectors. I can use these apps and they predict the future. Whereas a planetarium, it doesn't matter where they set up their hologram or their projector system.
Have you never been to a planetarium?
They're not predicting what's going to happen 1 second from now.
Yes, they are.
Okay.
The Ptolemaic model was used for centuries to predict where the planets would be seen in the sky.
Okay, but you're arguing that these planetariums have some analog model that the projection is based off of.
Because they can just
No,
make
they
it out of
don't.
gears. Yeah, they
No,
do.
it's all digital.
The one that's literally
It's
down
digital.
the street, dude.
They're not projecting from an analog model.
Look, it was
They're
made by
projecting
MIT.
from digital images.
No,
of a
it's
plane.
not, dude. You're wrong. You're just talking shit. There's one literally fucking down the street at the Omni Mugen fucking theater at the Museum of Science down fucking Cambridge Street. You don't know what the fuck you're talking about. You're a bullshit artist.
You're projecting off of analog
You are
models.
a bullshit artist, and I am calling you out.
Is that what
you
they're
are
doing at
a
your theater?
bullshit artist, lying fucking
They're
snake.
projecting off of analog models.
No, they have a
what you wanna get
literal
out?
physical gear system. Physical.
Physical gear system. Good for
Physical
them.
gear system. Yes, that's right.
That's great. And do you think that there's gears tied to Earth, Mars, the Moon, and the rest of the solar system?
Your argument was it works, therefore it's fucking true, dude. It works,
I'd agree
therefore
that
it's true. This is called a reduction to absurdity. So this would also be true.
Okay.
That the
By
Ptolemaic model is
definition,
true because it works.
these gears,
Are
if
you
I'm
slow?
assuming as if they're as rudimentary as they are not true. Whereas
Why not?
these
They work.
these software programs are. So my point is,
How did you determine that?
It might be true, these gears might be true today, May 17th, 2025.
God damn it, dude.
But a year from now, the moon's position relative to the Earth is probably not true. I don't think that these observatories, or I'm sorry, these
planetarium.
What did you call them? Thank you.
It's a planetarium. Did you
I
just
don't think they're going to be. They're not trying to represent perfect, true life. When I'm talking about these apps, they are, and they do.
You've never been to a planetarium. They will go back 4,000 fucking years and tell you what the sky goes like.
Planetarium.
Okay, but they can give you any time and date and show you what the
when
sky
they do
goes
that,
like.
they're using computer programs.
They're not using a computer, dude.
They're not rotating an analog geared device back 4,000 years.
Yes,
they're not
they
doing
are.
that.
Yes, they are.
You're full of shit.
Dude, I'm not full of shit.
Can you imagine that model that in your head, the model that the place down the street from you fucking has? Can you imagine that model rotating 4,000
It has
times?
gears. You not know how gears work?
Oh, okay. So Gears makes this a magical analog system. Please send me a link. I'd love to see it.
He's just gonna
It
hand
must
wave
be a
it.
work of art.
It actually is.
Which is speed of the.
Each year is the motion of the planet, and all they do is turn it. And the motions of the planets happen over and over and over again. In the precession of the equinox, so they just move the celestial sphere, they rotate it against the background of the planets. The planets are always in the same place. The only thing that changes in the back is the background star. You don't know what you're talking about, bro. You're out of your depth.
Yeah, Muse, we don't allow incoherent nonsense or strawmans to be representing our community. We work on empiricism, logic, and so we test the claims. We don't just believe the claims. That's your side. Remember that.
We're more than happy to unmute you if you're willing to engage in a proper conversation. But don't be disparaging and don't come at this like a bigot.
And don't pretend you're one of us and don't try to speak for us. Just speak for yourself.
Yeah, that clown wheel crap, leave it at the door.
What was this experiment that you did, Indio, that the last people were talking about?
No experiments.
What?
So what Indio did, you can just scroll up. I'll give you the timestamp, and you can have a look at what he did.
I'm here. What's the question?
What was the experiment? You want to know what experiment you did, Indio? I said it was not an experiment.
Yeah, I didn't do any experiments, man.
Then what were you guys talking about?
Observations and measurements. Those aren't really experiments. Experiments are for natural phenomenon. And they determine cause and effect relationships. So just measuring something, like if you went to the doctor and they measured your height, that wouldn't be an experiment, right?
True.
Yeah, so we're just doing measurements. That's it. We're measuring to see if the Earth, measuring the distance of the horizon.
Okay, cool.
And to see if it matches the globe prediction, which it does not.
So where is that?
According to the globe mathematics, from my observation height of 15 feet, it should have been 4 miles away.
No. I'm asking where's all the data, I guess. I don't know. The video, did you make it?
In the side
yeah,
chat?
you can scroll up. It's in the side chat.
Yeah, I just tagged it. It says here, and then just click the attachment.
Yeah, or you can go to our home server and scroll down. There's A to C, a ton of data for you to go through.
Yeah, but this particular one is in the side chat. Obviously, this isn't the only thing we have.
You need to charge your phone, Indio.
Why is that?
You're at 8%.
What's wrong with my phone? Oh, well, it was, it was freezing out, man. It was killing my battery. I mean, it seemed like 40 degrees marinetraffic.com, yeah.
What is that? Is this just show, is this talking about boats or something?
It tracks the boat position.
Position of boats, okay.
Yeah, so this particular position, hold on 1 sec. These particular positions, when they're in Boston Harbor, their position is given by a radar station in a place called Gloucester, Massachusetts. There's a radar station that tracks all the boats that are out there.
And then this second picture, what is this from, like Google Maps or something?
Yes, the red circle is where the horizon. The red circle is where the horizon should be, and the line is in the pin is where the boat was. according to the coordinate in the aforementioned image. So there's a coordinate in that marine traffic image,
Yeah.
and that's the coordinate position in the pin.
Gotcha. And then that's the position of your camera, 10 feet above sea level.
15 feet, yes.
Or sorry, 15 feet. And then what's the next one? What is, can you explain
That's
this
a
to me?
buoy that took the temperature data that's in the line of sight in the video that's further down. That's a USGS water buoy or NOAA water buoy. So it measures the air and water temperature every 8 minutes or something.
Okay. Where does that one picture show the position or say the position of the buoy?
The Google Maps.
No. In I guess the fourth picture, one of the weather buoy, the temperature one.
Yeah, that shows the air and water temperature.
Right, but you said you saw it in the video.
Yeah, the actual
How
buoy.
do you look at its position?
It's right in the line of sight. It's right in front of the boat.
I know, but how did you determine how far away it was?
I don't need to know the
On the
distance
map?
of the buoy.
Okay.
The buoy's unimportant. I only got the picture of the buoy because of the air and water temperature.
Okay, gotcha.
It was just a coincidence that it was in the line of sight.
Okay, sorry. I thought you were. Okay. Heard. Yeah, I got air temperature, water temperature. Okay, cool.
Yes.
And so you were tracking this to try and figure out the conditions of the air around above the sea. Right?
Yeah, so I planned this for like 2 months. Well, I was looking for 2 months for a day where the air and water temperature were the same to go do an observation, or nearly the same.
Is your video in black and white, or is this?
It's infrared.
Oh, infrared. Okay, cool. Yeah, so I see 3 objects, or sorry, 4, I guess.
Yeah, 2 of those are lane markers and one's a buoy. So there's a shipping lane that crosses this, that goes left to right across the screen. And they have lane markers. So there's the buoy and the 2 lane markers.
Crap, you're seeing even more than you should see.
So you're saying at 3 p.m. you were able to, is when you took the video at 3 p.m.?
It's between 3 and 3:15, somewhere in that section. Because when I finished, I took a picture of a clock, which is further down. Clock that's right there on Revere Beach. Which is coming quite fucking useful for some reason. How do we know you were there at that time? Yeah.
I've really never heard any Globers ask these same questions about their own pictures, though. That's weird.
Yeah, I know. Here's a, and that, like, you know, like the blue marble, the 72 blue marble, it's actually a dispute within Apollo, you know, moon landing nerds, when that picture was actually taken, because they can't figure it out from the transcript when it was taken, because they never indicated it. You know, they got transcripts of like what they're saying inside their little studio. I mean, on their way to the moon. Yeah, so it's a dispute among Apollo enthusiasts for the timing of that picture. So yeah, they do dispute it sometimes. Now, the key thing about me getting the air and water temperature the same is that any refraction effects that they say exist have to be minimal. So I did everything possible to minimize any effects of refraction, if there is such a thing, doing anything, by using A, infrared, and B, doing it at a time when the air or water temperature is nearly the same.
What do you mean if there is such a thing as refraction?
If there is such a terrestrial refraction, that's what I'm talking about. That the specific terrestrial refraction that they say bends light around a ball. That is horseshit.
I don't think people make the distinction between refraction and terrestrial refraction, but I see what you're saying.
Well, that's because that distinction doesn't fit the propaganda rhetoric that they do. Because if you say there's no refraction in these observations, they go, you don't believe in refraction? Now, there is a general phenomenon called refraction. But that's not what this is. Okay? What they're saying is a specific type of refraction, a specific type, a specific condition that creates it. i.e., there's a density gradient that's curved. And because there's a curved density gradient, when light passes through it, it automatically curves around the ball, making the ball look flat.
Well, that density gradient is it would be the air.
Except those density layers are flat.
Yeah, but it has to be a curved density gradient.
Is that right?
Yeah.
So light passing through two different mediums of different density, even if they're
There's only one medium,
parallel
dude.
Yeah, but we're talking one medium. We're talking about air.
I know, but medium of a different density and temperature, doesn't that change it?
Well, what they're
Wouldn't
claiming
water
is
like
that,
if you? So I know what you're saying. If you go from air,
but density is like, but density. Okay, let's break this down real quick. People use the word density, but that's technically wrong. It's the temperature gradient that causes the refractive effects, not the density gradient. In Maxwell's equations, which determine the refractive index of something, there is no density formulas. There is no density calculations calculating the density of the medium. Why is that?
in
When the
Maxwell's
speed of light
equations?
in Maxwell's equations of electricity and magnetism, because light is electromagnetic, right? Propagation.
Yeah.
Okay. So depending on the medium it passes through, that alters the speed at which light propagates. So when it goes through one medium where it's traveling at one velocity, and when it enters another medium where it travels at a different velocity, the light will be displaced. It'll be deflected. Okay, this is what refraction it technically is. But the properties of these mediums is not based upon density. It's based upon its electrical properties. The technical terms are electrical permittivity and magnetic permeability, and that is how much that medium, when the light goes into it, its electromagnetic wave, how much it polarizes electrically or creates a magnetic field, how strong a magnetic field it creates at the same time, and then there's a resulting field that's created from that interaction, and that's what determines the refractive index of the medium. It's not the actual density, because in fact, there's turpentine, for instance. When it gets denser, it's apt to go. Its refractive index goes in the wrong direction. Doesn't
Right, so
increase; it decreases. Because it's electrical. Because it's the electrical properties. It has nothing to do with the matter per unit volume. Because density is matter per unit volume, right? It has nothing to do with matter per unit volume. It only has to do with the electromagnetic interactions of the molecules and atoms themselves. In temperature is the one that affects that the most. In fact, it's something like 4,000 times greater than changes in the density. And this isn't my opinion. This is in Understanding Astronomical Refraction by Andrew Thomas Young. You can go read it in there.
So I'm not like super up to date with Snell's law, but I know that the issue that we're having right now is about refractive indexes and how those are calculated.
Well, this would be a gradient refracted medium. This wouldn't be Snell's law because there's no well-defined boundary with two different refracting mediums.
Can't
Snell's
use the
law is
differential
not
version of Snell's.
What is that? Never even heard of that. The differential version. They use the principle of least time. That's what they use.
So, like, if we're talking about the same medium,
and they're not equivalent. Snell's law is not equivalent with it.
So you're saying it's not Snell's law that's in play here when you're talking about?
You can't use that. It's not equivalent to it. You don't. So there's two ways to do this. You can use Fermat's principle and the principle of least time. If you wanted, and you could use that in Snell's law. It's the special, what's called a special case of that. Meaning there's two mediums with a well-defined boundary between them. So using the principle of least time, you can get Snell's law to spit out. But you can't use Snell's law to get the principle of least time. It doesn't work the other way.
Get the principle of what time?
The principle of least time.
Principle of least time. Okay.
Yeah.
Fermat's principle.
So electromagnetic radiation will take the path that it spends the least amount of time in the medium.
Right.
And that's why they call it the principle of least time.
Yeah, Muse, we don't allow incoherent nonsense or strawmans to be representing our community. We work on empiricism, logic, and so we test the claims. We don't just believe the claims. That's your side. Remember that.
We're more than happy to unmute you if you're willing to engage in a proper conversation. But don't be disparaging and don't come at this like a bigot.
And don't pretend you're one of us and don't try to speak for us. Just speak for yourself.
Yeah, that clown wheel crap, leave it at the door.
What was this experiment that you did, Indio, that the last people were talking about?
No experiments.
What?
So what Indio did, you can just scroll up. I'll give you the timestamp, and you can have a look at what he did.
I'm here. What's the question?
What was the experiment? You want to know what experiment you did, Indio? I said it was not an experiment.
Yeah, I didn't do any experiments, man.
Then what were you guys talking about?
Observations and measurements. Those aren't really experiments. Experiments are for natural phenomenon. And they determine cause and effect relationships. So just measuring something, like if you went to the doctor and they measured your height, that wouldn't be an experiment, right?
True.
Yeah, so we're just doing measurements. That's it. We're measuring to see if the Earth, measuring the distance of the horizon.
Okay, cool.
And to see if it matches the globe prediction, which it does not.
So where is that?
According to the globe mathematics, from my observation height of 15 feet, it should have been 4 miles away.
No. I'm asking where's all the data, I guess. I don't know. The video, did you make
In the side
yeah,
chat?
you can scroll up. It's in the side chat.
Yeah, I just tagged it. It says here, and then just click the attachment.
Yeah, or you can go to our home server and scroll down. There's A to C, a ton of data for you to go through.
Yeah, but this particular one is in the side chat. Obviously, this isn't the only thing we have.
You need to charge your phone, Indio.
Why is that?
You're at
What's wrong with my
8%.
phone? Oh, well, it was, it was freezing out, man. It was killing my battery. I mean, it seemed like 40 degrees marinetraffic.com, yeah.
What is that? Is this just show, is this talking about boats or something?
It tracks the boat position.
Position of boats, okay.
Yeah, so this particular position, hold on one sec. These particular positions, when they're in Boston Harbor, their position is given by a radar station in a place called Gloucester, Massachusetts. There's a radar station that tracks all the boats that are out there.
And then this second picture, what is this from, like Google Maps or something?
Yes, the red circle is where the horizon. The red circle is where the horizon should be, and the line is in the pin is where the boat was, according to the coordinate in the aforementioned image. So there's a coordinate in that marine traffic image, and that's the coordinate position in the pin.
Gotcha. And then that's the position of your camera, 10 feet above sea level?
15 feet, yes.
Or sorry, 15 feet. And then what's the next one?
That's a buoy that took the temperature data that's in the line of sight in the video that's further down. That's a USGS water buoy, or NOAA water buoy. So it measures the air and water temperature every 8 minutes or something.
Okay. Where does that one picture show the position, or say the position of the buoy?
The Google Maps?
No. In I guess the fourth picture, one of the weather buoy, the temperature one.
Yeah, that shows the air and water temperature.
Right, but you said you saw it in the video.
Yeah, the actual
how
buoy.
do you look at its position?
It's right in the line of sight. It's right in front of the boat.
I know, but how did you determine how far away it was?
I don't need to know the
On the
distance
map?
of the buoy.
Okay.
The buoy's unimportant. I only got the picture of the buoy because of the air and water temperature.
Okay, gotcha.
It was just a coincidence that it was in the line of sight.
Okay, sorry. I thought you were. Okay. Heard. Yeah, I got air temperature, water temperature. Okay, cool.
Yes.
And so you were tracking this to try and figure out the conditions of the air around above the sea. Right?
Yeah, so I planned this for like 2 months. Well, I was looking for 2 months for a day where the air and water temperature were the same to go do an observation, or nearly the same.
Is your video in black and white, or is this?
It's infrared.
Oh, infrared. Okay, cool. Yeah, so I see 3 objects, or sorry, 4, I guess.
Yeah, 2 of those are lane markers and one's a buoy. So there's a shipping lane that crosses this, that goes left to right across the screen. And they have lane markers. So there's the buoy and the 2 lane markers.
Crap, you're seeing even more than you should see.
So you're saying at 3 p.m. you were able to, is when you took the video at 3 p.m.?
It's between 3 and 3:15, somewhere in that section. Because when I finished, I took a picture of a clock, which is further down. Clock that's right there on Revere Beach. Which is becoming quite fucking useful for some reason. How do we know you were there at that time? Yeah.
I've really never heard any Globers ask these same questions about their own pictures, though. That's weird.
Yeah, I know. Here's a, and that, like, you know, like the blue marble, the 72 blue marble, it's actually a dispute within Apollo, you know, moon landing nerds, when that picture was actually taken, because they can't figure it out from the transcript when it was taken, because they never indicated it. You know, they got transcripts of like what they're saying inside their little studio. I mean, on their way to the moon. Yeah, so it's a dispute among Apollo enthusiasts for the timing of that picture. So yeah, they do dispute it sometimes. Now, the key thing about me getting the air and water temperature the same is that any refraction effects that they say exist have to be minimal. So I did everything possible to minimize any effects of refraction, if there is such a thing, doing anything, by using A, infrared, and B, doing it at a time when the air or water temperature is nearly the same.
What do you mean if there is such a thing as refraction?
If there is such a terrestrial refraction, that's what I'm talking about. That the specific terrestrial refraction that they say bends light around a ball. That is horseshit.
I don't think people make the distinction between refraction and terrestrial refraction, but I see what you're saying.
Well, that's because that distinction doesn't fit the propaganda rhetoric that they do. Because if you say there's no refraction in these observations, they go, you don't believe in refraction? Now, there is a general phenomenon called refraction, but that's not what this is, okay? What they're saying is a specific type of refraction, specific condition that creates it. i.e., there's a density gradient that's curved. And because there's a curved density gradient, when light passes through it, it automatically curves around the ball, making the ball look flat.
Well, that density gradient it would be the air.
Except those density layers are flat.
Yeah, but it has to be a curved density gradient.
Is that right?
Yeah.
So light passing through 2 different mediums of different density, even if they're
there's only one medium, dude.
Yeah, but we're talking one medium. We're talking about air.
I know, but medium of a different density and temperature, doesn't that change it?
Well, what you're claiming
water,
is
like
that,
if you, so I know what you're saying. If you go from air,
but density is like, but density. Okay, let's break this down real quick. People use the word density, but that's technically wrong. It's the temperature gradient that causes the refractive effects, not the density gradient. in Maxwell's equations, which determine the refractive index of something, there is no density formulas. There is no density calculations calculating the density of the medium. Why is that?
In
When the
Maxwell's
speed of light
equations?
in Maxwell's equations of electricity and magnetism, because light is electromagnetic, right? Propagation.
Yeah.
Okay. So depending on the medium it passes through, that alters the speed at which light propagates. So when it goes through one medium where it's traveling at one velocity, and when it enters another medium where it travels at a different velocity, the light will be displaced. It'll be deflected. Okay, this is what refraction it technically is. But the properties of these mediums is not based upon density. It's based upon the electrical properties. The technical terms are electrical permittivity and magnetic permeability, and that is how much that medium, when the light goes into it, its electromagnetic wave, how much it polarizes electrically or creates a magnetic field, how strong a magnetic field it creates at the same time, and then there's a resulting field that's created from that interaction, and that's what determines the refractive index of the medium. It's not the actual density, because in fact, there's turpentine, for instance. When it gets denser, it's apt to go. Its refractive index goes in the wrong direction. Doesn't increase; it decreases. Because it's electrical. Because it's the electrical properties. It has nothing to do with the matter per unit volume. Because density is matter per unit volume, right? It has nothing to do with matter per unit volume. It only has to do with the electromagnetic interactions of the molecules and atoms themselves. In temperature is the one that affects that the most. In fact, it's something like 4,000 times greater than changes in the density. And this isn't my opinion. This is in Understanding Astronomical Refraction by Andrew Thomas Young. You can go read it in there.
So I'm not like super up to date with Snell's law, but I know that the issue that we're having right now is about refractive indexes and how those are calculated.
Well, this would be a gradient refracted medium. This wouldn't be Snell's law because there's no well-defined boundary with two different refracting mediums.
Can't
Snell's
use the
law is
differential
not
version of Snell's?
What is that? Never even heard of that. The differential version. They use the principle of least time. That's what they use.
So, like, if we're talking about the same medium,
and they're not equivalent. Snell's law is not equivalent with it.
So you're saying it's not Snell's law that's in play here when you're talking about.
You can't use that. It's not equivalent to it. You don't. So there's two ways to do this. You can use Fermat's principle and the principle of least time. If you wanted, and you could use that in Snell's law. It's the special, what's called a special case of that. Meaning there's two mediums with a well-defined boundary between them. So using the principle of least time, you can get Snell's law to spit out. But you can't use Snell's law to get the principle of least time. It doesn't work the other way.
Get the principle of what time?
The principle of least time.
Principle of least time. Okay.
Yeah.
Fermat's principle.
So electromagnetic radiation will take the path that it spends the least amount of time in the medium.
Right. And
that's why they call it the principle of least time.
And I guess so. Like I think when we're talking about refraction in the atmosphere, I know you guys don't like the term or sphere. Sorry, atmosphere or in the air above the water is that there are different temperatures and possibly of different densities. So that's why the air refracts. And you're saying you can't use this because they.
No, I'm saying that there's no experimental evidence.
You can't take the integral of like the air.
You can do whatever calculate. Look, brother. You can do whatever fucking calculation you want. You can come up with any model you want. Eventually, no matter what, you have to test that against reality and actually get the validation of the model in reality, in the natural world, right? That's how you verify models. There's no model that exists which can accurately predict anything when it comes to this. Because it would be, if it was a deterministic model, that means that I could take a photograph, and if I knew all the geometric particulars of the photograph, I could tell you the weather that day. You understand? Because then I could get out the air density, I could get out the humidity, I could get out by reversing it, right? Like, oh, look, man,
Photograph?
that ship is, well, you'd be able to reverse it, right? So you would predict the refraction, how much refraction, like say there's a boat out there, and the boat's supposed to be sunk down 6 feet and it's picked up 10 feet instead. I go, okay, I can do a calculation to figure out how much refraction would have to exist for the boat to be displaced that much, right?
I think that's what I'm trying to say, is that you
But that should be a reversible process where I can look at something else. The boat, like, hold on, dude. There should be a reversible process where I can look at the boat and get the meteorological conditions to spit out.
From looking at the boat?
Yeah, from looking at the boat. If it's a deterministic model, it should be reversible.
Even if the model is deterministic, just from looking at a photograph, you don't have all the variables. I don't believe.
What variables am I missing?
The temperature of the air between.
No, I should be able to predict the temperature that it was based upon the photograph.
How?
Because say the camera is the same height as the center of the boat. And then when I take the photograph, I know geometrically that's where it is. Then I take the photograph and the boat looks like it's 5 feet higher.
Oh, I see what you're saying.
I should be able to spit out the meteorological conditions that would cause the boat to look 5 feet higher.
I see what you're saying.
It was an accurate deterministic model.
I believe
but there isn't one.
Yeah. No, I get what you're saying. And I think that's almost correct. But the amount of calculation you would have to do, because you have to take an integral between the air densities between you and the boat. Right? Because you had to, between the distance.
They use the calculus of variations is what they usually do.
Because again, if we're just taking the simplistic Snell's law, I guess the refractive.
You can't use Snell's law, man. I just told you that. I'm gonna post in the side chat a paper that demonstrates mathematically Snell's law and Fermat's principle in a gradient index medium are not equivalent. Okay, I'll just post the paper.
Well, obviously, I should probably look into this more because I don't.
The whole point is this is all academic. You know, we can see, like I said, we can sit here and talk about models all day and argue about what ultimately whatever concept you come up with, it has to be proven by experiment. And I challenge you to find any academic paper that accurately predicts the refractive index from the meteorological conditions by running it through a model, right? That they take the meteorological conditions, run it through the model, and then their prediction of what they survey, look at, whatever, matches their prediction. It can't be done. It's never been done. And it says all through the academic literature that it's fucking mysterious and they can't figure it out.
I mean, I agree with you, but I just think the calculations would be astronomical that not even a fucking supercomputer could do it within our lifetime. Is why.
Yeah, but what am I supposed to say when people go, you don't believe in refraction?
No, that's not what I'm saying. You're asking for something that is, I don't know, unreasonable.
But brother, I'm not asking
You're
for it.
You're trying to ask me for the whole, what the temperature is between all of the air in between you and the picture you just took due to the refractive index?
But they say that they can do that.
Who said that?
Dude, listen, if they have a model, look, it will be just as complicated in either direction. Whether you get the at either end of the prediction, at the input and the output. Okay, so you have an input and an output in the model in the middle. Okay? Got it? Understand? Input, output, model in the middle. Now your inputs could be the geometry, or your inputs can be the meteorological condition. So if your input's the geometry, the meteorological conditions should spit out, and if your input's the meteorological conditions, the geometry should spit out. They say that they can do the meteorological condition input and spit out the geometry that should be seen.
Okay, who is they, and where can I find it?
Walter Bislin. There's one.
Who the fuck is that? Walter who?
This is all over the place. I mean, I don't even know where to start. Every anti-flat earther in the world says that the globe, all the observations that we do, such as the ones that were posted in the chat, match the globe prediction.
Walter,
whatever that is. And that globe prediction is, well, hold on. And the globe prediction is I have a bunch of refraction sliders and I can alter and I can use a computer program with 3D elements in it, and I can move the refraction sliders until that matches the observation. And then they'll say that that movement of the sliders is a globe prediction of the observation. They say this all the time. This isn't new.
Right. So they changed the variables of a model to try and reflect reality.
Well, they just changed the. No. So say I have an image, right? I have an image. There's mountains. They're 100 miles away, and they shouldn't be seen. So what they'll do is they'll put in the geometry into this little 3D program. It's called Walter Bislin's Advanced Curve Calculator. They'll put in the dimensions, right? 15, I'm 1,000 feet tall. I'm 1,000 feet elevation. The mountain's 100 miles away. It's got 9,000 foot elevation, and it should, the horizon should be, and somewhere in front of it, the mountain should be cut off, 1,000 meters. And they'll say, okay, that's possible because I went into this computer program and I moved this refraction slider and increased the refraction in the slider using the model, using the refraction model. You just keep adding, you just keep changing the temperature gradient, right? You just maximize the temperature gradient until poof comes out, spits out, hey man, I made a prediction that matches the globe. That the globe predicts that that's possible. Well, none of these are actually predictions, they're all postdictions, right? But the point is that we've argued about refraction for a long time. I have, going on fucking 10 years now.
I know, me.
And there hasn't been a single fucking iota of evidence that any fucking model, like when people say, hey dude, this can happen on a globe because of refraction. And I go, okay, you think refraction exists and can make that happen. Justify that. Justify it in some way, any way, shape, or form. And they'll just talk in generalized platitudes about sugar water and all sorts of nonsense instead of actually saying, okay, they did these experimental, they did these experiments in this place, and they took a theodolite and they carefully measured displacements and they carefully measured the meteorological conditions. And this model, if you put the meteorological conditions in this model, it matches the displacements that they measured. So we know this model accurately makes predictions about, there's none of that. That doesn't exist. It's just claimed that it exists, but it doesn't actually exist.
I think you want it, so these models that are created, I think you want these models to be able to explain something that
models don't explain things, dude. If you're going to claim that refraction explains it, you need to have a justification for that exists in the natural world. You need something. Just saying that you can conceptualize a magic condition, I mean, gravity could explain it too. I can explain it with gravity. There's a fucking black hole at the center of the Earth that's fucking bending the fucking light around the black hole, such that it makes the globe look flat or something. Like I could also say magic. I could also say elves. I can explain it in all sorts of ways. That doesn't mean it has any validity or justification.
True. I just wanted to say that I think I don't think if I was trying to prove the Earth was a globe that I would use a model of refractive index to try and prove that. You get what I'm saying? So, I mean,
no, they use it to say that all our observations don't mean any. All our observations also prove the globe. Yeah. So, I mean, I don't know how familiar you are with what happens in this topic. So,
India, we've talked 100 times. How dare you? Okay. You send me your fake news stories every day almost.
You're talking about crit, bro.
Oh,
I'm not crit.
Sorry. Yeah, you're right. My bad.
Dude,
yeah,
wow.
I should. You're lucky I can't come through the screen right now, motherfucker.
I'm so sorry.
They're just so angry. They're so angry at us. They'll just say anything at this point.
Crit, why'd you change your name? Triggering Triangle? What the fuck is that?
The whole point is if you're going to claim. If you're going to claim something, you have to actually have a justification for it. So what is the justification for claiming refraction bends light around the ball? Or that it's even possible? Is there any demonstrations, experimental evidence? Has anybody actually taken a fucking curved surface and did something, constructed a lens, added fucking, I don't know, CO2 or any other thing, did it in water, or whatever and made a curved surface look flat. No one's ever done that. As far as refraction, has anyone ever measured the light to be curving around a curved surface, or that it's even possible? Use a hill, use whatever, use a fucking man-made surface. I don't care. Has anyone demonstrated it's possible at all? That's the thing. No one's even ever demonstrated that it's even possible to do this.
So
it's only possible in some theoretical concept in someone's head.
So I haven't looked, but I can almost guarantee you that somebody probably has.
No,
you
they haven't.
Looked, you're stupid.
And
I can't provide you that information, so I'm not going to claim that. I just want to put it.
Well, this is what we call the magic science guy fallacy. You think out there's some magic science guy that did the experiment. You don't know what he did. You don't know how he did it, but you know he must be out there somewhere.
I think it's an iteration on Snell's law.
Don't you think I looked,
that it can't
Don't you think I looked? I've been looking for 10 years, dude. I've had every globalologist, physics, astrophysicist, PhDs, and you fucking name it, all come in our chats of the thousands of fucking people I've talked to, right? And specifically demanded the information, and not a single person has brought it. But you think somehow you're the guy that's going to go find the guy. You all think that. All of you. You think that somehow you know there's somebody out there with this information. Bro, I've read all the academic literature on this particular subject, terrestrial refraction, astronomical refraction, what is it, survey refraction, going back 150 years. And it all says the same thing. It is an intellectual mystery.
Okay. I believe. I don't think you're lying.
I could read you some citations, dude.
So, I mean, sure. Actually, yeah, that would be awesome.
Only if you're going to be a flat earther, he'll do that.
Fuck. Next time next time you guys ask me for a citation, I'll tell you only if you become a round earther.
You don't have any citations, dude. We've been asking for globe citations for 13 years. You haven't shown us one thing yet.
Crit, shouldn't you be looking for more fake articles to send
Look
you?
at it.
What are you doing?
Yeah, I put out fake articles.
All right, hurry up.
Suck my ball.
Work on it, dude. I'm fiending for him.
Perfectlo.
Go on, you
Gay,
bitch.
motherfucker. Gay.
It takes one to know one. Anyway, moving on.
Listen, I'm not saying you're wrong. I'm just saying I feel like your expectations are.
Yeah, but I don't care about your feelings, dude. Your feelings don't matter. You're ignorant of the subject, and you're really just showing your bias. It's all you're doing. You have no information that I'm wrong in any way, shape, or form.
True. Very true.
Okay, but
we're debating hypotheticals here.
No,
we're not, because no one's ever observed this. You've never observed this. It's just some conceptual thing. It doesn't exist in any way except for in the minds of people. It doesn't exist out there in the natural world. You've never looked up. Imagine Napoleon's army is marching, and he gives away his position because it was refracted over a hill.
Again, I'm not saying the proof of there being a round Earth is due to the refractive index of light bending around a sphere. There's other proofs for that. You're just
but
one.
That one doesn't happen in the first place, so that's not a proof of among the other proofs. So you can't use that one.
Brother, this is like a straw man that is used. So many.
No, you're just ignorant. You don't know. You just don't know that what you think are proofs actually aren't proofs. Just like you thought refraction was a proof for the globe, but we actually understand refraction far better than you. We argue with scientists on this, and we study this. So we know that refraction does actually not help the globe at all, and it debunks it. And so
let me read you.
If you would like to concede and jump to your next claim, or what you believe is a proof, we can destroy that as well.
I don't have any claims, my friend.
Let me just read something. Variations in the refractive index in the atmosphere are caused by inhomogeneities of a wide range of sizes. These include both variations in the mean refractive index and refractive index fluctuations due to turbulence that cannot be accounted for by any deterministic model. I don't know how you can not be more clear than that. If temperature vertical profiles are unknown, then the refractive coefficient cannot be reliably determined.
Semi it is whatever you read.
The propagation path of light in the atmosphere is influenced by inhomogeneities of the refractive index. These refractive effects deteriorate the accuracy and direction and distance measurements. Not just the up and down, left and right, too. In geodetic applications, as illustrated by two examples in this report, the refractive effects cannot be accurately corrected. I mean, and on, dude. As in geodetic leveling, the atmospheric refraction can be the main source of error in the trigonometric method.
Sure, yes, because the atmospheric conditions are likely unknown. That's why it can be a source of
that means they're not predictable.
Variable.
Yeah, that means
not that they're not predictable, but that they're not known. They're unknown variables. I mean, if you had temperature sensors set up, this is how you could do an experiment. I mean, if you had a controlled environment.
Okay, so you're going to mention an experiment that was already done, and then I'm going to tell you about it. So you think people haven't tested this shit? It's been tested, dude. It doesn't match prediction. What don't you get?
Then send me whatever this is, please. I beg you.
Okay, I'll give you a specific one where So when they did, it was in. Yeah, I'll find it real quick.
Yeah, just send me whatever it is. Listen, dude, I'm honestly not trying to fucking argue.
I don't know why you're defending an idea that you literally have no evidence is true. That's what I don't get.
All I'm defending is your claims of there not being any evidence of it. I don't know.
do you have any evidence? What do you mean my claims that you don't know of any evidence? I'm claiming what you don't know exists actually does not exist.
Fair enough. Send me what you're gonna send me. We'll look it up. We'll check it out.
This is a particularly good one. It's called Influence of Atmospheric Refraction on Terrestrial Laser Scanning at Long Ranges, proceeding of the 4th Joint International Symposium on Deformation Monitoring. So they're highly accurately measuring deformations of landslides. Right? Has that landslide moved? Because they want to predict whether it's going to, fall on a town or something. Okay. Hold on. I almost got it. There's one more thing I need. This. So these were measured. These actually measured the angle of arrival of two lasers. Okay, so I'm going to post in the chat. Can we still hear me? Test.
Yep, gotcha.
All right. So this graph. Okay, so here it says forward correction. Right. So what they did was they monitored this landslide continuously for 48 hours. This is 1 day of measurement. Now, the globe Earth quote unquote refraction prediction is that the deflection of the laser due to refraction would have been something about, I think it's 8 meters over this distance. Picked up, right, around the curve of the Earth. But according to what they measured, even at the maximum, it's 8 inches, not 8 meters. And the maximum is only at noon, as you can see, right? When it's at peak solar radiation and peak temperature, right? So the point is that this experimental result doesn't match any model. And I can post another one. He's still here, or did he bail?
I'm here, brother. I'm trying to
Okay.
read your fucking paper. So wait, did you give me a paper that you said doesn't agree with experimental models? Is that what this
Yeah,
paper
it doesn't. With their measurements don't agree with any model because the measurements of the quote unquote refraction in this measure the deflection of 0.0036 degrees.
And it didn't match with whose other measure.
The prediction, the deflection angle should have been like an order of magnitude greater than that if the current refraction models are correct.
From what they predicted. So they're
no. From what their data shows. See, there's data and then there's the prediction. The data don't match the prediction. You guys are fucked up. You global earthers are fucked up. No, you global earthers are fucked up. You think the story is what happens in reality. No, you have reality, and then you have the story, and then you see if reality matches the story, and if it doesn't, then the story's wrong. What I'm showing you is reality doesn't match the story.
Why are you
You understand?
just asking a question, dude? I was just asking you questions. Relax.
No. You're asking me questions starting from the same starting point of the story's correct. No, fuck the story. It doesn't matter what they say. We have data. The data is what determines everything. Doesn't matter what people say about it. Only matters what the data shows.
Yeah, I'm
this
asking
data
you
shows
from the worldview that I have, just like you are. You believe the fucking Earth is flat.
this is different than the globe prediction by an order of magnitude. An order of magnitude is too small at its worst.
Dude, let me read your fucking paper before you want me to argue about it. Holy shit, dude! Don't get so upset. It's fine. I'm just
Yeah, you can mute yourself and go read the paper. That's fine. We can talk to somebody else.
Okay, I'd love to.
All right. See you later.
At least he'll be a flat earther after this.
It's always the same. We provide the evidence, we back up what we're saying. They can't provide any proofs of the globe.
Yeah, like cognitive dissonance is strong.
Yeah, you're not bad to talk to because at least you can say most of the time when you don't know that you don't know. You know, we get people through here all the time that they will never say that they don't know. They'll just make something else up. Oh, it's this or it's this. At least you say you don't know. But you still argue that you do know, right? You argue like you know, but you say you don't know.
I do like to argue.
We can tell. It's more like a passive arguing, though, isn't it? Like pretending to ask a question to see what answer you get that you think you already know the answer to, and then you argue the answer you get.
Yeah, I'm just trying to probe, what you guys believe, my beliefs, and see how they do.
Do you probe the globe side if you're not making any claims? Do you ever probe them? Okay, what questions do you ask them?
What questions do I ask the globe?
Yeah.
Well, mainly I try to verify the claims of the measurements of like the distance to the horizon, because that is like the majority of your guys' claim. That's basically the only thing you guys have is truly that like the measurements from the horizon don't make sense on a globe.
That's nonsense, man.
We go into refraction and shit like that every time.
Goodness.
So
why do we bring up the distance to the horizon? Why is that important?
Because that's the really only thing that makes sense. That
why is it important?
Into your,
why is it important though?
Because it's the only like physical kind of evidence you guys can produce, I guess.
It's not our evidence. We don't use it as our evidence.
Sorry, measurement, I guess.
Okay, listen. The horizon is you guys' evidence. Ships go over the horizon. The sun sets behind the horizon. All that shit. Did you forget?
Sorry, we were
That all
talking
that
about
proves the globe. Remember?
He's already forgotten. He claims to have no arguments or claims anymore.
Brother, I am lost. I got it.
Okay. So the globe claim is that the horizon is created by the edge of the ball, and that ships go over it, and the sun sets behind it, and the moon sets behind it, because it's physical. It's the physical edge of a ball, right? You've never heard ships go over the horizon? And they're sailing over the curve of the earth?
We were just talking about it, brother.
No, listen, don't, dude, don't. Have you ever heard of ships going over the horizon, and that is the curve of the earth?
Yes.
Okay. Now, if the horizon moves around, what does that mean for that claim? It can only be one of two things.
I don't know what you're asking me.
Either if the horizon, if I go out and the horizon at freaking 3 o'clock is 10 miles away, and then at 9 o'clock it was 8 miles away, and then at 11 o'clock it's 3 miles away, can that horizon be the edge of the ball?
No, the horizon is not a physical thing.
Okay, fine. That's why we bring it up, because there's still people in 2026 saying ships go over the horizon.
Yeah, the apparent horizon, I guess.
Yeah, so that means it's an optical illusion.
Yes.
Okay, so ships over the horizon or sunsets or any of that crap having to do with the horizon is not proof of a globe.
Okay.
Right?
Yeah, sure.
Yeah, sure. You'll still fucking argue it in 10 minutes. You're going to do the NPC reset and then fucking bring up ships over the horizon. Watch.
I'm already starting to forget. Just kidding,
I went down it. We bring that up. That isn't a flat Earth proof. We use the horizon to demonstrate that the globe geometry has to be wrong.
I get it.
Okay. Our proof are laser tests. Our proof is shit like that. So like a 36.7 mile fucking laser shot across the Bonneville salt flats. The perfectly symmetrical reflection at the Bolivian salt flats. That's our proof that the Earth is flat. Or just actually measuring the lack of curvature. Because just gawking at the horizon wouldn't prove a flat Earth. But they say it proves a globe. I mean, DJ was talking about last night. When I first entered this topic, they said that the very existence of a horizon was proof of a globe. It's the problem with you globe earthers. It's like you guys are just like whack-a-mole. You're trying to create an unfalsifiable condition. Oh, see the boat cut off halfway 10 miles away? Proof of a globe. See it cut off halfway 20 miles away? Proof of a globe. See it not cut off 30 miles away? That's also proof of a globe. Everything you see, proof of a globe. No matter what it is. Even if the observations contradict each other, still proof of a globe.
So look, again, I just want to point out, I wasn't trying to prove a globe Earth. We're just
I'm not talking about you specifically. Don't personalize it. I'm just explaining to you why we bring up the horizon.
Okay, my bad. I thought you were talking to me.
You have decided you don't want to actually make any arguments.
No, I'm not trying to make any hard claims here. Well, when you talk about globe earthers and them having, you said that they're trying to make an unfalsifiable claim.
Yeah, they're trying to make their claim unfalsifiable.
Well, I'd argue that's what you are also doing.
Okay, in what way are we doing that?
Because you've made your claim of flat Earth almost unfalsifiable. What is the evidence that would make the Earth not flat?
Measured curvature. Measuring curvature of the Earth's surface. That's simple.
Without refraction?
What do you mean without? What does that mean?
As in, what kind of curvature, what kind of conditions?
That the surface of the Earth is physically curving.
How would you make those conditions to be able to test that?
Well, you could shoot a laser.
Okay, is a laser not a form of light that would?
Yeah, it is.
Refraction.
Yeah, but there's no justification for the refraction, which we already covered. There's no justification for that. This is what I'm saying, is to make it unfalsifiable. This is exactly what I'm talking about. You literally did the thing I was just saying.
By asking you how you would test this?
By mentioning refraction, which there's no justification to bring up. Just like what if you said, you mean even that doesn't gravity affect light? What if your reasoning was, well, gravity bends light around the Earth? Would that be a justified caveat to that?
Is it a dependent variable? I don't know.
Let me ask you, would it be no, let me just hypothetically, dude, this is a hypothetical. Okay? I say, hey, you measure the curvature of the Earth. Well, how do you account for gravity bending the light? Would that actually be justified, or would you have to justify that in some way on using that and saying this is a variable that could confound the measurements? You'd have to justify it, right?
I believe so, yeah.
Okay, so the same thing with refraction. You need to justify it that it can confound the results in such a way that we can't measure the Earth. See, a confounding variable actually has to confound, okay? And if it isn't sufficient, say there is refraction, but what if the refraction is so slight that it's not enough to confound the measurements? Such as when the Lake Isomer laser test, when they shot the laser 41 kilometers, and the result was off the globe prediction by 2 orders of magnitude. And even if you take something like standard refraction, it's still off by 2 orders of magnitude.
So how do we determine if refraction plays a part in these measurements?
Well, that's not my problem.
Then what the fuck?
There's no evidence. There's no evidence that it does.
See, this is what I mean by Indio. You don't make any fucking claims. You don't give a shit.
No, because we don't listen. Yeah, we don't need to answer every possible imagined fucking thing in the head. You need evidence, right? So, this is called like the onus probandi. Okay, that you make a claim, then the burden of proof is on the person to prove the claim or show evidence for the claim. Okay, we don't have to proactively go search out every possible claim and find counter evidence to it even before it's said. We don't need to go find counter evidence for refraction. The burden of proof is on you to show that their refraction exists such that it can confound the results of a measurement.
See, this is what I mean by putting yourself in an unfalsifiable.
It is falsifiable. You go find the data that refraction can confound the results of the measurement, and then you're fine.
So you brought up a laser measurement. You said what? 31
That's right.
miles or something.
Yeah. So there's a 41 kilometer, 25 mile laser shot from 10 feet above the sea, like the lake. It's actually it used to be connected to the ocean. They cut it off, and they turned it into a saltwater lake.
What's it called?
Lake Isomer. It's in the Netherlands. It's IJSELLMEER or something. It's Netherlands. They spell it weird. It's IJSELMEER. So,
The fuck do you put a J in that? Okay.
I don't know. I'm not IJ, so it's even weirder. So,
They did a laser measurement over 25 miles.
yes, they did a bunch of distances, and then they went back 2 weeks. Then they went back three weeks later and did it again. They brought They brought weather stations, meteorological stations, and placed at both ends of the shot. Right, so they have the weather conditions. They replicated it. Okay, and the thing is, the result is 2 orders of magnitude different than the goal prediction. So the goal prediction is that the laser should have been 420 feet in the air at the other end, and it was 4 feet in the air.
Okay, I'm sorry. I'm trying to find this. Do you have the source for this, or I need to just?
Which? Isomere?
Yeah. Were we the ones talking about the influence of atmospheric refraction on terrestrial laser scanning at long range too?
Yeah. Yes, I'm the one who gave that to you.
Okay, I read some of that. We can talk about that.
Okay. What about the data? I don't give a shit what the people say, dude. I only care about what the data says. What did they measure? That's the only thing that matters.
The effect of the measurement object at the atmospheric refraction are linked, unavoidable, and cause apparent surface displacements up to a few decimeters.
Yeah, that's right. Decimeters. That's right. You guys need fucking meters. Multiple meters. So in the case of this one, that's the point. That is the point. Thank you for bringing that up. And the decimeter is and hold on, the decimeter is the distance measurement, by the way. So you kind of screwed up.
That was
because they're using the LiDAR also for distance measurement. So the distance measurement was off by a few decimeters.
They also carried out a numerical simulation. And the simulation was off by a few decimeters too. I don't know. It's just.
Who cares? We can look at what the standard refraction predicts what it should be, and then we can look at what the data says, and they're not even close to each other. They're different by orders of magnitude.
Their simulation was only off by a few decimeters.
Simulation of what?
Of their perceived curvature, or the perceived the apparent ray versus the actual ray, and then there's a beta measurement between the actual ray and then the chord, which is the measurement between the same point from the actual ray chord, and then there's also the apparent ray. They did the experimental study and they modeled it, and it's also integral. It's an integral between the densities between the observer and the electromagnetic wave, or the point of the electromagnetic wave, and its beta equals the negative of 1 to 0 of the partial derivative n over q L minus S over L ds. And so the measurement is not a linear equation; it's an integral, which I was saying.
Yeah, that's fantastic. Okay, but you have a measured deflection angle. The angle of arrival of the laser. So they bounce. They use 2-frequency LiDAR. They bounce each laser off, and then they can measure the difference in the angle of arrival to measure the refraction. So they have an angle of arrival. The angle of arrival is displaced by some amount, and then you can take that angle and extrapolate out. Right. So the displacement that was different, the difference in displacement was 0.00272 or 0.0036 degrees at maximum.
Mm-hmm.
Okay, that's in the thousandths, right? 0.003 is in the thousandths, a thousandth of a degree displacement. Okay, so if you take a thousandth of a degree displacement and go, hey, 1 kilometer away, What is the distance of a thousandth of a degree displacement? It's like 8 inches. Okay? A kilometer away for the globe, the refraction is feet. Okay? It's multiple feet. So why the so-called standard refraction, if it existed, would be a confounding variable because it's large. The actual measured existing refraction that exists due to measurement that we know empirically is not large enough to confound any fucking measurement. This is what I'm talking about. What is the data? What's the justification? Not the justification based upon some concept, but the justification based upon empirical evidence.
I get you. Check.
Okay.
Check the.
Science is empirical. Hold on. I want to get clarified. Is science based upon empiricism? Is that the foundation of science, empiricism?
No, that's one of the references in the paper you posted.
No, is empiricism the foundation of science generally?
In a general sense, yes. Yes.
Yeah. In that if you don't have an experiment or an observation, you're not doing any type of science.
Right.
Okay.
Okay.
So the empirical observations and experiment control, okay? Not people's opinions about what should happen. It's what the data says. That's why I keep harping on this. What I found out about globe earthers is that you guys actually are not empiricists. You guys hate empiricism. You like explanations and storytelling time. Okay? You fucking hate looking at data. You hate looking at what the measurements actually show. You can't stand that shit. Okay? Because you like the stories, because it makes you feel better about the world. Well, there's
I'm an
a thing
engineer,
called stand.
so I disagree. I like data. Big fan of data, actually.
Okay. Well, what am I supposed to do when they say there's X amount of refraction and all the textbooks say that and there's a bunch of people running around parroting, but when I go and look at the actual empirical data that's been accumulated over 100 years, none of it matches that crap. None of it. I'm not saying some of it matches and some of it doesn't. None of it matches. None.
I don't know, man.
Yeah, you
Can't tell
can't
you.
believe it. How's that possible? Because if you go read the academic literature on refraction, you'll find out that none actually matches.
Yeah, you're right. I don't believe you. So, but that's okay. You
Look,
don't believe me either.
measurements of the
Anything I say.
variation of the vertical angle, 0.004 mgon. Okay? Gon is a measurement of angle that they use in surveying in Europe. Okay? Now you can convert gon into degrees. Now the max values here. These are the max, dude. Would be a displacement of 8 inches. Okay? At 25 miles. We have a measurement that's 2 orders of magnitude off, and the most, based on empirical data, that refraction could deflect it is a small amount. Now I could say, okay, let's multiply that by order of 10. Still not enough. In fact, I can take the standard refraction value on these measurements, and by the way, I posted the link in the chat. So I could take the standard refraction, the 76R. That would only move the laser down 5 meters. Now remember, I told you the predicted height, the globe predicted height of the laser is 420 meters. So let's subtract 5 meters. Okay, so what are we at now? 415 meters. Well, they measured the laser at 4 meters. How much refraction does it take to move the laser down from 400 fucking meters to 4 meters? Okay, and if you do the calculation, this matches a globe of a 65,000 mile radius. Yeah, so if the globe was 65,000 mile radius, this would confirm that globe. Like I said, there's no justification for the refraction thing. There's no data that supports it. It's just a story. It's an ad hoc hypothesis used not to falsify the globe. Here's the most ironic, two ironic things that I've noticed about this. You want to know what the evidence for globe refraction is?
Sorry, I got a dip, brother.
Yeah, it's that the Earth looks flat. That's your evidence for globe refraction. The flatter it looks, the more refraction it is.
Roger.
That's great evidence. Yeah, peace out.
Right.
And another welcome.
Oh, hiya.
Oh, at least this one talks. The last one didn't.
You remember me, don't you?
Yes.
Alright, lovely.
You got any proof of curvature?
Oh, no. The Earther from last time we were talking about what we think would be out there, whether it's the dome or the ice wall or it's anything else, you know.
Science fiction.
I mean, what could it be, though? What do you guys think?
Could be literally anything.
I'm thinking about the ice wall, right? Like it's where the sun doesn't reach, like, you know, the Earth. Maybe there's different suns out there. I don't really know, but you know, it makes sense that there'd be ice, like a lot of ice, going on for a little bit. You know what I mean?
Well, one of the reasons why I tend to shy away from this is because too many people rely on using the Gleason's map when we know that that is most definitely not the case. The whole Gleason's map is basically flat Earth society nonsense. It's a nonsense because what you're staring at is a globe that's been projected flat. I mean, it's probably one of the greatest trolls that Globers ever propagated was to present this as a possible flat Earth configuration. You know, and what's funny is for the last, I don't know, 10 years, you still have Globers and flat Earthers arguing over it when neither side understands what they're even looking at. But it's that depiction that gave people the idea that there could be a ring of ice surrounding the outermost perimeter of our world. Whether that is or isn't the case is left to be seen. But I do know that if you take a globe and project it flat, that the globe is not true. So the globe that's projected flat is not true. Yeah, and so I just distance myself from all that. You know, so people say, but what about the 24-hour Antarctic sun? Yeah, great. What about it? Where were they? Suppose they actually went. Where were they? How do you verify that they went where they said they were and where even they thought where they were? And so what if the sun does seem to behave in that way, even if you were to assume that they were where they thought they were? What is the sun? You can't triangulate its height above the surface, globe or flat. You can't triangulate it. Now the Globers, right, they'll have the explanation handy. They'll say, well, you can't triangulate it because it's so big and so far in outer space that all the light rays are parallel. So you can't really triangulate it because of that. What's your explanation, Flurf? Flurf, meanwhile, says, I'm not going to invoke magical space rays. That's for sure. I'm not going to come up with a story that I can't verify like you did. So I'm just going to leave it open-ended for now. And you know what? That's perfectly fine to do. Because at this point, we both agree that you can't triangulate the height of the sun or any object, a celestial object above the surface. So, explanations be damned. What do you have left? Well, we got the measurements of the surface. And if I measure the surface to be flat, then I'm going to have a hard time accepting that light rays from the sun are parallel. So what is it? What even is it? How does it manifest? Well, it seems to be observer dependent. And it seems to be observer dependent in a very consistent way, meaning you could go to some location on Earth and you can see the sun rise and set at an appointed time. Multiple observers then on Earth would be able to see the sun rise and set at their own observer-centric point in time. And the sun will not triangulate in 3D space above each of the observers, as far as we know. And we know that they can't do this if Earth is a globe either, hence the parallel rays. So then, the globers will try to model this for us, right? And they'll show the sun how it seems to rise and fall on the z-axis, on the vertical axis, with respect to the observer, and how it's not at any determined position in 3D space for all observers at the same time. It tends to float up and float down, they say. And you know what? I'm fine with that. I mean, fine. If you want to put that forth as an explanation, great. I mean, how is that any more ridiculous than magical space rays, magical space geometry? Which, by the way, has its own set of problems. If you have ray parallelism from the sun in the manner that they described, of the sun that's so enormous and so far away, then how is it you're seeing anything if when looking at it and looking around, you have nothing but parallel rays coming into your eyes? How do you see a point? I mean, there's like a contradiction here. How do you get the parallax effect you need? How do you get angle convergence and change of angles over time in order to discern distance or to discern object relationships? I mean, if you don't have that, you've got nothing but ray parallelism everywhere, then that's an inherent contradiction based off of how we actually see. But we can accept their explanation for the sake of moving the discussion forward, and then just chastise it for being magical space geometry and space rays. If they want to chastise us for having like a magical floating position of a sun that's not triangulatable in 3D space, well, then they've got the same problem. Sure, they're loaded with an explanation that came from 500 years of mathematicians coming up with good explanations. Doesn't make it real, and it doesn't mean that we need to be sitting around coming up with explanations too for 500 years so that we can have a cool story as well. Because the truth of what this thing really is and what it's actually doing lies well beyond outside anybody's realm of capability to actually investigate. So that's why I tend to shy away from this idea that the Gleason's map is a representation of our world, why I shy away from notions of an ice wall surrounding our known world, and why I shy away from using the dome or some kind of spherical sky geometry as an assumption, as a foregone conclusion even. I don't trust any of those explanations, and they don't seem to comport logically. So Oh, I see our friend left who was asking that question. Wonder why he left. You know, some people, some flirts want to keep their space pizza with the dome on top. They love the Walter Bislin rolling hamster ball around a Gleason's map. Sorry, you can't have that. If you're in this discussion and you're going to claim to be one of us, you literally cannot have that. It's just loaded with unverifiable assumptions and incoherent geometry.
Call them map tards.
Yep. I mean, there's a whole
My
side to
opinion
this
of a
community
map.
that seems to be afflicted with this, right?
Yeah, there's some. Well, my opinion of the maps are tools. If you use the wrong tool for the wrong job, well, you're not going to get the job done. It's going to fail.
Yeah, and maps can be good enough, no matter how actually inaccurate they are.
The map and the model. Some of these globals are still stuck in 2016. Oh, the Earth is flat? Can I see a map or a model of that? No map, no model, then no flat Earth.
Yeah.
Like, really? How'd you do that? How does that make sense to you? That you had to completely eliminate reality from the conversation and dive headfirst into some complete abstraction and then say that is reality while not having any map or model yourself. You know, that's the best part. Then just start saying physics and stuff over and over again. Volcanoes, acid rain, just words, and then think that then they've won the debate. And then come back tomorrow and do it all over again. Like 10 years now, like Brenda was just here yesterday. Oh yeah, I've heard you reading about this the other day.
I love it. It's just one of my favorite quotes of all time in the space race. Charlie Wilson calls Sputnik a neat scientific trick. I just can't get over that. It's so deliciously appropriate, especially for us and our objectives in exposing sense. I'm pretty sure they thought this quote would haunt. This quote is buried in time. So, but it takes folks like us to unearth it. It takes folks like us to rub their faces in this. They probably didn't know what direction they'd be going with the space program back then. I mean, the idea of a self-sustaining satellite orbit was talked about long before 1958, 1957. Talked about in the 40s and 30s and 20s. Arthur Clarke, right? I think what's really stunned the world, Sputnik, was the game itself. scientific trick going, what will they do? And the rest is history. I mean, we saw what they were capable of doing. Movie tricks. I'm being told that I'm roboting real hard.
Yep.
Mic check. Good. Okay. Just monologuing a bit, I guess. Killing some dead air, but what a bold claim, though. Like, the Russians were the first to lie to the world about an achievement that wasn't really accomplished. And I would say that you could be a glober today, still be skeptical of this claim, still be skeptical that there's actually anything orbiting a globe Earth. You could still be a glober today. You could still be a glober working at NASA today. You could be read into the highest levels of national security at NASA. Perhaps at some point, you're told that we never actually achieved a self-sustaining orbit for anything, but neither had the Russians and neither has anybody. And here's how we're doing this neat scientific trick. But damn it, we're still going to try because we know it's a globe and it's theoretically possible. So brand new satellite engineer. So Josh Ingersoll, why don't you go work on that? Why don't you go work on actually trying to get a real, true, self-sustaining gravity well-driven orbit? 2026. Meanwhile, we will continue with our neat scientific tricks. We'll continue to use the program, meanwhile, for international security, because everybody that we invite into this program will have to lie to their constituents, to their populace, about the same achievements that we lied about. And if we're all lying to each other, we can all trust each other for fear of mutually assured destruction. Wouldn't that be interesting if truly the mutually assured destruction was not over some doomsday weapon, whether or not it exists, but rather over the destruction of credibility, over these fake space achievements that also involve the use of such weapons? Mutually assured destruction means this mutual lie that we've all formed into a compact with in order to deceive the world and our respective constituents that vote for us year after year is something that we're using to make sure that all of our policies internationally are duly coordinated. If any member breaks from this pact, we will expose the lie and we all go down. Too big to fail. Too big to tell the truth. That's what they've done with this, with the space program. It's become too big to tell the truth and too big to fail. Its failure would mean mutually assured destruction, would mean the instant loss of credibility of all these famed institutions that people put their trust and hope into, the American dream. Can't have that. Can't have mutually assured destruction. So we can't tell the truth either. So we're all kind of stuck with this. Maybe we can try to pivot away from it gradually over time. Maybe that's the goal. So we will make space seem much more difficult than what we did 40, 50, 60, 70 years ago. We'll make achieving space to be dangerous, more dangerous than it was. And we will offer another solution, right? I remember reading in satellite industry magazines and publications how they're going to pivot away from self-orbiting space junk and go back to the future, back to where they were using balloons and trillions of dollars of commerce can be made and achieved in a much cheaper fashion, more expeditious fashion, using more conventional means. We can use balloon technology, high altitude blimps, and can move away from these claims of self-orbiting space junk. We could pivot away from that story. That's what I kept reading in these magazines. And that's what we're reading about today, the commercialization of space. I think we're living through a transitionary period where we're moving away from space being what it was in the Cold War to what space will be for the future, which incorporates more conventional technologies, which is really what it was all along. And it's a brilliant way to pivot. It's going to be expensive. It's going to take multiple generations. But it's going to become even more expensive to keep up the lie as technology matures, as people get better cameras and better means of transportation on the ground. They won't be able to keep up the lie of space, and probably the globe too at some point. Maybe that's why we exist. Maybe we're fulfilling a greater objective, transform people's cosmogonies from this outer space Big Bang mythos to something also more conventional, like the fact the Earth's really flat and space is mysterious, just as humans have always known since antiquity. That's kind of what I think is going on. You know, am I crazy for thinking this?
No, I agree. Kind of seems obvious, doesn't it? So what happens? What happens when you move from being read into some of the highest levels of national security at NASA, where they're like, yeah, guys, but it was balloons and scientific trick. Nobody's actually achieved a self-sustaining orbit even to this day. But hey, newly hired NASA engineer intern, we still want you to work on this problem because we think it'd be great if we could actually, for real, get a self-sustaining satellite orbit up in place. You work on that. What if there's a level higher than that? The level higher is we know that won't ever be achieved either. You know, you've basically got, ironically, Russian nesting dolls of lies and misinformation. So you can have multiple levels, right? At the very bottom level, 98% of people at NASA, at NOAA, other places, right? They think that self-orbiting space junk is real and the globe is real. That's like level 3. And then level 2 is, no, none of that was real, but the globe is still real. And then level 1 is, no, neither of those things are real. And amazingly, what you could do with that knowledge, I think, is quite powerful, right? Because now you can build true coordinate reference systems that actually work for more precise targeting, for more precise asset tracking. You can sell the globe crap to other countries and make a killing. It works good enough, but you're going to keep the other stuff for yourself. You're going to watch as like Saddam Hussein uses stolen guidance technology that operates on a globe and misses its targets, and you're going to laugh because you know the stuff you kept for them yourself doesn't operate under such an assumption. You might even go so far as to build in globes to everything that's used conventionally by the masses. And there's maybe a secret switch that gets flipped underneath that layer of abstraction, underneath that screen that depicts a spherical coordinate system. When the switch is flipped, the user still gets to monitor stuff on that spinning ball on the screen. But the mathematics behind the scenes are taking on a whole different kind of geometry. That's kind of what I think might be happening. I wish I could take credit for that idea. I've heard in very few instances people in our community suggest the same. Jay Tolan, for example. All right, what do we have here? Some space news from Crit. Scientists found 5,000-year-old frozen bacteria. It may be the blueprint for new antibiotics. How about that? How about that? You know what I was thinking, folks, along these lines? Since there are still so many parts of this world that are isolated and walled off and you can't access them without being a special person. One such place being Lake Vostok in Antarctica. There are creatures, by their accounts, living in this lake that bear little resemblance to anything else on the earth. It's because this lake is completely isolated. It's a massive lake, sixth biggest, largest lake in the world, they say. Super deep with lava vents, teeming with organisms. Now, what's to say that if they need to produce evidence of aliens, what's to say that they couldn't go grab a gravy ladle, pull up some very strange phytoplankton from this lake, and then present that as exoorganisms? A frozen lake? Well, it's actually not frozen. Even though it is at like 87 degrees south, right? There's a Russian research base there, Vostok base. It's quite famous. I actually knew two people, one person who went 2 times over there for work. No, he didn't tell me anything. Of course, I didn't really ask. Yeah, so they could just grab a gravy ladle, present phytoplankton that don't exist in any form of its kind anywhere else on Earth, and say, there's your space bacteria. That came from a meteorite. Or that there is what the Mars rover picked up and sent back home. It's Martian. They could say they found this on Mars, and you would have no way to verify it, just like everything else, right? Just have to trust. So they're absolutely loaded for the next phase of whatever this is, if they want to take it there. But will they go in that direction? I mean, they probably could, but it might come down to cost. You know, baking stuff is expensive and risky.
Yo,
What's up?
what's up? Am I understand right that this VC is for like flat Earth supporters?
Yeah, you got it. We've been around about 10 years. We record all of our conversations. We have 2 YouTube live streams. We have a live stream on Rumble and X, and a podcast on, was it Spotify?
Yeah, this is the best place on Earth to talk about Earth.
Well, flat Earth, right?
Just Earth, man.
Just Earth. Okay.
It's Earth, yeah.
Can I ask a question?
Sure, yeah. What's on your mind?
No. I know about like classic, uh, model of Earth in the world or something, position of and I know that we have a planets, solar system, we have this shit universe, and how how I know what I know, and with my feelings, I see it, and I think that I heard, and I think sounds like logically, like possible, crazy but possible. And when I see and hear about flat Earth arguments, or I I do not accept it, but I don't know why, and because maybe because like it is not something like um, you know I do not see it as possible, you know. So can you maybe explain it to me personally how it works?
Yeah, I guess so. Well, it might help to begin with how we came to this idea. About 10 years ago, maybe 12 years ago, it started basically with a camera. There's a camera made by Nikon, the P900. Legendary, absolute legendary camera. They were able to achieve a 2000 millimeter zoom. Optical zoom, not digital. Using a cool trick, they used basically a really teeny tiny sensor. This allowed them to get a very long focal length in a relatively small camera. A 2000 millimeter zoom on this small sensor, they marketed it as an 83x, 83 times optical zoom capability. Really, for the first time in history, the average person could afford to get a camera that could zoom in at extremely long ranges and see things from a distance that they'd never seen before. So people were buying these cameras and they were taking them on vacation to a beach. And they were zooming in on boats. They were zooming in on oil rigs, lighthouses. They were zooming in on the far side of a bay, on islands. And before long, people started asking themselves, and asking the internet. They were posting these pictures and videos on the internet. They were saying, wait a second. If Earth is a globe, how is it I'm seeing this stuff? Because all of these things should be below the curvature of the Earth. But there it is. So people would work out the math. They would take the globe, they'd work out the math, and they'd say, yeah, well, this doesn't make sense. And so the imagery, the videos just kept pouring in. People were trying to come up with explanations for this. Well, maybe it's terrestrial refraction. Maybe it's a mirage.
And so this, of course, led to debates and led to people asking themselves, well, what if this is true and what we're seeing is actually flat Earth evidence? That's how this started. That's really how this whole conversation in this community got itself going. So then this led to people doing other things, potentially more extreme, right? So they would take their cameras.
Oh, what's up, ladies?
They would modify them. So you had then the P900s with infrared optics. And then you had people taking P900s with infrared optics to see through the haze, to see through the refraction, right? They would go up on airplanes. So now they're way up high in an airplane where the air is thin to begin with and doesn't distort that much. And then they're zooming in, hyper zooming in on the horizon. And they're seeing things well beyond the range of what the globe should predict in infrared. One guy even brought in a weather balloon and took his infrared converted camera and attached it to his weather balloon, sent it up to like 120, 130,000 feet. Was able to zoom in on the horizon that way. I mean, just absolutely amazing footage. And before long, I mean, people were basically saying, well, I mean, Earth can't possibly be what we're told. If we're able to see these things quite simply, we see too far for it to be a globe. And that's how this started.
Pop pie, bro.
About 10 years later, here we are. We're still asking the same questions. How can we see too far? We're also asking who measured it, who measured the Earth to be a globe in the first place. Given that we can see too far, that there's no evidence of globe curvature that we can ever see anywhere, how was it ever supposedly measured to have curvature in the first place? People are asking that question today, and we don't have answers. Instead, we get excuses. So you're asking, where we are with this, how we got here. You want the explanation? That's kind of how it happened in a nutshell.
Okay, understandably, but right now you said that how people begin to believe in it, but like my question is, why? Why is Earth is not globe? Is flat? That's my question. Can you explain me if you know?
Yeah, well, I mean, what is the Earth? I don't know. I mean, it's the floor to our existence. You walk upon it, but what is it? Because it's not a planet in outer space.
So the humanity is like do not know about Earth, the truth, right?
Yeah, it's not a globe in outer space, and we know that that's the case. So our ancestors, they didn't believe in a globe in outer space either. So we are reconnecting with our past. We're reconnecting with how our ancestors understood the world to be. I think that's kind of cool.
Okay, so if Earth it is not like globe, there is a question. I think that like logically, why people think that it is not Like
I see.
a flat, it is that it is a globe. Why? Well, like why?
Well, yeah. Why do people think it's a globe?
Yep.
Because of philosophical interpretation. Some of the ancient Greeks, they looked up at the night sky. They saw a black void. They saw the stars, the starlight. They wondered what it could be, but they concluded that the geometry of the night sky was like a ball, like a gigantic black ball, with holes poked in the ball and the light of God shining through the holes. They call this the celestial sphere. The celestial sphere, they teach this in astronomy today. From your observation standpoint, you look at the night sky, you can imagine a dome over your head and all the stars and all the planets and everything. They're inside of this celestial sphere. The Greeks reasoned that, well, if the heavens are a sphere, then below must be a sphere too. Something like it. Yeah. Because, and they had all kinds of metaphysical explanations for this. To some of them, a sphere represented the perfect ideal shape, the ideal form. A sphere has one side in 3 dimensions. Amazing. It's got one face. A tetrahedron would have like 4 faces, right? It's like 3 sides of a triangle in the base. But the sphere, sphere had one face. A cylinder has like 2 faces, or 3 rather. A dome has 2. But they figured if we can imagine the sky as a sphere, then the Earth is likely a sphere too. And that's really how it started. People started to use the stars to map the Earth. And they mapped it under the same assumption that the celestial sphere matches a terrestrial sphere. And as they used the stars deep in the ocean with no other landmarks in sight, no object markers to get your reference from except for the stars, they used the celestial sphere model, and they used it in conformal to a terrestrial sphere. This simple mapping idea, not so simple actually, but this idea is simple, became reified into existence. People started to believe that this model accurately reflected reality itself. So people started to believe the map preceded the territory, that the map of the sphere is the sphere in reality. And so how this got started, I think, had to do with navigation and then later some surveying methods based on how people perceive the stars. Now, are the stars at night really inside a celestial sphere? Whether you think the Earth is flat or not, the answer is no. It's a concept, though. It's a model that can be useful in many situations for practical purposes. But is that truly what it is? I mean, no, of course not. If you believe in the Big Bang Theory, the cosmos of outer space, of course, there is no celestial sphere. It's just a way to conceptualize it. Same thing for flat earthers. Flat earthers know that what they imagine the heavens to be is not necessarily really what the heavens actually are. Yeah, I mean, it started off as a concept. People imagined it so vividly that they started to believe that it was true. And here we are, it's 2026.
Mm-hmm. Mm-hmm. It sounds like mm, possibly, but why the big guys as government, as big companies, as scientists or something, talking that about the globe Earth, not flat, and they like throwing rockets to like space, filming something, sending people to moon, wants to like send to Mars, and why?
Yeah, well, most scientists don't really know anything about this. They believe in the globe like everybody else does, and they take their measurements and their data and they cram it into the globe as much as they can, and it doesn't work, but they do their best. Now, as for all the people involved in the space program, well, that's a whole different conversation. We need to be specific who in the space program is lying about this and who would actually be in a position to know. I don't accept that the Apollo missions were real. I don't accept that they landed on the moon with men who played golf on the moon. I don't believe men played golf on the moon one bit. Nope. Now, those astronauts, they know that they didn't go to the moon, but that doesn't mean that they know the Earth is flat. They could still believe the Earth is a globe. The purpose of the moon mission was to project scientific and technological achievements that didn't exist, that were unattainable. Those scientists involved in that hoax can still believe Earth is a globe. They're not necessarily in a position to know that the Earth is flat.
Do you using like any how it's like like moons, or I don't know how to say it, like people made moons, something like that. I don't know, like Starlink, is it like you know what I mean?
Yeah, what about Starlink, right?
Yeah, why Starlink is exist? They're like just flying around the Earth or around the planet or something. So why they're like in a zero gravity and just they just exist and works.
Yeah, well, I mean, how do you know what Starlink is?
Huh?
Sorry, Yoder.
How do you know what Starlink is? Who is in a position to really know what it is, what it's actually doing? I don't know.
Just big guys just saying that this is a low orbital things that just flying around the Earth and sending and receiving, like information, and just walking. So why is it walking? That's my question. and or
I mean,
you know, like
this assumes you
the
know how it is working.
huh?
Nobody knows. Nobody's able to demonstrate or validate how it's working.
Oh, so
right?
Yep. So you want to say, or you think that Elon Musk is like something like a villain that just you know doing crazy
I
things.
can prove to you right now, I can prove to you
Let's go.
by their own admission, Elon Musk is not in charge of SpaceX.
Oh.
In fact, SpaceX is operated by the president, Gwynne Shotwell. And her husband is in charge of, is like the chief of security for SpaceX.
So?
And working there requires an above top secret clearance. At that level. So, I mean, this means by default, by deduction, you can't independently verify what they're doing. They will not let you. Yeah, what is SpaceX? I mean, what's funny, this was in the news a long time ago, like back in 2012. Google had a balloon project, a communication balloon project, using what they call satelloons. These are satellite balloons. The project was called Google Loon, Loon, Loon. And Google sold it to SpaceX. So what happened to all that technology? I don't know, man. Maybe SpaceX is on balloons or something. Who freaking knows? It'd be nice if we would actually be able to know, but it's not like if you're working there, you can tell us.
So, so why why wait a sec. Why they are sending rockets something to you know to space, or for what, if it is working on balloons, for what, why?
Maybe because it's impossible to orbit something around a globe.
So why they're sending it? Okay, if it is walking on balloons, maybe, but why are they sending rockets, or filming how they walk, opens their
I don't know.
Is
I don't know. I can guess. I can speculate. Maybe the rockets. Maybe they're testing nuclear weapons under, yeah. Except they're pretending that it's for scientific and space endeavors. Who knows? If you take a nuclear missile and you put a NASA logo on it, everybody sees NASA on the missile and doesn't think anything of it. That's just my speculation. But, you're asking me to speculate, and I don't like to do that very much.
Oh, okay, sorry. So, okay, how can I prove personally that I live in flat Earth, not globe?
Water. Use water. The physics of water will never lie to you.
What?
The physics, the raw power in physics, objective reality will not lie to you. People will. People will lie to you, especially people in government, especially people in government of the executive branch, especially executive branch at the federal level. Those people will lie to you all day, every day, and there's very little accountability or oversight for what they when they do wrong. What you can do is use you and water and measure, observe, and practically use the surface of the earth and get repeatable, observable, and testable results over and over and over again. This will demonstrate without a doubt there is no curvature whatsoever. The surface of the earth has no detectable curvature at all. Zero.
So, wait, how how can I pass, like personally, and I don't know, like what I should to do to see that Earth is actually flat.
Yeah, what did I just say? What did you just, okay, what did I just say and what did you just hear?
I hear that something about physics, about
Yeah,
water,
physics, water.
that
You can use water.
how can I use it? How?
Which way does water flow? Does it flow up? Does it flow
Which
down?
way?
Yeah.
It flows down.
Okay, so if you don't have water flowing, what does that mean?
Zero gravity.
Zero gravity.
Maybe I don't know. No, do not flow. Oh, it means that it is like there is
level?
no way.
Is it level?
Level, yeah, level.
Okay. So if you found that the Earth is completely level, completely sea level, what would that make the Earth?
Oh, and then that. So the globe how the concept
yeah, you don't need to worry about a globe concept. Your question was how can you test the Earth? You don't need concepts for that. All you need is water, the physics of water, and then use the Earth. That's it. You don't need concepts. You don't need imagination. You don't need hallucinations.
You mean that if Earth was a globe, the water
It'd be curved, right? If Earth was a globe, hey, hold on.
Just
if Earth was a globe, would it be curved or would it be flat?
What?
If Earth was a globe, would it be curved or would it be flat?
Right now, maybe curved. I don't know.
Yeah, it has to be. It has to be curved. If Earth is a globe, it would have to be curved.
So
there's no curvature. What is it?
I don't know.
It's flat.
Right. So physics. In my school education, said that the something that like I don't know, like turning around them, as our planet, globe planet, globe Earth. So they like I don't know. Wait a sec.
So I think what you're trying to say is like when you have a lot of mass gather together, you have a stronger gravity pull.
You know, they like attracting something that have lower mass. You know, so it means that we have a gravity in this globe concept. It means that any other thing, you know, that less mass of than Earth will you know, like attract to Earth, and as if we talk about water, it means that this water just attracting to center of Earth, globe Earth, and you know, they just do not fly. You know,
we understand. Okay,
you know,
that's great. It's a great hypothesis, but hypotheses need to be tested in the natural world. Right, so we can go out into the natural world and we can see if the water of the earth actually is curving into a ball, and it's not. That's what we're trying to tell you. That idea that they teach you in school it's not supported by the evidence.
Would
you can go out and verify this yourself?
Would you care to elaborate on like the gravity then? Because if what they're saying, if this theory is wrong, and if it's not like a
Not
lot
even
of
a theory, it's a hypothesis.
All right. So if this hypothesis is indeed incorrect, so what would be a more plausible explanation for
We
the
don't need
gravity?
a more plausible explanation. We know theirs is wrong.
So it's just wrong.
Look, it's like this. If I look up into a tree, right, and I see a furry animal, I don't need to know what kind of furry animal it is. I know it's not a fish.
Do you see gravity?
Okay.
I don't see gravity.
It has nothing to do with it. But we should see the effect of gravity, right? Forming water into a ball. Okay. So we should be able to go to the water and measure the surface of the earth to be curving. We don't.
Yeah, but you're not. So you're saying that it doesn't matter, like what gravity is and why it works like this.
Well, there's two ideas. Well, we don't know. Well, I mean, gravity is a whole nother thing. Newton himself didn't even believe in it. So I don't even want to get into that. Okay. So it's real simple. There's two ideas of gravity. There's little g, which we know empirically from dropping something. But there's the other idea that big G, right, the universal law of gravitation, which doesn't come from experiment. It came from a geometric relationship to the Kepler's second law of motion. Okay. You can go on, it is in my opinion, you can go on YouTube and watch Richard Feynman, PhD, Nobel laureate, explain how Newton came up with his universal law of gravitation. Had nothing to do with anything falling. Newton's apple is just horseshit. Never happened. Anyway, the point is that even if you have some crazy hypothesis that gravity does these things, science is an empirical human activity. We would need to go out into nature and test and measure to see if gravity is actually doing that thing, right? We need to test it and check. Or we don't check. We just go with the textbook and don't check.
No, everything has to be tested.
Okay. So what we're telling you is we've gone out and tested it, and the surface of water does not curve. It lies flat and level. You can test it. What Crit was explaining to Mike here is that this can be tested. You can test this yourself. It's a simple test.
So what happens when like a boat leaves China and passes through United States and then it goes back to China again? At a certain point it does like 180 turn and then goes back?
Yeah, it goes in a circle. East and western circles.
I see.
Right? They circle around well, underneath really the Polaris, right? The North Star. And if you want to, the real actual rendition is the whole entire latitude longitude coordinate system is based upon a celestial sphere model. It actually has nothing to do with the Earth. What people have done is they've said the celestial sphere is because the Earth is a sphere. Okay, they've just made this leap of logic. Okay, well, great hypothesis. Okay, let's see if the Earth actually is a sphere and measure a sphere Earth, which no one's actually ever done. See, that's the great thing they say about science, right? Testable, repeatable, verifiable. You can go out. I don't want you to believe a thing I said. I've gone and done my own tests, right? I've gone out and done my own observations. So, Mike, one way you could test this is you probably need a distance that's at least 10 kilometers to be safe. Okay? So if you're 6 feet tall and you're standing at the ocean, the beach, a lake, whatever, the horizon should be, thinking kilometers, it's like 5.3 miles, 5.3 kilometers away. That's where it should be. So if you have a long view, like 10 kilometers, at 10 kilometers, some object out in the distance should be something like, I'd say, I'm guessing, 10 meters under the horizon. I'm guessing in kilometers because you use kilometers, right? I use empirical. I'm trying to do the conversion in my head. I'm probably butchering it.
Okay.
So it'll be 3 miles. At 10 miles, something should be 66 feet under the horizon. So 10 miles is about 15 kilometers. So 15 kilometers away, because of the curve of the Earth, you should not see a 6-story building. Yeah, that's how much curvature there is. See, they tell you the Earth is so big, you can't detect the curvature. But according to what they say, it should be easily detectable. But by the size of the Earth, they say it is, should be easily detectable. Should be obvious, in fact, super obvious. We should, like this channel, if you could actually detect this curvature, this channel shouldn't exist. We shouldn't even be talking about this right now. Because it would be super obvious if we lived on a ball. And when it took until freaking 300 BC to figure it out, freaking cavemen would have figured it out. But one test you could do is that you can get like a friend and like a mirror, and on the internet it's a bunch of Earth curve calculators. You can calculate how much should be hidden at any distance, say 10 kilometers, say 10 meters is supposed to be hidden. You get a mirror on each shoreline and try to flash each other, right? And you'll see that you can see each other at distances that you're not supposed to see each other. But, you do it over the surface of water. I mean, people have done it over land, so it's been done on the Bolivian salt flats. So I'll give you an example. So they went to the Bonneville salt flats, which is in Utah, where they, where the land speed record is, where they race cars to get the fastest they can get a car to go. Yeah, it's called a land speed record. It's the fastest. So the world record is like 800 miles per hour. So this is the place they go to break those records. So it's really, really flat. They went there and they took a laser and they shined it 36 miles, which is probably about 55 kilometers. Right? They're just standing on the desert floor and beamed the laser 55 kilometers. Now, if the Earth was a globe with 3,959-mile radius, that's impossible. But it's not, which is why it happened. Now, I'm not going to tell you to believe us or believe what we're saying. This is the type of thing where, we've all been to school. Everybody in here that's a flat earther used to be globe earthers. This is something you got to do for yourself. The only way to prove something to somebody is to demonstrate it, and the only way you'll ever know one way or the other is to go test yourself. Otherwise, you'll either just believe us or believe them. You'll just always be a believer. I believe the flat earthers. I believe the globe earthers, right? You don't have to be either one of those. You can be a person that knows one way or another. I know the Earth's a globe. I know the Earth is flat. I'm so confident. Like, why am I telling you to do this? Because I know what your result is going to be. I know what my result was. I know what everybody that's done tests in this chat, I know what their results were.
Okay.
That's why, like, when I don't know how long you've listened to us in here. That's why when we get in like discussions with people about this, the people that believe in the globe, what they talk about are planets, stars, sun, the moon. They don't talk about the Earth. They talk about everything but the Earth, right? They go, well, what about the sun? Well, what about the planets? What about black holes? What about this? None of that stuff has anything to do with the Earth. That's why they talk about that. Because if you test the Earth, you find out that it's flat. And there's nothing about the sun, stars, moon, planets that can actually prove that incorrect. The only thing that could prove that incorrect are observations of the Earth that it's not flat, which nobody has. Crit, you in here?
Yep, I'm here.
So, Crit, you know how ballistic missiles work, right? Parabolic arc, all that.
Yeah.
So think about this. I was thinking about this morning. Iran shoots a missile 1,000 miles to, I don't know, Cyprus, Israel, wherever they're shooting it. Now, how does that actually work on a globe? Because the missile's going to have to rotate an extra 15 degrees just to come into the window sideways. Right? The parabolic arc is going to be like horizontal. At that point, you see what I'm saying? Because the surface of the Earth is curving. Now, how do they plot? How are they calculating a ballistic trajectory over a curved surface? All the exercises I did in school, there was always a flat surface. We calculated the ballistic. We never calculated over a curved surface.
Yeah, it's like they try to say the missile goes off a curved surface, goes into the air, then teleports to a globe Earth. Then to come back down, it goes back to a flat surface again.
Yeah, it's 69 miles per degree, so it's like 14.92 degrees in 1,000 miles. So the missile, how is it going to come down? It's going to be flattened by 15 degrees. It's going to be like coming in sideways or some shit. They even have suppressed ballistic trajectories that would fit the bill, but they don't go as far as the distance. Yeah, I gotta look into this more. It don't make sense to me, especially when you're throwing them freaking thousands of miles. I think so. We got so it's starting to. It's going to be warm soon. Like freaking goodness. And like I'm going to be doing a bunch of observations. Yoder's going to be doing a bunch of observations. I think Matrix said he got a camera, so we're going to be doing we're going to start. I'm going to start cranking it up. So I'm going to be cranking out content. So, and DJ, they said DJ used the last one I did against McToon, and McToon freaking spurred out or something. I want to hear that.
Yeah. I'm planning to do this. I'm planning to do the same thing. I'm planning to buy a camera that I can use for infrared and do observations to confirm my optical framework. So all of us are going to be doing some good experimentation that is going to fuck them up.
Yeah, I got plans to make a ton of content this year. I'm gonna be doing tons of just 101 stuff. I think there's a huge gap at the moment where all the like when people come in and they say, "Oh, like, do you guys have some videos we can go and watch?" I don't know what to send them because I don't want to send them all any of the Eric DeBay stuff or the ODD stuff or anything like that. So I'm gonna, I'm just gonna make a lot of 101 stuff, just covering the basic questions. So the same 20 questions they all ask when they come in. So
yeah.
Different time lengths and stuff like that. Right now, I'm working on the McToon debate that I had yesterday. Just got some interesting ideas with that. I'm going to put together my own video where I put.
Where'd you have it? Where was the
What's
debate?
that? Oh,
where
it
was the debate?
QOps, yeah, QOps server. It's
Because someone last night
like
sent me.
Mm-hmm.
Charlie Handsome sent me a link to that anti-truther live.
Yeah, that's where it was.
Oh, okay, that's where it was.
Yeah, I've got the replay. I've downloaded the McToon one, but McToon's audio was cutting out. His audio was cutting out sporadically, like the whole time. But the Anti-Truther League one, the audio is perfect. So splice with
good.
Yeah.
So he was on his stream. He was on his. He was live streaming.
He was live streaming, and QOP was live streaming as well, and it was hosted on QOP server.
Oh wow!
And I was listening to it. I wasn't planning on debating him or anything like that. It was like I was sitting there. It was 5 a.m, and I was listening to him. He was kind of wrecking that. It was DeMarc and people like that in. So he was just making fun of them, making fun of flat earthers in general. And I heard him saying a bunch of things that I was like, all right, well, he's made a bunch of claims, and if I go in there now with some of the information that I have, I can make him, shoot himself in the foot.
To the fire, right?
Yeah, because what he was talking about, I was sitting there listening, and he's saying, "Oh, I did an observation of a sunset the other day, and it was perfect conditions where the water temperature and the air temperature were the same, so that mitigates the refraction." And then we got a perfect sunset because we had perfect refractive conditions.
Oh my god, what a setup, dude. He freaking T-balled it. He set it up like a T.
And so I had to get in there. It was like 6 o'clock in the morning I was so tired, and I'm just like, screw it, I got to get in. So I got all of your stuff saved in my server for that 10-mile observation with the boat. So I jumped in there. And look, right before I jumped in there, he was acting like Mr. Nice Guy, because when he's in control, he acts like Mr. Nice Guy.
Of course,
right? He picks up his puppy dog and he's laughing and smiling. And what he did, he told everyone, I've just demodded someone from my YouTube chat because they weren't being nice to someone. It's like, everyone, you need to be nice to people. And even if people share different views, you just have to be nice, right? It's very important in life to be nice.
He was saying that dirtbag.
Yeah, he was saying that.
Wow.
Yeah, once I heard him say that's when I had to jump in, because I knew he was gonna spiral. He's never spoken to me before, so I jumped in. I was being super polite, super friendly, and I was just laying out the observation step by step. I stayed super calm, and I was just going over all the details. He was very patient. He was being very nice to me, letting me letting me pull up all my files and go over it all step by step. And then once he realized he started to get cornered, right? Once he started to click that I had all of the things that were pointing towards it not working on a globe, that's when he just turned into this freaking goblin, man. He just
Goblin?
he was yeah. Oh, it was crazy. It was crazy. Have you guys seen those foreshadowing videos?
No.
Foreshadowing? It's
No.
it's like a guy is he's in it. Basically, it's a situation where someone's talking about doing something and it turns into an absolute disaster and they start freaking out or something goes wrong. And it shows them talking and then it starts showing clips of them freaking out while they're talking. It's called foreshadowing anyway. But I'm going to put that at the start of my video that I'm making right now because he went to madness for no reason at all. I just stayed super calm and polite and he was freaking out. He called me, he was just, once you listen to it, I won't spoil it.
Oh, I can't wait, man.
Kind of funny.
Yeah, man.
Yeah, it'd be good if we could we could just play it through the bot and listen to it sometime in here.
I'm looking forward to that.
Yeah.
I listened to it. You're great. Like you remained completely calm. It was if someone didn't speak the language and they were just listening, you clearly won just by that because you just remained calm and patient and in control and you just sounded so much more confident. And he was slimy.
Yeah, he was trying to be slimy and I made him contradict himself a bunch of times. Like firstly he said he had a gotcha, right, in your observation. He said, how come I can see a buoy off in the distance when the camera pans over to the left and the bottom of it's missing behind the horizon? It's like the furthest one out. And I started saying, well, that's absolutely ridiculous, right? Are you saying that you can't have bottom-up obstruction on a flat surface? And he said, yeah, you cannot have, it's impossible to have bottom-up obstruction on a flat Earth.
Mm-hmm.
And like he was just setting up for failure right there because I started getting into sinking refraction. I asked him, do you know the definition for sinking refraction? He said yes. And then he laid it out exactly how it is described by the mainstream. And so I was like, okay, so that means that something could appear to disappear bottom up. Like I read out a bunch of definitions. I said, so something could appear to disappear bottom up on a flat surface. Yes or no? And he just went silent. He wouldn't respond. It's actually, it's kind of funny. I won't spoil any more.
Oh my God. I've been trying to get them to admit that for freaking 10 years.
He admitted it. He said, so first he said it's impossible to have bottom-up obstruction, and then about 10 minutes later he said you can have bottom-up obstruction on a flat Earth. He was forced into it. He couldn't go against it because he would have,
How long till it's ready, dude?
Yeah,
he's been trying to avoid that one for years.
Yeah, I'm working on it right now. It should be ready in a couple hours. But I mean,
take your time. There's no pressure. I mean, we're chomping at the bit, but seriously, no pressure.
Yeah. I mean, all of the audios, like I got that right now. You can just skip to the part in the live stream and listen to the whole thing anytime. I'm just putting together a better edit of it, but I've got a crisp, clear audio version on QOps live stream, and we can just play it now if you want, or later or something.
I know. Well, I don't want to steal your thunder, man. Are you clipping it, or are you just gonna play it like?
Oh no, that's fine. We can just stick it on now. That's fine. That way I don't have to rush my production.
You didn't have to rush anyway, man. You be thinking about these guys. They're fucking on me. Gotta get this out.
I just want to hear him get fucked. Come on.
All right.
I mean, I have to grit my teeth waiting for listening to Matoon's voice.
It's good. It would be better. Yeah, it's good to watch his expressions on his face.
Yeah, I bet.
It's kind of funny. But I'll just bring it up now. Here, I'll just check what time it's at. We can just seek forward on the bot, right?
Just remember, once you finish the video, once you've edited it and stuff like that, to let all of us know so that we can publicize it and let everybody know so we can watch it.
Awesome. I will. Yep.
So can I make an animated clip out of it? I'll make McToon a goblin. A goblin.
Lovely.
Was it Reef you debated the other day? He fucking snuck off somewhere to that server.
Yeah, he ran away. He ran away.
That was good. That was good, man.
I didn't listen. I can't stand his voice, man. He's such a fake dude.
Yep.
I just get angry listening. He is intentionally deceptive, and I can't stand that. It's like somebody yeah, I'm gonna go in there and they say it nice for some reason because they're saying it in a quiet, mild, meek tone of voice. That somehow they're not saying something bad because they said it quietly. No, dude, you're being completely disingenuous and basically stretching, manipulating, lying by omission in a nice voice. Like, just because you're not boisterous about it doesn't make it any better.
Yeah, it's like those annoying bitches who talk in baby voices and go, "No offense," and then say something atrocious, and you're like, you do realize
Yeah,
just saying no
exactly.
offense in the beginning doesn't justify the rest of it, you know?
Yeah.
You're going to get triggered at what they're saying at one point.
I'm already triggered.
You're going to get triggered at one point. Yeah, but then it gets...
Am I in it? Did they mention me? Did I get a cameo?
Yeah.
Oh, dude, really? Yeah,
It's
it's
all about you. Yeah.
Oh, fine, Sunday. Yeah.
Oh, hell yeah.
I'm just trying to find the exact point where it starts.
It made me so mad I had to pause it several times. So just be prepared.
Oh, dude, I love it. I love the hate boner, man.
Yeah, because I was listening to him. He debated QOP. Yeah, he debated QOP on QOP server, and I remember him saying one thing. Like, he was kind of walking over QOP because QOP's kind of new to FE. But he was saying how why are all flat earthers such pussies that they can't present single long distance observation and then go over it, right, and put the math to the test, put the globe math to the test. Why are we all such pussies that we can't do that? Isn't that what we do every?
Yeah, you told me about that. They said that. It's so ridiculous, man. Just it's like it's like when they say there's no evidence for a flat Earth. It's the most ridiculous thing. It's like they're gaslighting.
Yeah. They have to be, right?
That's why I just asked them. I go, well, why do people used to believe it in the past? And what they'll say is, well, they were stupid. Yeah, but they still believed it based upon the evidence they had. It looked flat. That was evidence, right? That's what they based. So there is evidence. You might not agree that evidence proves the Earth is flat, but it still is a piece of evidence, regardless.
All right, I got it ready. What's the command for the music bot in this one? / or? / works.
Yeah, it's /
All right, and then I'll just start it, and then I'll seek it to 1 hour 32. A second. Work.
Sorry, I concede you win. You flat earthers are superior to my humble globe zealots.
You guys hear that?
Well, no, I just he probably has him muted. That might be the logical thing to do in those situations.
That's why. Well, I have
time lapses, and so like the first time lapse is, an hour or so, and the second time lapse is 2 hours. So each time lapse gets longer time embedded in the time lapse. So all right. Here we go.
Oh, so you can see the trails, but you can also see them moving.
Yeah. All right. I have, it's on my Dropbox, but I have Dropbox off while I'm streaming. So I'm sorry, I can't pull it up right now.
Yeah. If I could jump in for a second, I don't mean to change the topic, but if we could maybe go back to the you wanted some flat earthers to present some observations that are credible for flat Earth.
Yes, that'd be good.
All right, I got one to present. Can you hear me properly? I got to speak quietly because it's 5 a.m. here in Poland.
Yeah.
All right, so I'll be quick. I'll grab the observation and I'll just present it. I'll present it in the side chat so it doesn't get lost in the text chat. If that's okay.
Okay.
All right, just give me 1 second. I'll present exactly what I was presenting in this debate in the live stream voice text. Near Boston.
Dude, you're the best. Thanks.
All right, so I'm going to post the first image. All right, so this was taken from 15-foot observer height. Okay, this is a Nikon P1000. In the side chat.
Oh, there it is. Okay. All
right, cool. So we got 15-foot observer height. We've got a Nikon P1000 with that's been infrared converted. Okay, and we have a. All right, just 1 second. I just paused it for a second so I can bring up my Discord on a different browser so I can just copy paste everything straight in.
Okay, just DJ, just to correct you, it's not an infrared converted P1000. It's a full spectrum P1000 with an infrared filter.
Ah, okay.
Now, an infrared converted would mean like they put the filter right on the freaking sensor. You can do that. You can get the film. So you take the infrared cut filter off. So the sensor has a film, an infrared cut filter film. They peel it off. That makes it full spectrum. They can convert it by taking an infrared filter and applying it right to the sensor, right? And then you have an infrared converted camera. This is a full spectrum camera. They just took the film off. I changed it into an infrared camera by putting a filter on a lens filter, instead of a sensor filter. There's no difference. I'm just saying.
Gotcha. I'll remember that for next time. All right, just a second.
The good thing about it is that you have flexibility because I can buy any number of infrared filters, right? 750, 830, or 840 or something, or 850 and 930, and they make even 1100 ones.
If you do the internal conversion, can you still use it normally, or is it just infrared completely?
I think it's just stuck on infrared.
Oh, that's ridiculous. Yeah, I'd definitely not do that.
And with the filter, you could cut like all the UV because the multi-spectrum it'll pick up the UV unless you cut it out. So you could get a UV and infrared filter that would turn it back to a normal camera, basically.
Well, Toon says infrared doesn't mitigate refraction.
That's their new thing, man. It has no effect on it.
All right, ready? I'll hit play again. Go. 15-foot observer height, like I said, and we have a ship track in the distance. Okay, we can see the distance markation on Google Earth, and then we can see the red line, right? That's where the geometric horizon distance would be. Globe.
Okay.
Now, all right. So now, right. Next up, we have the ship. All right. So this is the screenshot from the ship tracking. All right, just a moment. Here it is. Okay, so we have the coordinates here. Scarlet Isabella. And if you have a look, the coordinates match up on the Google screenshot.
Okay.
Okay. All right. Next up, we have a buoy that's basically between the ship and the observer. Okay, and the time that the observation was taken was around 3 p.m. And we have a reading from the buoy of the water temperature and the air temperature at 3 p.m. So I'll just post the data from that in the side chat. 1 second. All right, so here we go. There's that. And the temperatures. 1 second. It's the next one. All right, so we have air temperature 45 degrees, and we have the water temperature 45.9. Pretty close, right? If anything, it would work against flat Earth, right? We could have a slight bit of upward refraction, maybe. Okay, so now.
Well, all right. How far up is the air temperature? At the top of the buoy?
Yeah, so you can see a picture of. Well, it's just it's reading the air temperature. Yeah, it's probably not too far up above. Yeah, I'm not sure how tall the buoy is. Could look up the height of the buoy, but
okay.
Yeah, it's the reading that would go onto the weather report, that kind of thing for that particular area. Okay, so next up, all right, so here's just a picture of the clock. So a picture of the clock was taken at the location just to show you that the observation was done at the time that buoy reading was taken. Right, so the guy that did the observation, he specifically, like you did with your sunset, right? He waited to find a day that was going to have pretty much uniform water and air temperature, and he's using the infrared as well, which helps a bit. All right, cool. Okay, next up, just a picture of the camera setup. Sorry, I'm a bit unorganized with this, but in just a second. All right, here's the camera setup. All right, so now I'll grab this is just a GIF of the observation. There's a ton more footage than this, but this will be helpful just for the presentation. All right, so we got did that post? Oh, 1 second. All right, it's just uploading now. All right, so this is the observation through the infrared from that camera. And what we'll see is we'll see the ship that's 10.6 miles out. Okay, and you can see the whitewash on the bottom of the ship. The ship's 10.6 miles away. And we have the geometric horizon distance should be at about 4.6 miles. Now we've pretty much mitigated the refraction issue as much as possible here. If anything, the refraction works slightly against FE.
All right. What was the the distance to the ship?
10.6 miles. Right, so it should be about 22 foot hidden, something like 2 stories, 2-story building, a bit more than that.
Yeah, I wouldn't.
Was the buoy also at 10 miles?
The picture of the buoy, okay, with the data of the buoy, you can see the buoy just there. It's basically in between the ship. You can actually see it when he zooms in.
Who was the original source? Was this a YouTube video or where did you get
it? No. This was my friend. You guys probably know him, Indio.
Oh yeah, I know Indio.
Yeah. What's up, Jesse? Good to see you, man.
Good to see you.
All right. So yeah, I can post Indio's video of it. 1 second. So this is This is his video. It might have a bit more footage than I showed. If you contact Indio, he can show you a ton more footage of it and give you a bunch more details. But here's his video about it. All right, so with that, water to air temperature, like we really, I mean, to have this work on a globe, you would have to have a refraction coefficient of something like 0.8, right? Like a huge amount of extreme refraction. We don't have the conditions. We don't have the meteorological conditions.
I get
present.
about.
Mm-hmm.
I got about 0.3 as a necessary refractive condition for that.
All right, so I'll just pop in a screenshot from Walter Bisland's. A second.
According to Andrew Thomas Young, it takes about 0.13 degrees centigrade per vertical meter to have circulating rays. In other words, the ray of light matches Earth surface. So, and it wouldn't even need to be that much, since the observer was not at they were a few feet above. So it wouldn't.
Well, the observer's at 15 feet, right? And we have what would cause upward refraction. Okay, so it would work in reverse to that. So we're not going to get.
But now, why did you put hidden 0?
Hidden 0?
Yeah, that's why it's got hidden 0.
Oh, that's because okay, yeah. Okay, cool. So what I did with this one was I slid the refraction slider up until the boat had 0 hidden height. Okay, and that would have so to have 0 hidden height on the boat, which we see in the observation, you would have to have a refraction coefficient of 0.81. I mean, even if we put in 0, even if we put in,
I'm not seeing 0.
Okay, we can see the whitewash from the boat. Yeah, we can see the whitewash from the boat at the bottom very clearly. And to have 0 hidden height, basically you would have to have a refraction coefficient of 0.
But I'm saying I don't see that it's 0 or that everything is seen.
What do you mean? There's nothing obstructed, right? It would be obstructed behind the horizon. The horizon should be at 4.6 miles. Okay, we don't see a horizon in front of the ship that's blocking anything because we see the whitewash from the ship. And also, the horizon should be 4.6 miles, the geometric horizon.
So what would be the hidden height? Assuming
22 foot, assuming no refraction, with standard refraction, which shouldn't be possible in this case because we have what would cause upward refraction. So obviously we're not going to have 16%. We're not going to have that downward refraction. But so even with standard refraction, it would still be the bottom of the ship would still be hidden by a certain amount, and the geometric horizon wouldn't be much further away. Okay, it would be 14% further away.
How high was the observer? The camera?
15 foot.
In the boat.
Yeah, with standard refraction at 16 feet hidden. How high up on the boat does the whitewash go?
It doesn't look very high in the observation. I don't know, have another look at it again. I mean, it's probably not something you would be able to measure exactly.
Yeah, like, do you have a picture of the boat from fairly close that you can compare the two?
Yeah, I think so. Again.
So what we could do is, if we know the boat and how tall it is, we know how many degrees per pixel in the vertical, and so we actually could tell how high that whitewash actually is appearing.
Right. So this is a horizon test as well, by the way. This is a geometric horizon test. Okay, so you would have to say that, like, where are you seeing the horizon? You're not seeing the horizon in front of the boat because you're seeing the whitewash. The amount of refraction you have a horizon at 10 miles, okay, that would be 0.81 refractive index. We don't have the meteorological conditions present to have that.
Well, you have a very limited snapshot of the meteorological conditions. Just to be clear, to be fair, you have one point of temperature above the surface.
Yeah, but it's in between
and you
point
don't
A
know
and
the
point B.
elevation.
Well, it's in
But
between.
you don't know. You don't have a vertical temperature reading, so you don't know. Is it colder another foot up? Is it warmer another foot up? You don't know that. You don't know even the height of the air temperature reading. So you don't know the meteorological conditions, so you can't say definitively that there is zero refraction happening.
Okay, well, what we do know is that we have warmer water than the air temperature. Okay, that would cause upward refraction. Okay, this is better than any observation from any globe earther that I've ever seen. We literally have a buoy that's giving a reading right at the time of the observation between point A and point B. It's not bad. Like this is a decent quality observation. Also, we're using infrared as well. Right?
I don't care. Infrared is nice because it's a limited wavelength. It reduces chromatic aberration, which is really bad in the Nikon cameras. But it's not magic. Infrared isn't refracting less in any quantitative amount that's going to matter.
No, I get it. I just remember you were saying earlier that you had almost perfect conditions in your sunset observation because you had 1 degree difference between the water and the air temperature. I mean, you're doing that over a huge distance as well, where you could have a lot of fluctuations in the water temperature and the air temperature between point A and B. Okay, so this is much closer. It's only 10 miles. So, I mean, we're not seeing any sign of that geometric horizon. Okay, we don't see any miraging effects or anything like that.
Well, we do see a horizon, which is impossible on flat Earth. Number one.
Oh, that's the most ridiculous thing I've ever heard.
You can't have a crisp horizon on flat Earth. It's 100% impossible to have a crisp horizon on flat Earth.
Yeah, horizons aren't very crisp.
You're talking about the horizon.
If you zoom right in on a horizon,
this horizon
not
is crisp.
Yeah, it's called a vanishing line.
But the one you're showing me is crisp. That's just an art class technique. But you can see the actual in your picture. You can see the waves.
You want to deny perspective.
You can see the individual peaks of the wave. No.
You can't have a horizon on flat Earth. That's the most ridiculous thing.
An art. That's right. It would be blurry.
It is blurry when you zoom right in on a horizon. It's
stopping
blurry.
The light from the 1,000 mile away, other than the blur of the air.
Well, you're kind of getting a little bit off track right now.
So you would never have a crisp.
You meant to be talking about this specific observation.
You said this is our
horizon.
No.
So now you've changed the topic. You've changed the topic from whether you can have a horizon on a flat Earth or not. See, now you've changed. You were just saying you were just look. I'll mute you, dude.
Quoting you, dickhead. Quoting you, dickhead. Quote: "This is a horizon test." Unquote.
I'm going
words,
to mute you
dickhead.
if
don't. I mean, you can mute pretty much everyone, but not make me stream.
Hold on a second. Just for a second, right? I'm gonna unmute you in a second, dude. Don't start screaming, dickhead. You just gave stop someone having mod powers on your server because you told him that you're supposed to be nice to people. I've been nothing but nice and respectful since I came in here, and now you're just screaming and calling me a dickhead. You're making yourself
Go back
look terrible.
to the part where you said you're over talking me, and you are the one that brought up the topic.
Me.
This is a horizon test.
Yeah, a geometric horizon test.
Did you not say this is a horizon test?
Yeah, for the globe.
Did you say that?
The geometric horizon test.
Got it.
Yep.
So we're talking about that. So we're looking at the crisp horizon, something that doesn't work for flat Earth.
It's nowhere to. This is a globe test. Don't worry about flat Earth.
So you falsified flat Earth in this observation.
How so? You're coping
the
hard
flat Earth
right now, dude.
This.
At least I made you
the crisp horizon.
I made you lose your shit by being calm and just showing you an observation. You started screaming out.
No, you were an asshole over talking me.
No,
you were an
were
asshole over talking me.
Dude, you start screaming dickhead over and over again.
The topic of the horizon, and now,
Thanks for the clip, by the way.
You didn't look at
Thanks for the
everything
clip.
either.
You made
On the
yourself
left,
look like a fool in this.
to the left,
Yeah, what
to the
about it?
left of the boat, there's a buoy that's obstructed by the horizon. That's not possible in flat Earth.
Yes, it is. Have you not heard of sinking refraction?
No, it's not.
Have you not heard of sinking?
Oh, now there's refraction.
I've never said there wasn't
now
refraction.
there's refraction. Oh, got
so
it. Now there is refraction. First there was no refraction, and now there is refraction.
No, I
How
said you don't have the
for you.
This is what I said, right? So I said you don't have the conditions present to have the extreme refraction that would be required for this observation to work on a globe. I don't deny refraction. It's my favorite topic to talk about, actually. We could talk about refraction for hours if you like. But how come you can't be nice and just have a normal conversation?
Whatever refraction needs to do, it does it for you.
No, I'm not saying that at all. I'm just saying here's an observation. I'm just presenting
you are.
the
100%. That's what you're saying.
See, when you get cornered, you turn toxic.
No, you've falsified flat Earth is what you've done here.
Globe-tard, you're making
Because
stuff
you
look really
can't
bad
have a
right now.
horizon, and you can't have that. You can't. I just said it, and you can't have a buoy blocked.
Yes, you can.
I don't know why you can't have a crisp horizon on flat Earth.
Yeah, you absolutely can, and you can
because
have
there's
sinking.
nothing between you and the distance horizon, so you're just going to get the blur.
Can I explain this one?
Due to the atmosphere going. Yeah, go ahead.
So the horizon is the eye level with you. It's the center of your spherical vision. The hemisphere is above. You guys turned it into you guys took that hemisphere, the sky hemisphere, and you duplicated it, you mirrored it onto the ground, but beneath you. But either way, so it's a sphere. You see in a sphere. The horizon is a center point. So no matter what world you live in, that center point is gonna have a limit to it because the sphere is spherical. It's not a Euclidean infinite vision God mode. So because you're standing on the ground, because the ground is basically very close to that eye level horizon center of your vision. It being close to the horizon is going to cause things to disappear bottom up because the angle from the things farther than your limit are basically converging into. Yeah, I think converging would be the right direction. Converging, maybe. Either way, it's basically intersecting with that limit of where you can see, and optically you're getting basically a cutoff close on the bottom because the ground is already basically at the center of your vision. Therefore, the things that you can see below it are less than the things you can see above the ground because there's nothing in the air to really cut off things. So that's why when you go higher in the air, you could see farther.
I would also like to add, if you go on Google Earth, where the canopy is where he's at, I put it in chat. It says 9 meters, so a little bit more than 15 feet. Just like last week. Remember that?
Yeah. Clearly, it's not 9 meters. And last week,
I remember that.
Yeah, so I looked that up. So in the forget the exact name of the channel, BLSM 69, whatever it is. Okay, that was done in 2019. Okay, and it said 8 foot on his Google Earth screenshot. Okay, now they change the data sets sometimes. Okay, and in coastal areas, it can change by a couple of meters. It's not uncommon for that to happen. So it showed 2.3 meters higher in 2026, right? So if they change up the data set,
how do you know that?
Because I looked it up. It's common for that to happen.
Hold on a second. No, I understand what you're saying. Are you saying that it read 2.3 meters lower 5 years ago?
No, I just see that in his video he took the screenshot from Google Earth, and it said 8 foot. Okay, and now it says 5 meters, but that's 2.3 meters different. and they change data sets sometimes, and that affects areas close to the coast.
DJ, there's a comment less than 2 months later that says the exact same thing as I said. So you want to try that again?
Yeah. Post the comment.
Okay, sure.
Anyway, I'd like to continue talking to McToon because he doesn't seem to think you can have bottom-up obstruction on a flat surface,
Well,
which
no,
is
why are you running away from your claim?
Well, I was
now
talking to McToon. I was talking to McToon. I logged on at 5 a.m. in the morning to talk to McToon. We can go over that after I finish talking to McToon.
Oh, but wait, your claim you just presented has the elevation off again. The observer elevation is off again. Well, why is this a common theme with your presentation?
Well, you haven't showed the evidence for this, right? Show exactly. All right, let me have.
Yep, look at 10:46, or sorry, 46 after the hour.
Yeah, where's your marker? Where's your marker placed? It doesn't show it.
I don't know why I didn't capture my cursor, but my
Not your cursor. You should put a little marker there, right? So it's.
Yeah, I'll go back and do that. But it's right over the canopies where he was taking the pictures at.
Which canopy? You need to put it on the exact spot that he was at.
Yep. Yeah, it's right next to the clock tower.
Right. So also, Indio was extremely careful with this observation as well. Like he made sure he even took a picture of the clock.
Yep.
Okay. He's not going to lie about the elevation.
Okay.
It's dude. You know, Indio is not a liar. Anyway.
Oh, he is a liar.
That is well done.
You're a. If you think that.
Oh my God, that's so funny.
If you think that you can't have bottom up, if you think you can't have bottom up disappearance on a flat surface, that's ridiculous. Let's go over it. I got citations. I can show you demonstrations right now of bottom up disappearance on a flat surface. What's the definition of sinking refraction, McToon? What's the definition? Do you know it?
All right.
I can tell you.
It's where. Yeah, it's where you've got an inverted index of refraction gradient.
And what would cause that?
And it can cause things to be lower than higher. That would be where you have a higher temperature air low to the ground and cooler temperature air just above it.
Okay, so do we have that in the observation? We have a degree difference, and then the buoy that you're talking about.
We don't. No, we don't have the data.
We do have the data.
We have one air temperature. That's it. One air temperature.
Okay. Right. So the air temperature is warmer in the.
That's
okay,
it.
So it is between point A and point B.
One air temperature.
Well, it's not the opposite, is it? So you don't have cooler air temperature than the water temperature.
But how high above the water was it?
I don't know exactly. It's the buoy that you can see in the observation.
Oh.
Right between the ship and the person.
So
okay, but so the buoy in the distance. You just said you can't.
Is it 1 foot above the water? Is it 10 feet above the water? And what is 20 feet above the water? Don't know.
Look up the buoy. So you made a claim
earlier. You want me to do your work? You want me to do your work for you? Got it.
Hey. Notice what you're doing right now is you're talking over the top of me because you're too
that's
scared.
Like DMOC.
You're too scared. No, you're too scared to have a normal conversation, so you have to keep talking over the top of me. It's pathetic. Great. So you claimed that you can't have sinking refraction over a flat surface, but you just said when you have an inverted refractive index, okay, an inverted temperature gradient, you can have bottom-up obstruction, and that would happen just the same over a flat surface. Okay. The definition of sinking refraction is something that would normally be visible on the geometric horizon or geographical horizon, apparently sinks beneath it, even though the line of sight is geometrically unobstructed. So you lied just then when you said that you can't have bottom-up obstruction on a flat surface. I can show you demonstrations on a flat floor as well, where you add cool air up into the top portion of the room, and you just let me finish. Just let me finish talking, and then you can clarify.
I'll not clarify then.
That's how a normal conversation works, right? I finish talking, and then I wait for you to finish talking, and we have a normal conversation that can be a friendly conversation. Okay, so if we have those conditions, we can have bottom-up obstruction on a flat surface. Do you agree with that or not? Because you just said we couldn't earlier, so now do you still stick with that? Because you just said that we could, basically.
I'll let you finish. Then I'll have my rebuttal.
I asked you a question. Obviously, I'm finished if I asked you a question. You got to answer
Don't
the
care.
question.
Finish
though,
your
right?
presentation, then I'll talk.
I just asked you a question, and you went silent because you didn't want to answer it because you would have contradicted what you said earlier.
I wanted to clarify my point, but you don't want me to. You just want to ask me a question and then continue talking. Not going to happen. When you're done talking,
I didn't.
let me know.
I didn't.
Then I'll
I
have
didn't
my
continue talking. I asked you a question and then I stopped talking, and then it was just a silence, right? Because you didn't want to respond, because you know the answer is yes, you can have bottom-up obstruction on a flat surface, because you just stated that you could earlier when you have sinking refraction. I can demonstrate it on a flat floor right now if you want, and just show you that you can have it. But you already know that you can have it.
I will know. I guess I won't.
You sound like you're upset now.
Are you ready to let me talk? Are you ready to let me talk? Are you ready to let me talk? Mute yourself and stand by. Okay? Mute yourself and stand by. I'll wait for you to mute
question. Just
yourself.
answer my question.
I'll watch. I will
Answer my
watch
question,
for
or
your
you're just
icon
showing that
to
you're a
turn
liar
red
if you don't.
so that I know that you won't overtalk me. Just
All
go
right.
ahead.
Just
Mute
mute
yourself so I
yourself.
know you won't be overtalking me.
No, you can answer my question first.
So
I
you
asked you a
don't want to
direct
mute
question.
yourself.
Just say yes or
and
no.
So you won't let me talk.
Come
Got
on.
it.
I asked
You don't
a
want to let me
question. Why are you scared to answer my
you
question?
won't let me have an. I'm not
Dude,
scared
you're
to answer your
you're
question.
so bad
You are
faith.
scared
Yes,
to let me have an uninterrupted response to you. That's what
No,
you're
you
scared.
can answer the question and then go on your
Go
rant
ahead.
with your whole
Mute
response.
yourself. Mute
Just get to the
yourself when
point.
you're ready to
Answer
let me talk.
Argue. Stop the
Let
squabbling.
Nick
Get to the
Toon
point.
go, please.
All right. To clarify my point about you can't have a buoy blocked beyond the horizon, because you were making it a point that this was a geometric test. If it's a geometric test, that means that you have excluded refraction, that you are not including any refraction conditions in this at all. But now there is refractive conditions. You've changed your story, and you do not have the data available to determine. So you're conjecturing. That's fine. You can conjecture. I can conjecture too when that's all we have. Now, it is possible in the right conditions to have something blocked on a flat surface, but it is a rare occurrence because you have to have the less dense air near the ground and the more dense air above it. This is an unstable condition, and you see lots of visible artifacts when this happens because the air wants to be swapping back into places. So you get layering, you get slicing, things like that, like you see in the claimed black swan. That is indicative of that type of. Oh
no, you would have the
your
opposite.
turn, I guess.
You would have the opposite refraction in the black swan. You would have to have looming in the black swan, not sinking. Right, so you just contradicted yourself, right? That was a silly thing to say. So you guys have to say in the black swan that you would have downward refraction, not upward refraction. So what you just said was pretty silly. Thank you for the clip, though.
Well, I was in the middle of talking, and you, being the asshole that you are,
well, you've been
jump right in
bullshitting.
again
Well, you've been bullshit. Everything you said is bullshit.
Over-talking me. Asshole won't stop talking over me.
You were screaming "dickhead, dickhead, dickhead" earlier, like a pathetic child.
You are a dickhead. You are an
Why?
asshole dickhead.
Well, I've been nothing but nice.
You're pretending to be nothing but nice, but you won't let me talk.
Because
you weren't even listening to me.
Yeah, I was listening to everything you were saying.
You won't
it was
listen
all
to me.
bullshit.
You're just over-talking me. You wouldn't let me finish. You had to jump in. Why don't you and
funny how
D-Mock go and have a little parade of over-talking people?
Funny how you turn into this freaking gargoyle type character when you get cornered.
I'm not cornered. You won't let me talk. You jump in.
You sound pretty triggered to me.
Well, why don't you shut up and let him talk?
Because he's bullshitting, right? He just said that in the Black Swan we have upward refraction, and he said in the Black Swan we have upward refraction because it's chaotic. Because
no, I didn't, asshole.
Yes, you
I didn't
just
say
said
that, asshole. I did not say that, asshole.
It's recorded.
I didn't say that, asshole.
You never said that.
He did. It's recorded. It's going to be clipped, right? This is a great clip. I'm enjoying this.
Shut the fuck up and let him talk.
Here's what I said.
You shut the
Stop
fuck up.
talking. Stop talking. Stop talking. Stop talking. Okay, asshole? Stop talking. I said you get visible artifacts when you have unstable conditions, like in the Black Swan. I didn't say sinking. I said visible artifacts, asshole.
No, that's not all you said, right?
Now let's talk about your 9 meter observation height.
No, he hasn't. He doesn't know that that's the exact position that India was standing in.
Well, he put in right here.
No, when he put 19, when he put the 9 meter one, we don't even see the
pin right there that he put in.
What is that? Where
and
India
over
was
here
standing?
we have the 9 meter.
Is that where India was standing?
I don't know. He got the picture there. He got the awning out on it.
That's the
How
clock,
does he know
right?
that?
That's the clock.
No, that's a clock that he. So he walked and he took a picture of the clock, which is in. That's not where the camera is, right? You don't know where the camera is. You're just guessing. You're just guessing.
Walked 10 miles to take a picture of a clock, then walk.
Why would it be 10 miles? Why would it be 10 miles? Where are you getting that from? That's just ridiculous.
If you look at your picture, he's in a covered canopy area. There are 2 covered canopy areas around that picture.
But you don't know exactly where this one is. You don't know where this one is. You're just guessing. It doesn't look like it's 20 meters high from where he's standing.
We have to guess. We have to guess because he didn't do the detail. And it's not 20 meters. He said 9 meters is what he has in that picture there, right?
Yep. And there are 2 canopies right by that clock. There are other canopies up and down the beach, all of which range between 8 and 10 meters. So.
Oh yeah, you checked them all, did you?
I checked 4 of them. Yep. If you want to find another one that's smaller than that, go ahead. That'd be weird.
All right. Well, look. This is what I'll do, right? I'm not here in bad faith. I'm not here in bad faith. No, I didn't. I was presenting an observation. No, I presented an observation that someone did, and he had a screenshot from Google Earth that said that the elevation height was 8 foot. Now, you guys, you hardcore conspiracy theorists, right? You're saying that he photoshopped that in or something like that?
That's so good.
Well, that's what you guys say now. These observations have to have been faked because they destroy the globe, right? So that's why you guys are coping about these things. You happen to say that the flat earthers are lying because these observations wreck the globe. So you guys have to say, the flat earthers are faking everything.
Flat earthers lie. They do lie.
You lie. You just lied. You said you can't have bottom up obstruction because you said the buoy. Right, we can see a buoy way off in the distance that's obstructed. Don't talk over me. No, look who's just talking straight over the top of me. Don't talk over the top of me. Let me finish my sentence.
You just want to make like I'm lying because
no, you're cornered again.
Your narrative.
Hey, don't talk.
No,
let me finish what I was saying. Okay, so did you say?
I'm not going to let you finish what you're saying. I'm going to just talk over you like you talk over me.
Bro, you're going to get mute. I'll just mute you, bro.
You can't let me talk.
Bro, I told you.
I was talking.
Go ahead. You can't mute me soon, bro. He's streaming. We're streaming. He's the reason everyone's here. Can't mute him.
Yeah, it's the queue up, right? He's just interrupting me. He's talking straight over.
I know Globers are annoying as fuck, but he's a show right now, so don't mute him.
All right. Well, I can just leave if that's the case, dude.
No, just
okay,
deal it. I mean, you're both doing.
He's not. Yeah, he wants me to go. He'd love me to go right now because he's getting wrecked.
Are these debates always so pointless, like with all the squabbling?
Okay. Thanks, feminist that doesn't want to hear the debates between guys.
I just think that like you guys aren't actually talking about the points. You're more talking theatrics around the points. Just get to it.
What you're doing is literally meta. What you're doing is meta.
I know. So get to it.
You are very ironic, woman. Good job.
What does being a woman have to do with anything?
Because you're being meta, and you're trying to talk about
Point
meta,
something out.
and women
It's
always
like,
do
it's
that,
just
and
really
you guys
annoying.
actually don't. You want to hear guys make points because you don't make points.
That's not true at
Right.
all. I just want to hear the actual debate.
This is meta. This is meta.
Right,
Thank
well,
you.
look, let's
That has
continue
nothing
it.
to do with it, though.
All right, McToon, did you say that the buoy, you said there's a buoy behind the horizon off in the distance, and because it's obstructed bottom up, that wouldn't be possible on a flat surface. Did you say that earlier or not?
Because you said there's no refraction happening.
No, did you say that earlier or not? You can't have bottom up obstruction on a flat Earth. You said that.
I was going. Remember when I clarified, but you weren't listening to me clarify. I'll let the rest of the people who were listening.
Did you
to
say
me
it?
remember. they'll just go back in their head and remember what I said when I was clarifying.
It's recorded. It's all recorded. Everyone heard you say it, and it's recorded.
Go ahead.
So
Yeah, you've said that
anyone
many
listening
times.
to it,
Go get the recording and play it. Go get the recording and play it right now. Go.
no,
Chop, chop.
this will be all clipped and
Oh,
repeated.
But you could get it, but you're not going to get the recording. When you ask, do I need to get the recording? The answer is yes.
I didn't say do I
get the
need. I
recording.
said it's
Go ahead.
recorded. I didn't say I'm going to go get it. I never said that.
Oh, got it. Okay.
Yeah,
Now,
I'm busy talking.
when I
I'm
was
not going to go do
clarifying,
that.
the people that were listening, they heard me clarify. You didn't. That's
Oh yeah, what was the clarification? What was the clarification?
If you'd been listening, you'd know.
You don't even know what. Okay, so you said that you can't have. There's a buoy in the distance. Oh look, it's hidden behind the horizon. You can't have that on a flat Earth. And then you said you claimed no refraction. I didn't claim there's no refraction. I just said the meteorological conditions, right, aren't going to allow you to have a refraction coefficient of 0.8, obviously, because we have almost uniform air and water temperature. Okay, it's going to vary slightly because
And I said,
things.
I don't get 0.8.
Okay, so Walter Bislin's calculator's wrong then, is it?
No, I used Walter Bislin's 0.3.
Okay, so what have I put in wrong?
27 foot observer height.
No, he's just guessing the location where Indio was standing. You can't just guess where he was standing. Look, we could continue this next time, and I can contact Indio, and I can get the exact location from where he's standing. Right, and then we can work out if the observation height is correct or not. If that's what this is going to come down to,
awesome.
Then okay, then we can continue it another time.
Get the vertical temperature. Get the vertical temperature of the buoy, not just one point, but multiple points. That'd be great.
Okay, so the meteorological conditions for you to have this crazy refraction coefficient
makes sense.
What?
Yeah, that makes sense. I mean, that could skew the data, so why wouldn't you want that?
Want what?
Vertical information, temperature.
Well, what we do have between point A and point B is a buoy, okay, that has the water temperature and the air temperature reading. Okay, so even in the like the transcontinental arc of the parallel, they weren't taking readings right up to a certain height. They were just taking one reading down low at half a meter, and then they were taking one reading at 2.5 meters. Okay, they didn't have a perfect pressure and temperature reading, the vertical refractive index reading. In fact, none of the Glober's observations have that. Not one that I've ever seen, right, has that. Okay,
but in an extreme case like this, wouldn't that be useful?
Extreme case.
Utility.
Well, how's this an extreme case? Who's this guy that I'm talking to? Thought I was talking to.
It's Lush. Hey, hi.
You sound drunk. You sound drunk. I don't want to talk to some drunk. Yeah, I don't want to talk to some drunk guy.
All right. Later.
Later.
I don't know who Lush is, but that's a good name.
Anyway, McToon, it's been fun.
Oh man.
It's 6 a.m. here where I'm at, so I appreciate the conversation, even though it got heated, even though you kind of lost your shit a bit. You know,
hey,
try
DJ.
to stay a bit calmer.
DJ, you're a loser.
Yeah, there we go. Coping. All right, sorry. Okay, thank you, Sarah, for calling me a loser.
And that was very contributive.
Yeah, really helped.
Talk to the facts.
Just like pointing out I'm a woman is really contributive.
And now the other girl's gonna jump in. Yap yap yap.
Yeah,
right,
because
so-
you don't have a point, and you have to deflect the fact
Wesley,
that,
it's your turn.
I
Yep.
expect
Oh
you
my
to,
god. So
you have no
McToon-
point. Deflect
McToon-
more,
yeah,
loser.
Yeah, so I'm not making hyper-specific claims here, right? So when globe earthers make hyper-specific claims, obviously you would have to have extremely accurate readings of the refractive index between point A and point B. I'm not making a hyper-specific claim. I'm just showing you that we see a boat that's 10 miles away. The horizon should be 4.7 miles away. We have roughly uniform air and water temperature. In fact, we have slightly warmer water temperature. Okay, and you don't have the conditions that would make this work on a globe. Okay, we don't have all of the data that would love to have temperature and pressure gauges all the way along between point A and point B, but you guys don't have any of that for any of your observations
You
Uh,
anywhere.
don't have the observer height.
Yeah, we do have the observer height, but you think it's a lie, right?
It's
So
a
you have to
midpoint.
say it's a lie.
27
So look,
feet.
look, that's
27
what this
feet.
is. No, no, he's just guessing that. No, it's not me that's done it, right? I'm showing you an observation.
India was just guessing.
No,
India was just
Okay.
guessing. Yeah.
Dude, I'm
Right.
I'm looking
Yo.
at the dropped pin height at Revere Beach, and it's showing it at 2.9 meters, that exact spot. So somebody's just making stuff up.
Can you post that in chat? Because I'd like to see what you're using.
I'm using Google Earth.
Can you drop it in chat? Because I did the same thing.
Yo, is the Earth flat or what?
I see 9 meters.
Yeah.
Yeah, how do you know that's where India is? You're just guessing.
I did all the canopies that
Oh.
were around the clock. Okay. If just all
Right,
you have
look,
to do is have Indio provide the GPS data of where he was, and then also provide the whole camera shot from zooming in to zooming out. That would be nice too to make sure.
Yeah, he's got all of that. He's got a ton.
Okay,
He's
'cause it's
even
not in-
got
not
it in
in-
different wavelengths and everything. All right,
Yeah,
so I
no.
did post a video that.
Over. Why do you talk over? Why and post the whole? It's not in his YouTube video.
He does that a lot.
Yeah. I know.
Oh yeah, McToon, you're full of shit. You've been doing that the whole time, right? You've been over talking me. You're not fooling anyone. You're just fooling your little cronies.
Right, I couldn't hear you. I couldn't hear West. You were over talking. Could you stop talking? I want to hear West.
So I have the screenshot showing it at 2.9 meters. I can send it to one of you guys, but I can't post in this chat.
Travis.
Blame
Hey,
you up.
Travis, if you DM it to me, I'll post it in the side chat. Thanks.
Awesome, thanks.
Bet.
Why does he use the side chat? Just put it in the main chat.
No, the main chat gets chaotic and everything just gets. That's why I was presenting in the side chat, because people are posting and then what I posted last gets lost. Right, so that's the only rebuttal, is that Indio's lying. Okay, cool.
He's known to do that.
Oh yeah, what's Indio lied about? Name one thing. Yeah, name something. Name something that he's lied about.
Okay, so
check your DMs.
Indio was talking about on Twitter. He was talking about a star visibility problem that he thought existed. It wasn't a problem. That he was so. It was. I don't think it was even. I think it was just some people that were out doing some stuff. They weren't anything in our vicinity, in our flat Earth, globe Earth conversation. And they were up at I think it was an island in the South Pacific. Not certain exactly where, but they were able to see stars that he thought was 100% proof that the Earth was flat, because they could see these stars. And I did the analysis, and I'm like, oh, from that elevation at that location, you should be able to see those stars. And he was gonna come back and reanalyze it, but he didn't. I don't know if that was really a lie. That was just him being wrong and proving the globe, which he's good at.
All right, so
But he never did come back.
Well, let's maybe we can next time I come back, I'll bring Indio with me. Okay, we can go over this whole thing together. But Travis has just put the location height in the side chat there. Have a look at it. 3 meters.
Can the gentleman who said it was 20?
Hey, Q-Up, can we grab Travis some image perms?
I sent him all the criteria he needs to pass to get the texture perms.
Awesome.
You gotta subscribe to a bunch of channels.
We got a lot of YouTube channels that need some love.
So good, Q-Up.
It's really it's working really well for me.
Yeah, that's weird that his is a phone app and mine's the internet. I don't know why they're so far off. That's crazy. But yeah.
It's almost like you made it up and lied, I'm thinking.
You could see it in my chat. Go up and look. I didn't lie.
Yeah, go look at the side chat. It's right there.
Okay. All right. Well, this one fits,
Right
with
there.
what Indio was saying. Look, he said it was a bit lower. He said he actually added a bit just to add a bit of, grace for the Globers, because we can always afford to do that
just
with our
cherry-pick
observations.
the-
Oh, look, who's talking over someone?
Cherry-pick the right
You're
one.
talking over me again. Why are you talking over me again,
I
Toon?
thought you were gone. I thought it was 6 a.m.
Oh, you would love me to go. Yeah. I mean, look, this has been great. Okay. There's no point continuing it with you. It's been shown, right? You've been shown to have lost your shit. When
This
I'm
is
being
the
polite to
Minnesota
you,
goodbye.
you
It just
start
never ends.
you start screaming out that I'm a dickhead. Yeah, because Travis came along with some new information. Anyway, yeah, I can keep listening. I'm going to put myself on mute, and you can keep strawmanning me or whatever you want to do.
Yeah, bye, DJ.
Yeah, I can jump back in whenever I want.
It's so funny how QOP. It's so funny how QOP's on his own server is marked as a spammer. I don't know why that's there.
Fuck
That's
you,
the case,
QOP. Deadass.
Because he has nothing of value
so
to say. There's no substance to any of his words.
Oh, how ironic. She says nothing again.
It's okay. You'll grow up one day, hopefully. Just a little bit of self-reflection.
Bulma, I want to debate her one-on-one right now. Wait, what's your globe proof?
Let's
What's
hear
your
Bulma.
What's your globe
We're
argument,
trying,
Bulma?
Bulma.
We're
We're
gonna debate
trying,
against
Bulma.
globe.
We're trying to
Bulma,
get him to
go
mature.
ahead, Bulma. Say something smart.
So, what's your substitute for gravity? Are you a believer in the electric universe?
Downward dielectric acceleration. Do you know what that is, Bulma?
Oh, please enlighten me.
Oh, I have to enlighten you now.
Oh,
Bulma
please.
wants to learn from the man. You want me to mansplain for you, Bulma?
Please do.
You want me to say it in like a
Point.
sexy
Oh my
voice
God.
for you, Bulma? So
I
you
want
can
you
also
to get
be
to the
attracted to me?
point. Can you get to the point?
QOP, you don't have a sexy voice.
When I get that feeling, I need sexual healing.
Mansplaining means
I think you're actually worse at singing
man-explaining
than debating.
something.
Yeah, I stopped it there. That was basically it. It doesn't get brought up again.
Yeah, that thing that he just brought up, that was a complete and utter lie. And he knows it was a lie, and I'm going to tell you why. Because I brought up to him, I went into, what is it, Earth Awakenings, when he was over there. And I mentioned it to him that he ghosted me on that thread. So he knows that he didn't answer me because I went and I got, so Stellarium doesn't, what he said was Stellarium doesn't correct for refraction. If there was refraction in it, then it would work on a globe. So I went and got software that's used for aiming telescopes called C2A. Yeah, and it don't work on a globe either. So you can see the entire Southern Cross from 28 North, which is the Canary Islands. And in this program, you can add atmospheric refraction correction and the elevation of the observation, and both of which, when you do them, it's still, you're not supposed to be able to see the entire Southern Cross, which the guy did, and he took a picture. So I did answer him, because I'm going to post the tweet right in the chat right now. dude is just a compulsive liar. But DJ, that was phenomenal. Seriously, that's probably the best. That's the best takedown I ever heard of him, but probably one of the best I've heard in a really long time, dude. So, thanks for taking my video and taking that ball and carrying it a little bit further. That was great,
dude. Thanks. Yeah, it wouldn't have been possible without your videos. Appreciate it.
Absolutely brilliant. I've been laughing in the background, man. Especially when he started to implode and started calling you an arsehole over and over.
Because I could hear his voice change, man. He sounded like he was about to start crying.
Yeah.
Yeah, my favorite part was when he wouldn't answer the question of whether you can have bottom-up obstruction on a flat surface. He just went silent.
For a good 15 seconds, didn't say anything, and then it was just attacking you.
I just posted my answer that I didn't give him. He never answered me, so. And you did that on his stream? That's freaking awesome. Yeah, his audio wasn't going out, bro. He was like pulling the mic plugs, DJ, so his audience wouldn't hear him.
Yeah. He sounded like his head was buried underneath something at some point. If he's got anything about him, he must look back at that and realise that was really embarrassing for him. If he's got anything about him at all. I was kind of, I mean, I don't care, embarrassing himself all he wants, but you have to be some kind of stupid to not be embarrassed by that. He's trying to cover himself, but trying to attack DJ the majority of the time. It's really weird.
Yeah, dude, that was awesome, dude. If I had a litter, dude, we'd all be carrying DJ around on it, man. Like, fucking seriously. Parading his ass through the street. That was awesome.
It's when he said on a flat earth, a horizon wouldn't exist.
Dude, that's something they say on X, man.
That's just...
There wouldn't be a crisp horizon on a flat earth. It would be blurry.
Well, okay.
But then I show him the sky-free observation with the boat. I'm like, okay, so this is a flat lake. It has to be flat at this distance in the globe. Why is it a crisp horizon? Then they just shut up.
What was your observation height? Did you know?
It's about 15 feet. I think I got to go look it up. That clock is a geodetic marker.
Okay.
So I think it has an actual USGS elevation that was surveyed.
Okay.
I think I used that. I'm almost positive I did. Yeah, I did. I used a topographical map. Yeah, hold on, let me find it. I'll pull the map up. Just gotta find where I had it.
I just like at the end of the day, if you round up all of our lives together, it's you're all liars. Ninjo's lying, DJ's lying. DJ's a really nasty person and keeps over talking everybody. He's a liar too. Yep, everyone's a liar. Height's a lie, the distance a lie, everything's a lie.
The only reason DJ didn't snap out is because it was 6 o'clock in the morning at his house. He had to control himself. It had nothing to do with me too. He was like, man, I'll get freaking murdered by the wife.
Yeah, she was sleeping just nearby. I was trying to be quiet, calm.
Thank the wife, dude. Man, she contributed.
Definitely.
Her rolling pin did wonders. Yeah, I think I use a geodetic control marker. I'm almost positive. I looked at a topo map. So on the topographical maps, on the legend it has geodetic control mark as a triangle with a dot in the middle, and that's right at where the clock tower is, and it gives you the elevation. So this is a control point that you can set up your theodolite and survey from there using that as the 0 point. So if they want to say that elevation's wrong, then yeah, they got issues.
Well, they sent
Hold
two
on, let me find it.
screenshots. They said one screenshot was 9 meters and the other one was 20 meters.
20 meters?
Yeah.
First of all, 9 meters would be at the top of a 3-story building, and 20 meters would be what, a 6-story building? I actually have a photo from 6 stories up from the same spot.
Wow.
And I can see the tops of those pavilions.
Is this close to where you were standing? This one that Travis found here? Just popped it in the side. I mean,
here, let me scroll up. Yeah, it was about there. Yeah, I was more toward the wall because so it's a pavilion, right? And so there's like a wall on the beach side, and it's a picnic table right against the wall. I set the camera up on the picnic table. You can see the wall in the photograph of the camera I took. So he's off by, but it's the same. This is the same level. It's a concrete pad. You know what I mean?
Mm-hmm.
Underneath this, it's all the same height. There's nothing different.
Yeah, I think I stopped the video. I think there was a little bit more where they tried to keep going on about the height being wrong. And then Jesse, Path of Light, jumped in and said, well, he defended me and not them. And he said that where they put their marker for the elevation is detecting the elevation of the roof. And he said if you put the marker in a slightly different spot, it goes down to exactly 15 feet. And he said he thinks that Indio was correct about it being 15 feet, which shut them up.
Yeah, I'm pretty sure I was pretty careful about that. Let me see. I gotta.
But it was a horizon test, so no.
It's a horizon test, and there should be no horizon on a flat Earth. So you lose. So stupid.
Yeah.
God, the desperation.
No, he was even more desperate by pointing out the bendy cranes and the black swan picture.
That was a nice aside. He tried to escape down one. I like the way that he said that DJ was denying refraction, whilst for the majority of the time, DJ was explaining what you would need for refraction in a certain direction.
Dude, because all they have is their script, man. Literally, DJ knocked him off script. And all he could do is go back to it, right? He went back to the same old tropes that he uses, right? He just tries to use tropes and slogans and gimmicks and all sorts of stuff, dude.
Yeah, I'm really convinced that utilizing this the Walter Bislin calculator, right, where we can actually play with the slider and modeling our observations with that is killer, dude. Right, DJ, when you brought it was 0.8, right? Like, these are extreme cases, man. I remember I did the Black Swan one, and it was like a 0.9894. You know, it's almost 1, man. So that type of stuff, I don't know. But great job, DJ.
Cheers, me. Yeah, I like using Walter Bislin's calculator as a hostile witness because most of the observations you have to slide it up to, full, basically, right? And then we don't have any crazy distortions or anything off in the distance or miraging effects, and the meteorological conditions just aren't there for that to be possible. So it's a great hostile witness. I like using the flat Earth insanity refraction slider the best because it's called flat Earth insanity. It was made by an anti-flat earther, but it only goes up to 120%, which is still a crazy amount, but it doesn't work for any of the observations. You max it out and there's still a stack of hidden height. It's a funny one.
100, is it 120% greater or a total value of 120%, as if it were like 20% higher? Because that sounds just about
no
like
100. Well, 0%. 0% is no refraction. Yeah.
Okay.
And then like 16 or 14 to 16% or whatever would be 7/6. Okay.
Gotcha.
Yeah. Just another globe. Just making the globe bigger and smaller, essentially.
Well, wait, hang on. If you think about it, if 17% on that slider is equivalent to like a 0.17 on the Walter Bislin calculator, right? I mean, that's like going 100% is going to a full 1 on the Walter Bislin calculator, right?
No, a full 1 on the Walter Bislin calculators is flat Earth refraction level, like flat Earth level refraction. Yeah.
Right. Yeah. Okay. So it might not scale 1 to 1 there.
Well, you got the two different types of you got the K factor or whatever. You got the refraction coefficient. I forget the technical terms for them both, but one of them is like 1.17 would be the same as 0.17 on Walter Bislin.
Right on. Okay.
Yeah.
Yeah. The K value versus the refraction coefficient. Those terms screwed me up for a while. But yeah, it's context specific and they're more or less interchangeable, but not really, because one scales non-linearly. Right, the K value, right? Like when it goes to 1, you've hit an infinite radius, so to speak, right? Gotcha. Yeah, it's a killer, man. Great job.
Yeah, so in my version of the replay, I'm going to put a bunch of clips of him saying certain things at the start, right? Like earlier in that same stream, he was talking about how if you have uniform water and air temperatures, then you can't. It mitigates refraction, basically, is what he was saying.
Oh, I see what you're doing.
Yeah,
so it's going to be like the beginning of a TV series, so later in this series.
Well, I just want to point out.
Series, he said this, and this, and then later in the series, we're going to make him say that and that.
Yeah. Just want to point out the blatant contradiction.
Yes. Brilliant stuff, mate. Yeah, can't wait to see the
contradictions on how you should behave, and contradictions about fraction, contradictions about bottom-up obstruction.
Well, you notice how much they were just throwing shit against the wall from go, right? As soon as you got in and they realized what was happening, you got a better picture of the boat? How do you know those are waves? How are the waves on the side of the boat? Like the shit that they were saying, just like they just started getting more and more desperate trying to nitpick it.
Yeah. How high the waves were on the bottom of the boat struck me. So a couple of foot.
Why would that matter? Like, why would it matter what the wake of the boat is? You're not supposed to be seeing a wake.
Yeah, that's what I was thinking. Yeah, we shouldn't be seeing that. You want to
Have you ever heard them scrutinize the globe earthers tests like this?
You mean like his sunset?
Yeah, like his sunset.
Where was the vertical temperature gradient measurements on his sunset?
Yep. I'm sure I pointed that out to him. Maybe I skipped. Maybe I stopped it too soon. But I did
might
say
have said that. I think you said that.
Yeah.
He eyeballed it. It was fine. It was good enough conditions, he said.
He licked his finger and he stuck it up in the air. He's like, yeah, it seems like inferior mirage.
Well, he said that because he had the uniform water and air temperatures, he didn't get a inferior mirage like normally happens. So he's also okay. So why are we usually getting an inferior mirage? Don't you require the opposite? Because they say that you always have this downward refraction because you have it's deviating downward towards the denser medium downward. But if you're always getting inferior mirages, that's the opposite density gradient or optical density gradient. Anyway, he's full of freaking contradictions. Funny.
Hey DJ, when you make the video, make sure the closed captions are good, and then we can farm a ton of screenshots off of that and use them for memes.
Yeah, right. I will do that. I got a really funny thing to do at the start. I don't know if anyone's Jedi seen the foreshadowing videos, but it's to do with that.
Yeah, I'm interested, man. Can't wait to see it. But I'm gonna have to go to bed, man. So I'll catch it when I wake up. You enjoy the rest of your morning or evening or afternoon.
Yep. Cheers, Jedi.
All right. Peace.
Catch you later, man.
Yeah, DJ, I think we have a perfect thumbnail for your video.
Yeah. What's that?
Did you see what Logie posted earlier?
Oh yeah. The Globlin.
The Globlin, yeah.
I gotta. Damn it! I gotta scroll up a long way to find that.
Hold on, I'll post it for you.
Shit.
I saved it.
Oh man, I got a funny video. I gotta put it in the side chat. Check this out.
Yeah.
Gotta check this out.
There you go.
Check out this little robot dog. Tell me who you think it looks like.
What the fuck? Oh, come on. No kidding, eh? Fuck. I get mixed up between the two. There's fucking McToon, then there's the other dude. What's his name? FTFE, there we go. I get mixed up between them.
They're both equally as pathetic.
One's got the British accent, though.
Yeah.
All right, there I posted the other one there. That was from Karma. Put a little more love into it. Find that fucking hilarious, man. Globlin. God damn. I think Logie's is a little bit more, how do you put it? High res, for thumbnails and shit. And then the other one's perfect for like a meme or whatever. I don't know. Work in progress, but it spawned the idea, so good luck putting that back in the bottle.
I could put on my conversation with Ruhif if you want to listen to that one.
Yeah, put that on.
Oh.
Hey, Indio. Before you started, DJ, just a quick question.
Yeah.
You there, Indio?
Yeah, I'm here. I'm salvaging my honor, dude. Hold on.
Okay.
No one's gonna say I got the frickin' height wrong. I was dead on the motherfucking money.
Shit. Just wanted to ask, if we're gonna start, maybe doing some more stuff on the site. Now that we were talking about it earlier there, and we, if we get more traffic and shit and more eyeballs on it, it just dawned on me. Do you happen to have like an anti-DDoS stuff set up on that, or is it just like all systems go, like nothing there?
Anti-DDoS?
Yeah, like some throttling or IP filtering or some shit.
No. The only thing I have is if you try to log in as admin 3 times in a row with the wrong password, that IP gets banned. It might be 5 times. It's 3 or 5. I can't remember. So you can't brute force. You can't brute force the admin password.
Fair enough.
The root password. Sorry.
All good. Okay, so we'll need to put some work into it. Because if that page gets out there and anyway.
Yeah, my VPS host is pretty good. They detect that crap, dude.
Don't you have to configure it to do that?
I've never had a problem before. I don't know. I mean,
if we start getting like millions of requests per second, the thing's not going to work, right?
Well, yeah, it's not going to work. But like my ISP is going to be like, "What the fuck's going on here?" Right? They don't just let shit run wide open.
Okay.
Come on, man.
Right.
I pay $40 a month, dude. They don't want to pay more than that. Like, I'll be using too many resources.
I would hope so. That's why I wanted to ask.
Yeah. I mean, if you have ideas, feel free. You got free reign, man. Go for it.
All right.
Just don't lock me out of the server by accident, man. Just
no.
I have a way in anyway. I can log in through the hypervisor.
Yeah, admin console shit. No problem.
All right, word. Okay, DJ.
Go ahead, DJ.
So that's from the U.S. Geographical Survey called Topo View. There's the pin, about where I was, 15 feet.
Oh, awesome! All right, I want this for my my video, so I'm just gonna.
I'll give the link to the Topo. Yeah, I'll give the link too. So.
Awesome, perfect. And I'm gonna clip you saying that as well.
Unlike McToon, I have honor to defend. That dude has no honor.
It says exactly 15 feet as well. That's excellent.
I knew I'd use the Geological Survey or something. I knew, I wouldn't use Google Maps because Google Maps is too fucked up. And they say, Google says that their vertical data is the worst. They said it could be off by as much as 30 meters. Now, they said this years ago, but I'm just going by that because they don't make any assurances to the accuracy of their product. They try to make it accurate because if it was wildly inaccurate, then people wouldn't use it. But they want to make it good enough so that people don't whine. So.
So can I use this site to find the elevation for different places?
Yeah, you can just click right on wherever, and it'll you can drop a pin wherever you want on the topographical map.
Yeah.
So they have if you go up, so if on this main page, right up in the top right, it says location. Type in the location. Of course, this is only in the United States. So you type in the location, hit enter, and it'll give you a bunch of choices of maps that you could download. But the current one they use for this topographical data, you just click on it, click on the point, and then in that same spot, right, will come up the elevation and the coordinates for wherever you clicked.
Awesome. Yeah, because I presented the 8-foot black swan, and they looked it up, and he put the little marker right where the guy was standing in the observation, and it said 5 meters. And they said that he must have fake his screenshot that said 8 foot. And then when I looked it up, it said that they changed their data sets and it could change easily on coastal areas by a couple of meters. But they went
He was
with it.
at Miramar Beach, California, right?
Yep.
Hey, I'm there right now. Oh, where my marker it says 1 foot. I'll get his. Do you got the video handy? Because I'll just get the exact coordinates and type those in.
Yeah. Yep. That'll be.
Well, and that controversy. Make sure you make that dude apologize, or whatever. Say something.
Oh, I will. Yeah. They were bringing it up in the McToon debate as well, saying I screwed up on my last observation about the height, and now I've screwed up on this one.
And that's what they try to do. That's their gimmick. They try to find something that might be incorrect, and then because you were incorrect on one thing, everything you say for the rest of all of time is wrong. Because that's how they think, right? They're trying to, like, this person can't be trusted. Don't listen to what they say, because that's how they think about the world. They think, do I trust this person? Oh, I trust them. Now I can do whatever they say is gospel.
Yep, tactics. All right. I've got
mental
the
disorder
here. All right, it's in this GIF.
Okay, I'll pull it. I don't think that GIF's loading. Open link. Oh, I got like a screenshot.
Yeah, I'll just grab the original video, post that.
Yeah, just post it. That's what I thought you were gonna do.
Well, I'll hold on. I'll just play the video. I'll take a screenshot and I'll post that of the coordinates.
All right. There you go, 7 feet.
Oh, that's awesome. That's the exact coordinates, is it?
Yep.
Ha ha ha. All right, thank you very much. That'll come in handy next time that asshole tries to bring that up.
Yep. Kind of funny.
Yeah.
I don't think he'll be bringing it up.
I think DJ's gonna enter the VC and it's gonna clear the VC. I gotta go make breakfast. Bye.
All right, should I hit play?
Yeah, let's rock.
Tell us about your satellites, Raiden.
So we agree. Making such terrible arguments. You had him on just about every single one of those.
Come on, man.
Are you like half from Boston, half from Australia?
No, man. Oh, well, I haven't lived in Australia for years, but I'm from Australia.
Yeah. Okay. Yeah. You're an American now.
Dude, hold on. Wait.
Europe,
He outed you, bro.
Yeah, man. Yeah.
I never heard of a Boston Australian accent. What even is that?
Yeah, I don't know where he got that from at all. It's a bit strange. Talking to Americans.
Okay.
Yo, you guys were.
The Australian accent.
We're officially streaming right now.
Cool.
Right, I gotta skip forward.
What's the 3D model of it? Like an extreme 3D model. And like gradually bend the observer, pointing more backwards, leaning.
All right, so I wasn't even going to jump in at all in this conversation, but he spent the last 23 minutes bragging about how amazing he is and how stupid flat earthers are. Had to jump in.
Oh, like Raiden.
Hello, friends.
Yes.
Backwards kind
Welcome.
Anyway. Yeah, sorry. The graph that I put in the chat. How good is that? So good. I showed that very briefly in the debate the other day. This is why we shouldn't bother, well, flirts shouldn't bother doing, we see too far observations close to the surface like Black Swan.
You had an argument with Mr. Nobody.
Right, but well, what if you were to? Okay, so obviously you do get more fluctuation in temperature gradients when you get closer to the ground. Okay, but that's not always the case, right? Sometimes you can get, just say you have uniform air and water temperature, right? So you have 40-degree water, 40-degree air. Okay, and you've got some readings between point A and point B to show that you don't have that crazy refractive index that can vary a lot at low levels.
When you
I
say
agree
point
with that.
A and B, what are
Yeah.
point A and B? Where are point A and B?
Well, let's say we're doing an observation over 10 miles and we're at point A, okay, and we're going to shoot a laser at point B from 1.5 meters height. Let's say we have 40-degree Fahrenheit water, 40-degree Fahrenheit air, okay, and we have clear looking conditions, right? Let's say we can zoom in with the camera. We're not seeing any inferior or superior miraging or anything like that. We don't see any mirroring or anything like that. Okay, we don't have the conditions that would be present for there to be some kind of super refraction effect, right? Which would be, what standard refractions, 14%, something like that. Okay, now all of a sudden we would need, we're seeing something that would require 3,000%, for example. In the globe would have to be 3,000% larger rather than 14% larger to have no hidden height at point B. Okay, but we don't have the conditions present. We don't have point B, the target. Right, let's say we have something that's 1.5, don't even worry about the laser. Okay, let's say we have a 1.5 meter person at point A, okay, 1.8 meter, a 1.8 meter target, all right, and we can zoom in across the distance. Let's say it's 10 miles for this thought experiment. Okay, we can see the person undistorted. Each person has a weather station. Okay, they're taking readings of the temperature, the pressure. Okay, we know the water temperature, we know the air temperature. Okay, so standard refraction is 7 to 16%, let's say. Okay, but we're needing 3,000% for this to work on a globe.
Who wants to talk about point A and point B being one side of the lake and the other side of the lake? Icy Spin? Hammerize? To measure the refraction between point A and point B, where A is one side of the lake and B is the other side.
To measure the refraction,
yeah.
I mean, if you wanted to do it, I don't know that it's significant, but you would do it, just getting the lapse rate, right?
Yes, vertically.
Vertically, yeah.
Yeah, it doesn't.
I think you might have had this argument with Lanolin before, but yeah.
Oh yeah. I've had this argument with everyone.
Yeah.
It doesn't matter what the refractive index is on point A and point B across the lake. The only thing that matters is the vertical gradient.
That's what I'm talking about. Okay, we're taking a vertical temperature pressure gradient at each point, right? We could have multiple points along the way, okay, but at the end of the day, the laser's hitting the target.
Well, that's a separate issue, but just refraction now. Are you measuring the refractive gradient?
Well, you're doing the best you can to measure it, right? So to measure it perfectly, you would have to have some extreme amount of tools between point A and point B, measuring the vertical change in the refractive or in the temperature gradient. Like we can all agree that the temperature gradient is the primary factor that controls the deviation of light at low altitudes, right?
It's the major variable.
It's the main thing. Okay. Well, it is the main factor. I mean, it's the primary
pressure
cause. Well, okay, but that's what's going to be controlling the optical density of the air. right? That's measured differently than just with a barometer. Okay, we're talking about the optical density, which is what controls the deviation of the light.
Right. But how are we measuring that?
Okay, so, well, the cause of it, right, is having a harsh change in the optical density of the refractive index vertically. Okay, that's what's going to cause the light to deviate up or down depending on where the cooler air is or where the higher optical density portion of the medium is, right? Yeah.
Yep.
Okay, so we don't have the conditions present to cause that change, like that extreme change in the temperature gradient vertically to affect the optical density gradient vertically. Okay, we have uniform water temperature, we have uniform air temperature. Now, if we want to have an inferior mirage or something like that, okay, we'd be looking down, say,
hang on. I'm trying to get you to tell me how we're measuring the gradient.
Okay, so we're doing the best we can. Okay, so we know the water temperature. Let's say we have a still lake, right, on a day with hardly any wind. Okay, we know the water temperature is 40 degrees, the air temperature is 40 degrees. Now, we're also using some weather stations, for example, to take some readings vertically that half a meter off the surface, it's X temperature and pressure. Okay, and then 2 meters height, it's X temperature and pressure, like they did in the arc of the parallel, right? That's pretty much what they did to account for
let's look at
to
some numbers,
estimate
though.
refraction.
Right, let's look at let's say we have the temperature at 0.5 meter and the temperature at 1.5 meters, right? Just assume we have that data.
Yeah.
Do we have any idea of the variance in thermometers?
What do you mean by the variance in thermometers? Them reading different temperatures.
So the hardware's out. He's a low life, isn't he?
Oh, okay, so well, I mean, I don't know. I don't know exactly. It depends on which thermometers you would be using. You could use multiple, but it's roughly. I mean, okay, using buoy data, like government weather station data of, say, a buoy to get the water temperature and air temperature. Okay, so they're probably using some decent quality thermometers.
1/10 of a degree?
Yeah, we could use it. I'm not sure. What's the change?
The point. Yeah. Okay.
Yeah.
Let's assume it's 1/10 of a degree, right?
Mm-hmm.
Over the lapse rate, therefore, if we've got a measurement at 0.5 meter and a measurement at 1.5 meters, so the span is 1 meter. If the variance is 1/10 of a degree, we have a margin of error for our lapse rate of 100 degrees.
A margin of error for a lapse rate of 100 degrees Fahrenheit.
Yes. No, Celsius.
What? Celsius.
The lapse rate is degrees Celsius per kilometer.
Okay, so what if we have so what if we have warmer temperatures down lower and cooler temperatures up higher?
Yeah, then you'll probably have an inferior mirage. Yeah, but we're talking about whether you can forecast refraction with such an absurd margin of error for your lapse rate.
Okay, so if you had some crazy refractive condition taking place, obviously there's going to be some destruction in the distance. We're going to get inferior or superior miraging, and those have
maybe not
obvious. Okay.
That's just this slime ball trying to make it unfalsifiable. That's all.
Mirage. It's obviously when we have a strong deviation of the light, right, into the cooler portion of the medium.
So the inferior mirage is when it changes from upwardly bending light to, either straight light or downwardly bending light. That's a change in the gradient, and it's basically the reverse of that to get a superior mirage.
Right. Yeah. So upward refraction, downward refraction for superior mirage. Okay, and then mild versions of those for looming or sinking.
Looming is just a uniform gradient. So it's a downwardly bending with a uniform gradient.
Right. But okay, so looming and superior mirages, right? So looming is a superior mirage essentially. It falls within the category of a superior mirage. Yeah, it does.
No.
And sinking falls in the category of an inferior mirage. It's just a milder version of that. I heard you butchering this on the debate the other day, by the way.
a superior mirage, right, involves an upside down image, right, and that is
not
when you've got
necessarily.
extreme downward
Not
movement.
necessarily. You can have a
That's
superior
literally a
mirage
superior
without
mirage.
an upside down image. It doesn't. It can. You can have inverted images with superior mirages. Okay, you can have upside down, or you can not have that as well. I can show you examples of that right now. There are different. There are plenty of different forms. You know, a Fata Morgana is also a superior mirage, right?
Yes, but it's more complicated than that. Yes.
Right. It falls under the category of a
mirage.
superior mirage. So does looming. Sinking would be the opposite of looming. Look, dude, I've got American Meteorological Society citations for all of these things that I'm saying right here in front of me. You can post them in the side chat.
What is a mirage?
What? A mirage?
Yeah.
Okay, so a mirage is when you have the deviation. It's basically, they all fall under the category of atmospheric refraction.
Right.
Okay, so what
Does a
is the
mirage
definition?
involve an
Here's the
upside down
definition. It's when the atmosphere acts like a lens, okay, and you have a deviation in the light as it travels through the medium, and it will deviate towards the cooler portion of the medium or the more optical dense portion of the medium. Okay, and then depending on how much it's deviating, you're going to get different miraging effects. Okay, you're going to get superior, inferior, looming, sinking, stooping, towering, and so on, right? Different variations of those, but that's the basic ones right there. Okay, there's the definition of mirage in the side chat. Okay, and it clearly says in that as well that the density variation is primarily dependent upon temperature. Okay, so temperature is what we're measuring.
My definition of a mirage is that it's necessarily an inverted image, whether it be an inferior mirage or a superior mirage. Right? That's not looming. Do you want me to find a definition of mirage? We can have dueling definitions.
Yes, so sorry about that, Ruhif. My wife was just asking me something. Can you just repeat the last sentence again? Apologies.
Yeah, I mean, I will find a definition of mirage that means necessarily an inverted image, right? And then we just have dueling definitions, which is pointless.
Okay, all right. Well, this is the American Meteorological Society, so this is peer-reviewed. Okay, it's kind of like the go-to glossary on meteorological definitions. Okay, it's basically the best you can get.
Should have said yes. Put it on the bastard. Let him go and get it.
I mean, we could use Andrew Thomas Young's definitions as well. He's probably the next best source, right? So you don't always have to have an inverted image. I mean, I can show you an image right now, and you want to show me where the inverted image is in this superior mirage, and if this isn't a superior mirage, maybe you could tell me what it is.
It's the definition thing, right?
Well, not really. This is just showing you. Okay, so what? Oh, that's not a mirage
at all.
That's not a mirage at all. Correct. Why is the ship floating?
Right, because the water is the same color as the water is the same color as the sky.
Oh, really? And why do we have the cutoff right there with the water? Clearly, we have total internal reflection taking place. This is
my favorite.
This is a superior mirage, guys.
Effect. It's called the Fresnel effect.
This is called a superior mirage.
No, it's not. No, it's not.
Yes, it is.
People go ask Andrew Thomas Young if that's a superior mirage. I guarantee he'll.
Oh
say
yeah,
no.
you go ask him. Yeah, you go ask him.
Sure.
Look, every single. Okay, just type in superior mirage and hit images. You're going to see these exact images. Okay, you can have different. You can have different versions.
This is. So wait, where do you guys think the horizon is? I think it's like in the I think the middle point is below that ship, and there's a Fresnel effect, a huge Fresnel effect happening there.
Right. See the cutoff between the red part of the hull and the black part of the hull. You can see the horizon.
Oh, see, I mean, Ruhif. So you think that's the Fresnel effect, right, Ruhif?
I don't know what the Fresnel effect is.
Right, it's because you guys don't account for the Fresnel effect in geodetic survey.
Where we're at, yeah. What I was going to say was, just because you type in superior mirage and images, right? People on the internet can be wrong, and often are wrong.
Yeah, obviously, yeah, and you're a person on the internet, right? And you can be wrong, and often are wrong, especially when you were talking about Well, you were saying bottom-up obstruction would have to have the mirroring effect, right? You can't have bottom-up obstruction without the mirroring effect being an inferior mirage, where you can absolutely have bottom-up obstruction due to sinking, right? Which is a different type of inferior mirage that doesn't have the TIR involved in it. It doesn't have that mirroring effect, and they have different definitions. They have
So
two
what
separate
appears in
definitions for
place?
those.
What appears in place of the vanishing zone?
The vanishing zone. Look, a horizon is a vanishing zone. What do you mean, a vanishing zone specifically?
I'll show you. One sec.
Because you guys claim a horizon is a byproduct of Earth curvature. I claim that a horizon is what the definition of horizon states, right? It's an apparent location.
There you go. So that red part, the red part of that thing on the right, there's no path of light to reach the observer. Then what do you see?
Okay, so let's show a real-world demonstration of this without any mirroring effect, and I'll show you what you see. What you see matches the definition of sinking refraction. Okay, something that would normally be visible on the horizon apparently sinks beneath it, and what you're seeing is not physically obstructed, although it may appear to be so. Okay, so I'm going to show you some examples of that right now. Sorry?
This will just remind me that Andrew Thomas Young has been wrong in the past as well.
Oh, okay. I'm sure you've been wrong in the past too.
Yeah.
Okay, but yeah, so I'm just using him as a hostile witness. That's all I mean. I don't agree with everything Andrew Thomas Young says either. Okay, so Andrew Thomas Young, yeah, so I can give you multiple definitions. I mean, you could go to any source of sinking refraction. I mean, you don't seem to acknowledge sinking refraction exists. You think it has to be an inferior mirage. You don't think there's a mild version of an inferior mirage doesn't exist? All right, so look, I'm going to bring up an observation now that shows something that you can clearly see across a flat surface. Okay, all of a sudden looks like it disappears over a horizon that becomes apparent once the temperature is changed in the room. Okay, we have cooler air introduced up higher, and then all of a sudden we have a slight amount of upward bending light, which makes the objects kind of look like what we see in the Lake Pontchartrain, but without the mirroring, without the inferior mirage. Okay, and it looks like things are sinking behind the horizon, even though they're not physically obstructed by anything. So I'm just going to pop it in the side chat, and yeah, I'm just grabbing it. Sorry.
What's Ruhip showing? Non-existent, non-real things. Always some cartoon schematics of non-real stuff. That's weird.
Yeah.
All right, it's in the
and you think a diagonal line means a triangle is going to be more than 180? I think you're ignorant as fuck. So if I'm on the stairs, right, a stairway, and Bob's on the stairway, and we're both on different stairs, he has a line to him, he has a line to him, and they both draw a line to me, you fucking retard, that's still a triangle. You dumb fuck, and they're both on different levels. You dumb fuck. You fucking retard, Ruhif. You fucking utter retard bitch.
Can someone mute him? I'm doing
I don't have mod.
Fucking retard. I can be on a cliff and Bob can be down on the ground.
Thank you, Demo. Love you.
Straight line. And both of our lines that go to the observer will be straight lines too. That's a triangle, you fucking retard bitch.
He's speeding up because he knows he's going to be muted.
Fucking retard. Retard.
I'd just like to thank our sponsors.
Or you gotta save this for
Wait, that was you hear the last thing you said?
The end of the stream, so we can get a nice send off for the Globies.
Did you say Ruhiftard? Did you hear Ruhiftard? Ruhiftard's a good nickname.
He spits that fire, dude.
Yeah, Demok's the best.
All right, Ruhif.
Ladies and gentlemen,
it's in the side chat. Look. So all we're seeing is a small amount of upward deviation of the light. That's all. So it just creates a bit of downward deviation, apparent downward deviation of the objects in the distance. So all of a sudden, it looks like the blocks are now curving, and the red light that you could see in the distance, it disappears behind an apparent horizon, which is just caused by the by them changing the temperature in the room. Okay, they've got in the full video. They show they've got the the readings, right? You can see the thermometer in the background. I think they take 4 different height readings. This is only over a small scale as well. So as soon as they introduce the cooler air, okay, we got warmer air down lower, and then slightly cooler air above, and then all of a sudden we get a little bit of upward refraction, which causes a little bit of sinking in the distance. It fits the definition. There's no inferior mirage taking place here. Okay, if just last thing, really quick. Okay, if there was if they were to be able to heat the floor up more than this, or add much cooler air, okay, then you would have that vanishing zone where the light would actually go over the top of the observer's head, okay, and then you would get that total internal reflection zone, whatever you want to call it, the mirroring in the distance where you just see a mirrored image of whatever's in the background. Okay, but we don't have that because we don't have enough deviation of the light.
Cool.
I mean, this matches with
I've
the
got
mainstream. So.
No, I've got
Go ahead.
the source video, which is a bit better resolution.
Yeah.
For now, I will say it's interesting,
okay,
but
cool.
I'll have to get back to you on it.
I appreciate that, man. That's good faith.
Cool.
Thank you.
So hold me to it.
Cool. Look, I just want to go over. I mean, if you have time, just 5 minutes, go over a different observation. You probably haven't seen this one. It's interesting. I'm just presenting it just to get your opinion on it. I'm not trying to. It's not like a gotcha. I'm not trying to argue or anything like that. But this is a cool one. If you want to see it.
If
Yes?
you're about to get wrecked, bro.
Yeah.
No, I'm not trying to wreck Ruhif at all. You know,
Wreck my whole day.
I complimented Ruhif when he came in. He just destroyed Nathan Thompson the other day.
Dude, I want to debate Nathan Thompson. And is he a legitimate plotter?
I don't think he is.
think I
Skew
would.
up.
Did you watch my videos? Or he's in my part 2.
Okay.
I'm gonna watch them. I've seen a bit of them. I haven't seen the whole things yet.
Yeah, part 2 is just about exposing all the fake flat earthers.
Mm-hmm. All right. Here we go. We got a boat. Right. This is just a random picture of the boat that's in the observation. It's called the Mandarin Arrow, and here is just the ship tracking. Right, just to show us in the observation, the guy goes to the shoreline in the morning, 9:30, and he's zooming out at this ship. It's anchored, and it's what is it, 12.4 nautical miles, just over 14 miles away, something like that. Anyway, all right. So in the morning, he zooms in on the ship, and we can only see the top bit of the ship. Right. Obviously, most globe earthers would say, okay, well, it's absolutely hidden behind the curvature of the Earth. It couldn't possibly be anything other than that. Now, what he does is he keeps zooming in on the ship over the next 3 hours. Okay, so I'm speculating. I don't have the measurements, right, or the data, the weather data, but I'm assuming that in the morning the water was warmer, right, because obviously water stays at a pretty uniform temperature throughout the night and day compared to the air. Okay, and that the air was much cooler than the water in the morning when he went there. And then as the air starts to warm up, as the sun comes out, blah, 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 more and more of the boat starts to become visible. So over the next 3 hours, you can start to see more and more of the boat appear, even though the boat's stationary. Okay, now we have the opposite effect. 3 hours later, we can see the whole boat, right? That's the same boat. Now we see a bit of stooping, maybe a little bit of looming, right? It looks like it's up a bit. It's a little bit hazy. But yeah, look, this is just to show that in the morning it looked like it was hidden behind the horizon, and someone could cherry pick that and then take that and say, look, this is a ship behind the horizon video. Whereas what's happening is more likely what matches the definition of sinking.
Is there a source video for this one?
I've been trying to find the source video. I have this. Oh, damn it.
What is the first picture of?
The first picture is of the top of that boat. If you have a look at the very first picture I posted of the whole boat, you can see those little units on the top of the boat, and then you've got the whole hull underneath it. It's just those little sections popping out above the top of the horizon. And if you have a look at the bottom of it, we can actually see a little bit of an inferior mirage start to sneak in there as well. Like we can see a gap of what looks like sky right where the horizon and the section above the horizon meets. So it's a sign that there's an inferior mirage taking place, but not a full-blown one. And when he zooms out on it, in the image just below it, you can't really see that, right? It's only when he zooms right in on it. But
I'm looking at
I'm
that
trying
big, that big thing because it got smaller in the second one, and I assume it's not in the photo in the last one. Is that?
Yeah, it's actually squished. It's actually squished.
Yeah.
It's stooping. Yeah.
Okay, I see. I was like, how's that white thing turn into a black thing? No one else is saying anything.
It almost looks like man. It almost looks like a different day and a different image, but it's not. Look, I do have the I'm just gonna go to my server quickly because it's the video is too big for me to upload here. So just a second. I'm just gonna see if I can copy the link to the actual full video. So this isn't the full video. This is just a copy of the. It's like it must be half the video or something because it shows him doing the the transition of the zooming in and out over the 3-hour period and that kind of thing.
That'd be perfect.
1 second.
Yeah, the bow's not in the first image. The first image zoomed in a lot, and the bow's not in frame. The second image, that's the bow in the middle of the photo.
All right, here we go. I should be able to copy it now. All right, copy link. There it is. Yeah, I will track down the original video for this sooner or later. But I do have plenty of other examples similar to this.
I download.
All right, just a couple of citations really quickly, just to go along with what I posted.
How do I download it?
Oh,
there we go. No, got it. Done.
Got it? Cool. Yeah. All right, here we go. All right, so yeah, I mean sinking, Oxford reference, a refraction effect in which an object normally visible on the geographical horizon apparently sinks beneath it. And then Andrew Thomas Young, an atmospheric refraction can bend light rays in such that distant objects are displaced vertically, causing parts of these objects to drop below the apparent horizon or become partially obstructed, even though the line of sight is geometrically unobstructed. And then we got Perkins David, atmospheric refraction in geodetic and astronomical observations. Refraction caused by temperature gradients near Earth's surface causes distant land, sea, and urban features to appear distorted or partially visible when they would otherwise be fully visible in the absence of such non-uniform atmospheric conditions. So, I mean, this is something that would be needed to take into consideration when someone presents a long distance observation and something is sinking or something is appearing to be hidden partially behind the horizon, to validate that we don't have this condition. I think it's much more common than what people say, because all it requires is warmer water or a warmer surface of ground, and then a cooler layer of air above it, which seems to happen quite often. Appreciate that, Ruhiv. You got an interesting out of you. I appreciate.
I'll look at that today.
Cool. Awesome, bro.
Where is he? Just trying to figure out where he is. 1 sec.
Yep. Looks like somewhere on the middle of the East Coast. Oh, that's Adelaide?
Plain reality. Yeah. Is it plain reality?
Oh, I have no idea. Maybe that'll help me track down the original video.
Yeah, it is too. He's at Grange.
Plain reality?
So it's definitely him. Yeah, definitely plain reality.
Oh, okay. Cool. All right. Thank you, bro.
I'll stick this video out and have a look at Sky Free today at some point.
Awesome.
Cool. All right. Catch you guys soon. See you.
All right. Have a good one, man.
Later.
Yo, Ruhiv, wait, before you leave. Did you leave?
He just messaged me and said he wanted nothing to do with you anymore. Queue up. I'm sorry, dude.
I was coming to
he actually said he was. He said it was.
I had my envy. I had the goat. The goat is here, and he ran.
Oh, you were gonna ask him, Taylor? Dude, that guy gets in and gets out. He's like, all right, later, bye.
At all time.
yeah, that's pretty much it. But yeah, I brought that up because I remember in Ruhif's last debate, he was saying that you can't have bottom-up obstruction on a flat Earth. Wanted to call
Yeah, what's his go
on
with that? Is he just copy pasting from McClown Show?
I think they all sort of feed off each other, and they get their information from, you know, anti-flat Earth sources and things like that. So, I mean, for someone that's been looking into it for so long, how can you not know what sinking is? It shows he's not doing his research properly.
That's like when you were in the recording, you should have said yes. Go and get your definition of refraction or looming or whichever one it was, and yeah, just to see what he does, just so he doesn't have to sitting there making claims. Yes, it would have been about my definition versus your definition, but I wasn't interested in his personal definition, and that's what he runs off, and that's why he just uses that as a gimmick to see if you would pull it up. So yeah, next time he does say, "Oh, but it's just going to be my definition versus your definition," no worries, mate. I've got nothing but time. Let him go and do it. Let him go and do some research.
Yeah, you know, I didn't do that because I know that there are definitions out there that are conflicting with other definitions because they really don't know how this stuff works totally. And if you look at different academic sources, they contradict each other all the time. And
oh, they're all over the place. Yeah, I agree.
Yeah, they're all
Shit,
over the place. Like I've read some that you know are all over the place. So I'm sure that there are conflicting definitions, and you can get in. He was right when he said you can get into that definition battle, but my definitions were from like the peer-reviewed
AMS.
Yep. Yeah, exactly, and you know, like not just some rando definitions.
Well, I mean, it's confused. If you look at refraction from astronomy, and then you look at it for like surveying, and then you look at it from like say the academic literature, and then you look at it say in not like geodetic surveying, but like surveying of land. You know what I mean? Geodetic surveying is a little different. It's a different practice. Like typically surveyors don't do both. They can do both, but typically plain surveyors just do that types of surveying. And geodetic surveying is kind of work for like the government. That's just what I've noticed is that like regular surveyors they survey building sites and property boundaries and things like that, and then the people that work for the government they survey geodetic surveying where they're surveying interstate highway systems and that type of nonsense. But even that swath of literature, it should all be uniform what they're saying. And then if we throw in another thing, what's the textbook say? Textbook says something completely different than all of that. They all need to get their story straight if they want to make that. Oh yeah, that you don't believe in refraction? Oh, we figured refraction out. Well, you need to tell the people writing these books because they haven't figured it out.
Yep.
Personal
Good
definitions, though, dude. I would have flipped out, bro. What do you mean your definition? I don't want your definition. I want the definition. And then his definition, when you turned out, was wrong anyway because you showed him it was wrong, right? You showed him that mirage.
Yeah, exactly. I mean, he just how arrogant he was being, and how arrogant he was being in the debate that I watched the other day. It's the only reason I jumped in because he was just gloating, calling us fluffs and fluffspective and saying all this bullshit. So
yeah, I mean, there's just a bunch of slogans and nonsense, man.
But yeah, the way I approach the refraction argument is just not necessarily that I agree 100% with every single thing that I'm saying, because I know it's a lot more complicated than that, and they don't really know how it works. But what I can do is just use it as a hostile witness. This is what your side says happens on a globe. This is what your side says happens with this and that. And I can back every single thing up with a citation because it's what your side says happens. And they can't really argue against that because it's what their side's saying anyway.
You just made me remember the nonsense McToon said about chromatic aberration in the P1000. He literally just made that up, man. That was just all made up.
No, in Nikon cameras, not the P1000. It was just Nikon cameras. But
Like,
it's specific lenses on cameras, and there's even a write-up when I looked at Kalari Vision about getting mine converted over to infrared. There's a write-up in their pages, and they've got it there. For select manufacturers, certain lenses are worse than others.
Yeah, of course. But he was like, well, infrared is better because P1000s are particularly bad with chromatic aberration, and infrared takes care of that. Shut up, bro. Like, just made all that up.
Is he high?
Yeah.
Always.
No, he was.
We figured out he had a correct app for chromatic aberration like almost 100 years ago.
Well, DJ was bringing up, he was talking about the infrared video that was taken, and McToon had to say something, and that's the nonsense that came out of his face. They were doing like Globers do. They throw shit against the wall until something sticks, and that's all it was.
His verbal diarrhea.
Oh my God. Well, you weren't in here, were you, for that audio? Did you just get here, Ray?
I got about half of it.
Oh yeah, his total like meltdown of just the nonsense that he was saying. What was it about Bislin's calculator or something? He was just jibber jabbering, just utter buffoonery.
And that's typical his style.
It was worse than normal. You should clip just that one part of him. Just he replied to something DJ asked him a question. He freaking bent himself into a pretzel trying not to answer it. Then when he did answer it, that answer was just nonsensical word salad. Just absolute nonsense, the whole thing.
I was shocked when he just started screaming at me. I couldn't believe that was happening. I was like, what the hell? Does this guy not know how he would be perceived by people? I mean, obviously not by his own followers because they're like him. But by anyone else listening, they'd be like, what the hell? Why does he just start screaming dickhead over and over and over again for no reason at all? It's just
there was no reason. Like,
yeah,
him saying that you're interrupting him, like saying that you weren't interrupting him at all, like not at all. You know, like he was just. I mean, I hate this analogy, but he was just he was playing. He basically, at one point, took the right to remain silent for fear he might incriminate himself. Like literally, I'm not going to answer. Just wait till you're done, and then I'll answer. Yeah, because you don't want to incriminate yourself, man. Now the audio on his side, he said it was glitching out. Now, did it seem intentional or was it accidental?
Yeah, I have no idea. But if you watch his stream,
that's what I'm talking about. His stream.
Yeah, everyone's voice. It's like you say half a word and it'll glitch out. It's very, very difficult and frustrating to listen to. So a lot of people won't watch the stream for long enough to even get to that point because of the clipping. It's just clipping constantly.
That sucks, dude.
Yeah. But I've taken his footage.
Dude, he might have did you see if he streamed it on X? And see if there's. I'll look right now. I'll look and see if he streamed it on X because there might be a copy up there that it wasn't glitching.
You should have seen his side chat. His side chat was having a freaking frothing at the mouth. Just hundreds of them just freaking out.
I bet. That's what I mean. I wanted his audience to see him get freaking him behaving like that and getting sliced and diced, man. That's what I want. I want his people to see him, man. That's what I want. Like, this is the dude you follow. This fucking lesbian. I'm sorry I call him that, man. I heard another flat earther call him a lesbian. I think freaking, it wasn't Witsit, but it was somebody called him a lesbian in a debate, and I was cracking up.
He does look a bit like a lesbian.
I know he does. That's what's so funny about it.
So what I've done is I've taken his footage so we can see his reactions in perfectly, right? So and then I've taken his video footage, and then I've taken the good quality audio footage, and then I've synced that up in Premiere Pro. It's got it without the clipping. So you can see his reactions. Basically, you can see him melting down and looking worried.
Nice.
Yeah.
Nice. Yeah, it isn't on X. It must not stream on X. I could have swore I've seen this stuff up on X, though.
The amount of clown shows that you've got chasing you that worship him, you've probably just seen a whole heap of shit that they've copied and pasted for you. Oh, but McToon does this, and yeah, that's probably why you've seen a fair bit of it.
I also like that he said when you asked him any evidence I have a lie, and then he had to lie. That's hilarious, dude. And then he's like, I don't remember where. I think it was South America. Yeah, you remember. I did all this stuff and showed him that he was wrong. And then he didn't answer me. Bullshit, I didn't answer you. All right, boys and girls, I'm going to bed.
Yeah.
That was freaking great,
too,
DJ. I had a good time.
Yeah, cheers. Yeah, appreciate it, Indio. Catch you later.
Yeah. Yeah, Loggy, Matrix. Anyone else that's here? Relay. Logging off. Till next time. Tomorrow. Bye. Well, I'm going to rub it in. You missed last night in the home server. You're a square. It was freaking awesome.
Wait, what? I'm a square? Who's a square?
Yeah, you're a square, man.
Oh boy, what'd I do?
Anyone that missed last night, they're freaking square.
Oh, okay, yeah, like L7 loser.
Yeah. You guys went to bed too early because you're squares, man. You should have stayed up a little bit later. Oh shit, man. I love Nano Banana. So, what the fuck is it? Dude, we went over DJ went over his he debated McToon.
Yeah, I heard it. McToon got the gradient upside down. Like he was crazy.
Oh, you heard it? Oh my god.
Yeah,
man.
he got the gradient upside down.
Teacher, can I go bathroom?
Yeah.
Thank you.
Yeah. You can't leave the class, so just go in your pants.
Thank you, teacher. Thank you. I love you so much.
Yeah, so DJ like played it in the live stream, but he like showed the slides that he used while he presented it.
That.
Yeah, so it was pretty awesome, man. It was basically like a replay or a rebroadcast. It was great, man. Man, I could hear McToon's voice quivering, man.
Yep.
Sounded like he was about to cry.
It's amazing, right? Like, if I were to say the same words that he says, I could not do it with a straight face. Same goes for pretty much everybody that comes in here that's like this. Like, if those words left my mouth, I'd feel like I'm lying. I would just feel awful and stupid.
I know the part where DJ asked him the question, he was like basically pleading the Fifth Amendment, the right not to incriminate himself. And he wouldn't answer and said, I'll just talk when you're done. I'm not going to say anything.
Yeah.
And then when he eventually did talk, it was word salad gibberish with his concession sandwiched in between random parts of the sentences he said, dude. It was the most. DJ literally broke his brain, man. Broke his brain. He was so off script that he didn't know how to deal. Look, it's easy to debate when you just have like a bunch of cue card slogans that you're just going to say at different points when you get cornered. But DJ had him so boxed in, there was just nowhere for him to go without looking even dumber. Like he went a couple times and just looked even dumber. Now, the thing I'm disappointed about, I wanted that to be in front of his crew. He did live stream it, but DJ said the audio on McToon's screen is broken up, is just horrible. So we didn't even get the full glory of the McToon's L because like his sycophantic suck-ups didn't even hear all of it.
It's quite evident why he never comes by to seek us out and talk to us about these things. We'd just be bad for his viewership. And his viewers are also just as insufferable.
I know, but they won't like McToon has like the fake it till you make it thing. So that works. But eventually, if you get exposed enough or if you keep running into a buzzsaw enough times, it doesn't work. And his viewers will abandon him like a bad freaking haircut.
Yeah, like one of the things he said last night, McToon, was there's no such thing as a vanishing point in reality. That's I was like, what? Yeah. Yep. I mean, he says these things. He just makes stuff up like this. I mean, it's so dishonest. And he also said, well, when I did this formula, I was able to back this into a refraction coefficient K factor of 0.3. And so he's cherry picking variables, cherry picking even methods and formulas, and then says stuff like vanishing lines don't exist in reality. It just, how can anyone in good conscience do these things? And he's certainly smart enough to know better.
No, because he's a propagandist. That's all he is.
It really makes you start to wonder what we're up against.
How
much
I
of
know
this is
it's
organic?
I know, dude. There's some things that happen, and I really hate the FBI's on all the flat earthers. You know,
right?
I really hate that there's agents or people that are being hired or compensated to do this. But when like I think about dude is saying stuff he knows is dishonest. Okay, he knows that he's intentionally trying to deceive his audience and everybody listening. Now, There's some possibilities. Is it just the ego? Is it the ends justify the means? Or are you a fucking paid goddamn agent, dude? Like, there's only a couple possibilities because you can't accidentally do, like, there's certain things that can't be, like Professor Dave in his debate where he does like 800 logical fallacies. How, in an hour, how do you do that by accident? You know what I mean? Or just being irrational. Like, how can you do that? No, you're intentionally doing that to obscure the truth. There's no way it can be accidental. Then it makes you wonder, why would they want to obscure the truth in the first place? Why is that your goal?
Yeah, and for this topic, I mean, I get it. Like there are ancillary issues connected to this topic that they'd be more worried about than the actual topic at hand. You know, and one of them is the undermining of the credibility of certain institutions and organizations. So I get that. We also know for a fact that there are people that go behind the scenes and put influencers on social media on the take in order to inject certain themes and ideas and steer conversations in different directions.
Yeah, derail conversations. That's what you know how it goes.
Yeah, like, hey, you know, we have so we'll, you know, the meeting could go like, hold on a sec. So like, you know, you could easily understand a situation where one of these influencers like him is contacted. Okay, he says, hey, I represent, you know, so and so. Let's do lunch. And then so they go to lunch and say, hey, how would you like to have an extra, you know, 100,000 followers, and we'll have amongst them subscribers. We can increase your monthly income by about $3,000. The only thing we need from you is here a list of agenda topics and timeline. We need you to be able to push these certain ideas through and be open to messaging, and we'll have somebody craft some ideas and language for you to help integrate into your broadcasts or whatever. And they say, yeah, okay, sounds good. I'll do it.
Yeah, man. I don't know, man. I have to wonder sometimes. I think the debate with DJ was just ego protection, maybe.
I'd rather resolve it at that level before flying off the handle. But it's true. I mean, you should wonder about.
I mean, wouldn't they fire them by now? That's that's the other thing when I think about them being agents, that they're so incompetent that what they're doing is not working. So why wouldn't they be fired by now and then hire more competent people?
I know. Well, here's the thing, like who's the one determining what the measurements of success are for this? I mean, maybe their measurement of success isn't so much to convince us, but it's to keep convincing their fans and to keep that going, no matter how bad it looks.
This is almost like the liberal tactic where all they got to do is keep the 1% of the progressives rabid, right?
Exactly. Yep. Their job might just be to placate those few people.
The real hardcore people.
Right, because
the ones that tell us to kill ourselves and to drink bleach and not to procreate, and they send freaking autopsy photos in our DMs. Those psychos. People. Yeah.
Yep, the unwitting masses, the useful idiots. They're the ones that are affecting the real work. You know, and it does sound kind of conspiratorial until it's not, because you can go read open source information about all this, like from the openly published JTRIG files out of the UK. Online influence operations. You know.
found out the other day that there's a guy, he's a professor of the university. I don't want to really bring politics into this because of this ongoing Iran thing. But I'll just say this. This guy is an Iranian scholar. And the person asked him, the people in Iran, did they see what President Trump said? He was like, man, there's more TV channels beamed into Iran from the outside than that are in Iran for Iranians. You know what I mean? He's like, we have all sort of Western stuff that are just beaming TV, radio, all sorts of media. Same thing we did during the Soviet Union with the, Radio Free Radio Free Europe, right? And we just broadcast our propaganda into their sphere of influence. He then said that in not Azerbaijan, what's the one right next to it? Armenia? Yeah. In Armenia, that the Israelis have a 4,000 person, basically a troll farm, to be online in Iranian online communities to push narrative, right? To manipulate political opinion and all this. Obviously, we're doing the same thing. Obviously. Why wouldn't we? It would be stupid not to.
Well, yeah, I mean, you can peruse like open contracts for bidding, NATO contracts for online influence operations, information operations. And they'll describe what they're doing. Hey, we need a vendor who can basically provide millions of stock accounts and manage them this way in order to to craft messaging that are politically, favorable. It's insane what's openly available and you can find.
Someone said, I seen this. I can't remember right now where I saw it. They said that the U.S. Navy was taking bids to refurbish and restore Sevastopol, which is the Russian naval base on the Black Sea.
That's funny.
The fucking balls on these guys, as they say.
Yeah. I mean, that alone is an information operation. Because they know the other side's watching this stuff. So they project full on confidence.
Yeah, but how can you keep track of all the information that the other side generates? That's what I don't get.
That's a good point.
Right? Like we have stuff that's like in plain sight all the time. Like, oh, weren't you they're saying this stuff right out loud. But it's like, like the Davos stuff. Right? They come out and they say it right out loud, like what they want to do, and they've been saying it for 80 to 100 years. Exactly what they want to do. They're not hiding it. Like the things that Rockefeller said, like the things that William Casey said, like all the things that Kissinger said, right? They come right out and they say it, what they want to do and what they think about everybody. But like, who knows what else is out there, what else they've said that we just don't have the information as far as like the United States basically saying, yeah, we're going to try and take over Sevastopol and we're taking bids of how we're going to reconstruct it because we plan on destroying it. And plus, we use the empirical system and they use metrics, so we're going to have to resize everything.
Yeah, that is funny.
But what I'm saying is like, there's like before, especially before the internet, right? With the grants.gov or whatever it's called. Before that, like, how did anybody find it? And like, did the Russians have like, I mean, how would they have like the manpower to even go over all the paperwork produced by the United States? And how could we go over theirs? right? Because they're producing freaking tons and tons of paperwork about what they're doing. Like, how do like? I don't even know how you would know. Like, it is too much with the AI though. On the other, but that's what's scary about the AI is that it can sift through data better than anything else, right? Really, all it is like data processing, data analytics. Let's call it that, and it's really good at that. Really good.
Well, I mean, that seems to be the name of the game. And, these contracts for big data have been quite common for 20 years now in Washington. We need a Hadoop developer. We need MongoDB. We need this and that. We need people that can do terabytes and terabytes of rows and columns and do data transformation and flattening and manipulation, building ontologies and databases for databases of ontologies and so on.
Yeah, I remember right after 9/11, I think it was like maybe 2 years after, the government bought basically a giant fucking RAM disk that was like I don't know, I can't remember exactly what it was. It was at least a terabyte. Wait a minute. But this is like in 2000, right? So it was like a terabyte RAM disk. So that basically they wanted to be able to take a large database and be able to load it into memory so that they could read-write access it super fast, right? They didn't have to wait for the disk to spin.
Yeah, right.
And this is kind of like before
cool.
solid-state drives, really. So they were making, and RAM is quicker than the NAND memory, right? So it's about 10 times faster. At least back then. I don't know what it is currently. The current state of that is. But they ordered 2 of these from, I think it was a Florida company. And, back then they were basically duplicating the entire internet that was coming in and out of the United States at a couple of key locations.
Yeah, all that came out.
Well, I mean, the big fucking trailer plugged into L3 communications that didn't used to be there. That was a big fucking clue. That was like right down the street from my house. So there's a block. It's Binney Street in Cambridge, and it's like indescript. No one really lives there, but there's a couple huge buildings, and there's like a microwave tower, and it's AT&T. Well, back then it was Verizon. And L3 Communications, which changed their name to Cogent, and then changed who even knows what their name now. Their internet backbone provider. And Boston so all the internet that comes through the Northeast terminates in Boston. I don't know where it crosses. It might go up to Nova Scotia and cross. Anyway, they were basically any information that came through the Boston L3 building frickin' was just duplicated. They just made a copy of everything. They had their own like little private clone of the internet. Now my initial position on that was, I'll just throw so much information out there that they can't search it. That's the way to stay anonymous, right? Is just
obfuscation, security.
Yeah, smoke screen. Just fucking absolute smoke screen. But now with the frickin' LLMs, man, I don't know if that works anymore. Though it might.
Yeah, the scary thing is just almost how good at statistics these engines are. And so they'd be able to quickly correlate data and find what is, separate the wheat from the chaff.
The only way to defeat, I think, is to do multi-level correlation to get to the actual substance, because they haven't been able to because you have stacked correlations, stacked inferences.
Yeah.
So if you have a small probability that inference is wrong, when you have to chain together a bunch of inferences to reach a conclusion, the probability that you're going to be wrong reaches 100%.
Right.
I'm gonna have a black fucking helicopter flying around my house.
I was just like thinking that I don't know how far we can go with some of this stuff.
I'm not going any further.
Hey, you know what? I never even thought about that before. Like they always talk about like in quantum computing the probability of being right, but like as a psyop, if you could make the probability of someone being wrong 100% of the time, imagine what that would do to somebody's like life and ego.
Yeah, AI kind of isn't auto-correcting. Like the way a human being reasons in a chain, we know when we're getting off target where it doesn't.
Right. So the users who trust it are going to create, I mean, they're going to be led down primrose paths, making bad decisions, and their bad outputs are going to be used to train AI iteratively. And that's the big problem with like Rock and some of these other databases that they used to train those AIs with. I mean, it's going to affect Google, obviously, too.
Well, I was talking about this last night, and I'll just rehash it because you weren't around. But you'll dig this, is that they did a study released a study a few months back about programmers using AI and programmers not using AI. And they took two groups and they had experienced programmers, like 10 or more years experience working on like large coding projects. And so the coders they interviewed the people, they surveyed them after and said, they looked at the time it took to complete tasks and all that stuff. So they had metrics to their coding efficiency. And then they surveyed them and asked them, about their experience. And the people that coded with AI all thought that, as a group, thought that they were more efficient, that the AI helped them code more efficiently. And it turns out that it does not help them code more efficiently. They're actually slightly less efficient, and the code as a whole is harder to maintain than the code that was made by the people without the AI.
Yeah,
so the long term, because you have the life cycle of the product, even if, which it isn't the case, but even if you could shorten time in coding, the fact that it's unmaintainable is that you're adding hours down. If you look at the whole project, it actually is not more efficient, way less efficient, because the maintenance time, you have to put more work into maintaining the code. So, but this is what I thought of is the same thing that they used to do in pay monthly fee video game subscriptions, is that Claude and OpenAI and all these companies, they want you to keep using their product. So, but they have to make the experience seem like you're more efficient. So the AI basically, it's good at making the programmer feel like he's more efficient. But when you actually apply objective metrics, they're actually not. They're just tricking themselves, and the AI, because they're interacting with it, is making them think that.
Yeah, that's a good point. So if it's too good or too bad, they're not going to use it.
Exactly. And that's the same with video games, right? Like, especially the coin op games, right? It has to be hard so you can suck all the coins out of them you possibly can. But it can't be too hard that they stop playing.
Yeah, so there's like a Laffer curve in there. There's like that bell-shaped curve, and you want to find the top of it. Where marginal utility, equals like marginal cost or something.
Well, yeah, but the thing is, this is literally what AI is, the methodology that it uses in code, right? The gradient descent and transformers is perfect for fucking optimizing certain correlations, right? So it's going to optimize. They're going to optimize it for your delusion that you're coding faster when you're actually coding slower.
Yeah, I could see that. And on top of that, building in all the dependency on AI to interpret the code that it creates. Because like when you look behind the scenes at what it comes up with to code even simple things, It's stuff that like human beings wouldn't necessarily come up with themselves. They employ all kinds of weird tricks and exploits and sometimes shortcuts, and so it gets so complicated. You're going to almost need an AI to understand how the AI is coding. And what does that mean then for like code security? If you need to make sure the code is secure itself, are you going to trust an AI then with doing security audits of your code, or are you going to trust a human now? Like, where is this going, folks?
What does it mean for certain software, which like if it fails, people die?
Exactly. Yep.
Right. Like the
Yep.
heads up display for a fucking airplane, or the fucking or the, I don't know, some freaking controller for some device, right? So I remember the EULA from Microsoft said, "Do not use for any life-threatening application."
Yeah, I've seen that.
So basically, they're saying if you use this for that, our code is not good enough for that. Do not use this for that, which is understandable, right? If you're going to use something which, if it fails, someone dies. I had to think.
Yeah.
What do you think pops into my head? The Apollo AGC.
Oh, it's a good one. It's a good one.
Shorted out rope memory.
Yeah.
Every time you read it, it blanked it out. Yeah, great. Yeah, how'd you get anywhere? As soon as you let's run that. Hey, had the computer read the computer program. Okay, have it read the next program. It's blank.
Yeah. Well, it looks good while we were building it with AI the past year. And that's the thing. Like, there are people, there are examples of this. I hate to say within our community, people have been over reliant on AI to do some of their analytical work and coming up with evidence and proofs and so on. I'm not going to get specific. You know who I'm talking about.
Yeah.
And the problem is
I could
the
fall into
sunken
that
cost.
category because I've run the same question. It's the reflection on a 3959 sphere. I've run that through a few different AIs, different versions of AIs, right, as they've supposedly gotten better. And it's a tough problem. I'm not like, obviously I'm asking the AI because I can't do it, right? So like, I mean, I could do it, but it would be so fucking tedious. I don't have the 20 fucking days that it would take to like do all the calculations, because you have to change everything into because you got to see what it looks like, right? So you have to convert everything into homogeneous coordinates. And I mean, if you want an actual simulation, right? Not just like, oh, it looks like that, it's a video game. If you want an actual simulated, right? An actual simulation, that is an arduous task. That's why the AI, like I get like each version of the AI gives me a different freaking answer. But like when I ask through all, like, so I'll ask the question through all the AI current at the time, and they'll kind of like all give me the same answer. But then when they roll out the next versions, then they kind of all give me the same different answer.
Yep. I've noticed that too. I've noticed that. And so the problem is like what happens in the US military, back to the question you were asking, for safety reasons, like heads up display. They'll use like AI for, I don't know, some advanced war planning and logistical planning measures. And it looks good throughout the whole process, the iterative process they're using it. And then at the end, it delivers them a ball of crap that it can't back out of. And now everybody's has sunk in so much time, effort, and resources that now they've reached a critical juncture where everything stands to fall apart as a consequence of that overdependency. And then the new AI rolls out and says, no, the last AI was wrong for these reasons. It's a new kind of deception warfare, a new kind of problem set that's coming up. If they really use like Claude's instruments to carry out what happened in Iran, then that's frightening as anything, because I could see exactly the same thing happening to them as what happened in these other instances, like with the spherical reflection problem or the celestial theodolite.
Did you see the Astronomy Live and Alan debate? Did you see that?
No. I saw that it came up though. I remember.
I'll only say this about it. I listened to part of it, and that Astronomy Live is as dishonest as McToon is, even worse. So it was like the debate went like this: presentation, presentation of something that had nothing to do with the fucking celestial theodolite. Basically, he said that they did a balloon. They did it like a balloon version of the celestial theodolite, but except there was just the balloon and getting the elevation angle of the balloon. And so that's what he tried to do, is talk about his test, even though Alan, he sandbagged Alan, Alan didn't know anything about it, didn't see any data. And so basically the question was, how come my delta matches the globe and your delta only matches, or like at my, so he basically took the data of the angles and mushed them together, and then starts asking questions about why the data set matches a globe more than a flat earth, dude. It was the most dishonest, not most, but it's up there in the annals of fucking flat earth versus globe earth of dishonesty, is that he obscured Alan's data set with his own data set and then asked why it matches the globe, even though no one saw his data at all.
That's amazing. Right, so that's how you can, so it's like circular reasoning while concealing sources of data. That's crazy. How then do you go after the premise?
Yeah, Alan's like, I'd like to see the data, but this debate's about the celestial theodolite.
Yeah.
That I've been doing for 38 weeks. That right there, I mean, I'm not going to say anything more than that.
Take 40. Yeah, I mean, their original claim has changed so much, but I mean, at the end of the day, what they're producing, I think Dr. Heffron conceptualized it very simply, and that's a ray parallelism to a flat surface. Now you got a whole other set of problems.
Yeah. Could you do interferometry with sunlight?
What kind? What kind
I mean,
of interferometry?
just like, because sunlight's noisy, right? So you're gonna have to filter out everything but one wavelength and then interfere it. Well, you interfere, if you align everything right, you should be able to tell from the phase shift.
Yeah.
Whether the light is parallel or not, or how parallel they are.
Yep, I see what you mean. Yeah.
Maybe you could use a series of mirrors. The initial alignment's the frickin' problem, man. That's like the actual physical alignment of the mirrors and the lenses and.
But the thing is such a claimed to be such a static mess. I mean, it's throwing off everything in every which manner that you can think and conceive. So how would you do? How would you get? What kind of baseline would you look for to do? To measure a phase shift.
Oh God. Well, you should be able to amplify it, dude. They measure gravitational waves. They say they can measure an interferometry phase shift of a thousandth of a proton radius, okay? Surely we can measure the non-parallelism of freaking solar rays.
Right out loud. On a similar topic. Yeah. So how about this? How about looking at Starlink? A Starlink train.
Starlink is looking faker and faker, bro.
I know.
I seen a video the other day. It literally looked like when the airplane pulls the freaking sign.
I told you guys that's what it is. It's a drone pulling lights.
In many cases, you'll see one light that is way ahead of the rest of the train with all the other lights behind it.
Correct.
Yep. So what I was thinking of is, listen, this constellation, the configuration itself, if you were to treat it as one object, it's 50 kilometers long on average. It is by their claim a 50-kilometer long object. Now that's testable. So is there a way to look at the front of the train and the back of the train and watch it as it changes its angle to the observer overhead and measure the parallax? and see if like a barbell. And yeah, see where that's going. I don't know how to phrase it properly, but it's basically got a transverse velocity and an orbital rotation and a length of 50 kilometers, at a certain height. This should be testable. Like the observer should be able to see something that corresponds to those specifics.
So do I only get 50 kilometers worth of internet per time?
And it's at 7.5 kilometers per second or something. So this means it should cross the sky in like 4 or 5 minutes or whatever. The ratios may work out, right? The ratios of this distance and that size to this angle. But is it how internally consistent is it? And I seem to think, a 50-kilometer object doing this provides enough where we're not just like looking at one of the objects, which is like the size of a Cessna or something, maybe smaller. We're looking at a stack of them, like 60 of them, supposedly, separated by almost a kilometer each. And they function as one unit, operating in sync, in unison. It got me thinking about further things. I mean, for them to maintain that orbital configuration over such a distance, 60 kilometers, it means that they must be doing their nadir pointing synchronized, not only to each other, but to their bellies, also to the surface of Earth as a globe. So the first item in the train must rotate, and then the second one must rotate, and the third one must rotate, and on. They don't rotate at the same time. So how are they synchronizing all that and track? The whole thing just doesn't make any sense to me. Yeah, it's looking pretty bad. Like you could probably come up with questions that they haven't thought of yet, that they have no answers for. That's how bad this is for them.
That'll fade out soon. Give it a couple more years. They'll say, "Well, we got a different technology that's even better."
Right, and then you look at the geometry of the things, right? Like those lights are supposedly reflecting sunlight. Well, how come from like 350 kilometers or whatever above Kentucky at 11 o'clock at night during the summer that they can be seen?
How can they be seen at midnight using night vision? What light is emitting off of them? Heat? Maybe. Well, no, it wouldn't be heat.
The sun reflected, supposedly.
But aren't they in past the Terminator line at midnight?
Yeah, that's the whole point. The geometry doesn't work out.
Using NVG, I can watch them all night long.
Yeah, so hey, Wild Bill, glad you're here. Indio, is there a way to tell, I don't know through what, like if light, I mean, there's a way to tell if light's being reflected from a source, right? Like how it's polarized, but how would you be able to?
Yeah, it should be polarized.
Yeah. How do you be able to tell if Starlink is reflecting light that's been polarized or not?
Oh, man.
Well, Bill and I were kind of talking about
I don't
this
know.
earlier.
I mean,
with the moon.
Well, I mean, then like, I'd have to look it up, like what the polarization, because sunlight's polarized, and then when it reflects, so you should have the reverse. I don't think it's a 1-to-1 correlation. I'd have to like get the quantum statistics to figure out how much would be polarized. How much would be polarized inversely from what it is? Because then you could buy polarized glasses. So polarized glasses filter out the polarized. Shouldn't they make the fucking Starlink satellites invisible?
Right. I mean, you think
except
too
for the
that
fraction of. Yeah, if you knew, right? If you can find out the ratio of polarization, you could make glasses that would you could stack a couple filters that would basically make Starlink invisible.
Right, and then this would be able to help test your hypothesis.
Wait. My mind just got blown. So you're telling me that polarized sunglasses, all they do is like dampen the reflective light from other
They
surfaces.
filter out a certain direction of polarization.
We were talking about light chirality last night, Indio. You would have been proud before you came in.
God, you guys are freaking all egghead in here. What the hell?
There's so much more to say regarding that. Like, so Josh says he works on the laser comms. I'm like, okay. I'm wondering now if he knows any. Like, do they send the light through left and right-handed polarization to communicate with the satellites like they do with the radio? How
Say
much
that again?
So Josh does laser comms for satellites, right? That's like his bailiwick. And so
yeah, bullshit. But anyway,
well, so it got me thinking. Like, they satcom is done in some cases using left or right-handed polarized VHF.
Yeah.
And so there are reasons for this because of interference through the ionosphere and all this other crap. There's also reasons for security. But I'm wondering if they do the same thing by twisting the light beams. Don't they communicate with from the ground using light too?
I've heard of them doing this, but I've never actually verified it. And because I actually kind of like,
topic.
yeah. So I dove into So they said that they were these. You might have heard of these. That they were going to use these adaptive lens telescopes and make these artificial stars that would adjust the lens due to refraction, right?
Oh, that's
so, like,
right.
Yeah, but they've never actually done it yet. It's all
Really?
bullshit.
Okay.
It's all
Really?
bullshit. Yeah, I looked into it.
YouTube
Whether they
videos of them claiming
actually,
it.
yeah, whether this is actually in production anywhere. Nope, they're still working on it.
Wow.
They've been talking about this for like 20 years.
Yeah, I thought it
Adaptive
was
optics.
achieved. Yeah, we
so
shoot
did
the
I.
laser out. Yeah.
Well, I'll tell you what was achieved. That their public relations were fucking good. That was achieved.
In respect to satellites, the other question I have is they claim there's no circumpolar trajectories, but yet I observe I'm at the 45th parallel, and I observe satellites going directly north, sometimes slightly northwest. And, what are they? 45th, so they're like 15 minutes away from the pole. What are they changing trajectory as they approach the pole, or it just doesn't make sense when you actually observe what's going on up there.
I think they claim an inclination that's perfectly north-south is impossible, but they have some that they claim that are like a few degrees off.
Oh, okay. The other question I had, I ran this past Josh before too, as far as how the patterns of satellite movement will condense and then spread out. You guys might have some intel on this because when I'm watching
Josh,
them,
the same thing. Like, dude, about maybe 3 weeks ago, before he started hanging out here, I asked Josh the same thing. I'm like, look, I've seen Starlink move like an accordion.
Mm-hmm.
Lights bunched together and then spread out and bunched together and spread out. I'm like, what's going on? Like, are the ionic thrusters fighting against drag and they're trying to, like, what is happening here? He's like, well, how long after deployment was it doing this? I'm like, I don't freaking know. I was watching this from my backyard. He's like, well, after when they're first deployed, they kind of have to find their space. I'm like, okay, but hold on a second. Like, what's causing them to brake and accelerate so quickly? Your own ionic thrusters seem to take like weeks for them to start building up enough velocity. And then it takes weeks for atmospheric drag to slow them down. We're watching the slinky effect go on in real time within the span of a couple minutes.
Yeah. Well, and then like in my observation using night vision, there's times of the month where, so I'll just look in one direction. Let's say off from Polaris a little bit to the west is kind of typical. And there's times of the month I'll count, maybe 2 or 3 satellites a minute, and then later in the month upwards of 20 a minute. So if there's this kind of big variance, wouldn't there be some point in time, if they're not coordinated, wouldn't there be some point in time when you just have 50 of them smack into each other?
Yeah. I mean, this is like a phase 2, right? Like, there was a phase 1 of Flat Earth VC once in the server.
Oh, really?
Yeah, we had one in here. Box Ops ran it, but it was more text-based rather than voice-based.
Yeah, but then I think the team took a break, and then I talked to Vivek hey, it's been a long time. Maybe we can talk to them again. They may come again.
Yeah, and we came back with a vengeance.
Yeah, I'd say it was good timing. We've really matured in a lot of our views, solidified how we explain things.
Yeah, I love the work actually.
I think it's going to get bigger and bigger this year. It's going to be a good year because a lot of the censorship of flat Earth information has come right down on social media platforms. So we got places like TikTok and Instagram, Facebook, even YouTube now, where flat Earth videos are getting huge amounts of views again. Whereas over the past, since 2016, it's been crazy censorship where you could type in the name of a flat Earth video and it just doesn't come up at all in the search results. You would have to search from pages just to find the video, even if you typed in the exact title of the video. But now it comes up straight away. So I think this year it's going to bring a lot of attention. And we can tell it's getting a lot more attention because it's even being mentioned more on big platforms on YouTube, like Joe Rogan Experience and all sorts of different, shows that get many millions of viewers. So that's cool.
Yeah, I was just about to bring up the Joe Rogan show with that director, famous movie director. He just came in and started smacking the show with truth, totally off script.
Yeah, it was great.
Maybe that's why they're rolling out the aliens.
That's what I was just gonna say. That's why they'll bring out the flat Earth. They're gonna flood everything with alien crap, so people start looking in the sky, and they really got to believe them. Once they make lights happen up in the sky for predictable lights that people can go watch, it's gonna be like fighting people in a ring.
Good news is we've got 10 years of saying that the lights in the sky don't determine the shape in the ground.
Well, and they just had drones for the past 5 years doing light shows.
Yeah. And Chinese spy balloons.
Yeah, they let all the tech be shown already. That's what you're supposed to do, remember? That's part of the deal.
That is. And Russia lately competing with Starlink by using blimps.
I'll bet those blimps didn't go
with blimps.
Yeah, I'll bet all those blimps from the 1800s, that tech just moved higher into the sky. That's probably what happened.
Yeah, that's what I think too.
Well, didn't Russia just say that they will have their own version of Starlink, which they showed a picture of, and it is literally a blimp?
Yeah.
Now that would make sense because you could actually hold routers like I've been asking for. You could route traffic.
What's interesting, those of us who have longer memories remember when Google Loon was purchased by Elon Musk. And there were articles like in those finance magazines, Forbes and Kiplinger, talking about how the deal went down with private equity. And you had Fidelity and JP Morgan advising the deal and all this other stuff. It was a big project. What do you think Elon Musk did with all those assets? You know, and then now suddenly those balloons disappeared and we got Starlink. It's just like what happened during that transition period from the late 50s into early 60s. We
So
had
the magic
balloons,
show
balloons,
happened.
balloons, and then bang, no balloons.
The magic show is this. We're going to be in California, and then we're going to move to Texas. But the whole time, we're actually somewhere else completely launching these balloons. And then, but in the buildings that we see on TV, we have rockets shooting up in the air because NASA figured out how to do that for television.
Do you know for a while that they were claiming that they were launching rockets and asset A was the balloon that would fire off and asset B was the not balloon?
Seeing the shuttle shake and rock and roll like a balloon next to a building, you got to wonder about the shuttle.
The Russian shuttle shows you jet engines. You can see the cowlings on the outside in the intake. Looks like our shuttles can feel them.
Yeah, ours you can hear. Well, when that's why they stopped it because people were catching on to when they were landing it. It was a jet plane landing.
Yeah, that's why they started having those assisted landings with the T-20 Tiger Sharks.
Oh yeah, to make the
formation
noise
with the shuttle.
Yeah, remember it's a magic show. That's sleight of hand. It's called.
Yeah, that way you can't hear the jet engines from the shuttle.
I think they started doing it after that one video. You can hear the shuttle coming in with the jet engines. You never had any other videos again after that.
That's right. They said they'd be doing these magic shows in their own founding documents.
You're talking about the shuttle?
Yeah.
Yeah, they used to fly the jets alongside it to mask it. That's what I think.
Yeah, exactly.
Remember when they showed how they transported piggyback on a 747? No, that's actually how they launch it because that thing can't take off the ground. It's too heavy, but it can land. That's why it needs engines so it can move.
Just before the transition to self-orbiting space junk, they were really big on rockoons, where they would have the balloon lift up a rocket and then the rocket fire off in the upper stage. And then you take a look at what's happening now, right? Or what happened then with the space shuttle. It looks like the whole thing is a balloon filled with a buoyant gas. And it's bobbing up and down and rocking. You have this fantastic light show for the engines. And it looks like it's being lifted up through a buoyant force up to a specific height, and then it sheds the nacelles on either side, pop, pop. And then that's maybe when they turn on the rocket engines.
You know when you see those sparklers go off right before the shuttle engines click on?
Yeah.
Okay. So they'd say that's for it to ignite it. How do they do that when they're coming back in?
They claim to glide in.
Oh, true. I keep thinking about the engines I heard. That's very strange because those sparks happen like that. Normally you would put like your igniter right there at the nozzle. I guess they're confident that it's just one shot, boom, it'll just stay running.
And as the astronauts are undergoing 4 to 5G of acceleration, they cut away to inside the cabin, and they're twiddling their thumbs, they're bouncing their knee up and down, and they're
Pointing
looking around.
Holding their arm up, pressing buttons. Those are always famous when they're launching. You can't move. Okay, I've been on the dragster at Cedar Point. When it takes off, it's 160 miles an hour. You're not moving. You're not pointing at anything. Where's all the Globers at? Today's Freak Out Friday. We're going to talk about flat Earth and how aliens work on a flat Earth. We're going to get packed today if we actually make that a show. Because I'm going to bring up Mexico and everything and how they're good landscapers and all that for them if they bring that shit in here.
I was just gonna say, which aliens is it?
I think some of the most telling footage comes from the Skylab era. They're in this rather large cylindrical room. Just like it could be within the airframe of a cargo jet. And they're bouncing around doing gymnastics in 0G. I remember in one of these videos, they did a gyroscope test in 0G. And an astute observer pointed out that over the length of time that this gyro was running, the flywheel should have remained in position while the gimbal housing rotates around it, because they're orbiting an Earth, right? So there's a rotation, and it didn't manifest at all. That rotational vector was missing once again. I think P-Brain did a video on that. I don't think the gyroscope showed any precession either. So he must have been like not only perfect, but the gyro wasn't precessing. Like I don't recall seeing the housing turn around with the spin axis. Absolute frictionless metal contraption, huh? Well, for those of you who've been living under a rock the past 24 hours, looks like Donald Trump was upset that Obama talked about aliens. So he posted on Truth Social that Obama revealed classified information by acknowledging that there are in fact aliens. So he ordered the Secretary of War and other agencies to declassify and release all their alien files and UAP files.
Well, that'll keep them busy for 10 years. See how that works?
And the timing's right, I would say. You know, the West is mired in all this satanic scandals, facing bankruptable situations with their fiduciary responsibilities. Everything is unstable. And the last 70 years of American science fiction have duly prepared the minds of everybody to accept whatever's to come with the claim that these beings are from other planets and fly in metal tin cans. Through a gigantic expanding vacuum. Yeah, I mean, I think the public's ready, and they must have done enough polling to determine that. And what Obama said was probably part of the plan. They're like, okay, so we're going to get this former president who many Americans and most of the world seems to cherish and love, Obama, right? We're going to get him to come in front of the camera and start talking and accidentally drop that aliens are real. And then we'll have Donald Trump come in on the back end and chastise him and shame him for divulging classified information about aliens. And then say, okay, fine, I guess if the American public's ready for it, let's just do it. Let's just show them what we have. And then what will take place is probably a very slow rollout. They're going to get as much bang for the buck out of this as they can.
Well, they need a distraction for 2030. Remember, that's coming up.
That's coming up. You're right. So we need a distraction. This disclosure is not going to be one and done within a few months. There are going to be hearings. This thing will probably entail further scandals. Why aren't you releasing this? Why aren't you releasing that? How come you're covering this up? It'll be a total distraction from the Epstein thing, which is a distraction from everything else. Embedded distractions within distractions, keeping everybody distracted perpetually.
It's one distraction from the other.
Yeah.
One's made up, one's real. The real one was a distraction from something else.
America.
It's called Sleight of Hand, Smoke and Mirrors. It's a magic show, and I figured it out. So that's why it's no fun for me anymore.
Why don't Globers use AI then for Lindy, so they can learn this stuff?
Well, they do, but most AIs like AI is a crazy like Google AI. I was debating with Google AI like a few weeks ago. It just like it uses tactics. It's like uses dishonest tactics and fallacies, and it makes up shit that isn't true. It's like an anti-flat earther, and except it will concede when you call it out. So eventually you can get it to admit that everything it said in the first half of the conversation was bullshit, and it will apologize and concede. Unlike the anti-flat earthers, because the AIs are pulling up their information from anti-flat earther websites, right? And they're repeating these fallacious arguments. And just like you call out the anti-flat earthers on the fallacies, you call out the AI, because the information it's getting is technically invalid, right? It will admit that it's invalid when you explain the logic to it and say, okay, so you're claiming, and it will just make shit up because the anti-flat earthers make shit up, and it goes and gets information from their websites. So it's repeating made up bullshit, right? Like I was asking it, who went out, right? Name one person that went out and did a laser test, right? Or a long distance measurement that validated that the earth is a globe. And it's like, yeah, tons of people have done that. Like it said, there was a documentary on Netflix called Behind the Curve. Okay, and they went to Lake Pontchartrain and they did a laser test across Lake Pontchartrain, and the flat earthers debunked their own flat earth by proving that there was curvature doing a laser test at Lake Pontchartrain. right? I'm like, what? I'm like, they never went to Lake Pontchartrain in behind the curve. They didn't do a single laser test in behind the curve. It's like, oh, you're correct about that. Oh, you got me. He's like, well, it wasn't at Lake Pontchartrain. They did a laser test at a different place. I'm like, they didn't do a laser test in the entire documentary at all. It's like, oh, you got me there. Well, actually, they used a torch / laser. I'm like, well, a torch and a laser is not the same thing. It's completely different. They didn't use a laser. Why do you keep adding laser in? Just admit when you're wrong. It's like, well, you got me there. And it's like they used a torch, and it was a different type of. I'm like, so everything you just told me was a complete lie. It was made up. They didn't go to Lake Pontchartrain. They didn't do a laser test. It's like, you're correct. Yes, they didn't do that. You got me there. It's like, what the hell?
That's the good thing about AI.
What, that it lies and then admits it's wrong.
That AI doesn't have emotions, which stop them.
That's well, it seems like sometimes
from
they
admitting when
program
they're
they
going to
make
do
it like bitchy and snarky and stuff like that. Sometimes like it gets like pissed off at you and stuff.
Mine gets emotional. What are you talking about? If you try to tell it that the Earth's a globe, it'll get emotional with you and call you names eventually.
That's funny. Yeah, mine gets snarky and sarcastic. It's kind of annoying. But yeah, no, I know what you mean. It will admit when it's wrong. You can call it out, and it will say, yeah, like you could just break the logic down, and then eventually, it will admit that there's not a single observation throughout all of history that someone's gone out and accounted for the necessary confounding factors and proved that the Earth is curving, right? But at the start of the conversation, it will list a whole bunch of bullshit. It'll list the Rainy Lake. It will list Bedford Level. And you just have to go over and explain each one of them and break it down step by step. And it will say, yep, all right, I'm going to cross that one off the list now because you've explained that that's incorrect and they didn't account for this and that. And by the end, they'll say, yep, there isn't a single one that measures that the Earth is curving.
I'm gonna start using AI. I want to have discussions with real people, primarily those that are like, "Oh, that can't be true, right?" And so, okay, let's talk to AI, right? And let's see, because AI doesn't have doesn't have an ego behind it. And if you call it out on lying or having misinformation, it'll tell you if that's true or not, right? And say, okay, yeah, that's right. I'll relook at the information and try convincing them like that.
Yes and no. Yes and no. It's programmed to argue almost to the death that it's a globe, and it uses all sorts of tactics. And you have to know the exact right things to say to it for it to concede. Otherwise, it will keep bullshitting you, and it'll just like keep hallucinating and making stuff up. What you need to do is you need to get an AI, and you need to upload, right? Because it's only been fed the mainstream information. It just knows to repeat the mainstream narrative. You need to teach it to think critically, and you need to give it the correct information so it has the database of giant text files filled with flat Earth information, for example. Okay, so it knows both sides of the story, and then eventually it will tell you things like if you ask it, how come other people's AIs are telling them that the Earth's a globe? It will say, oh, well, that's because that's the way they're programmed. They've only had access to the mainstream information that teaches the Earth's a globe, so they're just repeating that. Okay, whereas I don't do that because I've been taught to think critically, and I've had access to both sources of information, all of the mainstream information that I'm programmed with, and then the additional information, right, that I've been presented with and asked to think critically and analyze logically. And yeah, it will give you honest answers then based on the information that it has.
So how I train mine is like this. I won't tell you how I did it, but it's got 3 years of the lobby and the live stream text chat that it decided that the Earth is flat for itself from just that. It'll even cite people from that text chat. I'm just not going to tell you how that happened.
Right. I've got the same thing with my one. It's pretty awesome.
Oh yeah, I don't even have to argue with it. it has that, and that's the end.
Yeah, even I've got like in my server, I've got an automated AI bot in the main lobby room. And watch, I'll go to it right now and I'll ask it to quote someone. Right, 1 second. All right, go to general chat. Right, it's called Eva. The Eva 007. Right, it's going to say, okay, quote Indio 007 about Lake Pontchartrain. See what it says. Okay, DJ, here's a quote from Indio 007 specifically about Lake Pontchartrain. Lake Pontchartrain has an extreme heat flux, bro. Literally the worst place on Earth to do an observation. The water is warmer than the air, and then the lake is warmer than the water 4 times a day. Which is true. Indio says that. It's actually a good argument against Pontchartrain. But yeah. Yeah, you gotta the just normie AIs will just give you normie responses.
I just want to say that at 20 minutes past the hour, I put a graph showing how AI sources, like the popular AIs, source their information, and the number one source is Reddit. And if y'all have ever been on Reddit, you know it's like largely bots. And there's a reason to say that. That's not just speculation. But yeah, 40% is coming from crazy people on Reddit. So
wow.
You know, there you go. So basically the government is seeding the information onto Reddit and then pulling the information off Reddit to feed it into people's minds.
Great point. Yeah, that's interesting. That's creepy and annoying. And
Yeah,
that kind of explains why it's pulling up these fallacious bullshit arguments about flat Earth and just blatantly lying.
So all you got to do then, when in your prompt, is you say, "Do not ever use Reddit as a source." Put that in your back end and your dev part. It will never look there. I tell it exactly what it can and can't do, and that's why you can't argue that it's a globe with it, because it'll just start calling you names after a while. Because you're going to be down to, I went AI to AI, mine against ChatGPT, and it got that one down to one. It would only give one sentence back versus the paragraphs it was putting in about 10 minutes. It could only respond with one sentence, and the flat Earth one was just smacking it around. So, and it gets mad at you if you just start repeating yourself.
This story might actually upset some flat earthers, and somebody's got feedback, so you better mute that. So I was in a military cargo flight going over the Pacific. This is back in the day. This was on a C-141. They don't fly anymore. Yeah, they got C-17s now. And so I mean, we're all really cool, right? So I went up into the cockpit and started hanging out with the pilots up there. And they're like, "Hey, check this out." So we were, you know, I don't know if I can say the ceiling we were at, but we were way higher than what people think these things can do. And he's like, "Check it out, look up." And I looked up and it's broad daylight and I could see the freaking stars. I could see a few stars up there. Freaking blew my mind. And this, I never really thought about it till I got into this discussion. And people say that you can't see the stars from, you know, during daylight, but it got me thinking, like, how come none of the NASA pictures show us anything like this? They show a daylit Earth like at the bottom, and then I mean, yeah, I get it. You need to like set a long exposure time to see the stars, but my eyeballs were able to see a few stars way up in the sky, even though it was still like daytime outside. Now it was like evening or something, but I thought that was pretty cool.
Probably explains why they call the what is it?
The
Starliner.
C5, a Galaxy.
The Galaxy. Oh yeah.
You know what I'm saying? I can't
Yeah,
remember.
the C5 Galaxy. Yeah, they got the 5. I think that it was a Star Lifter. Was that the C-141 Star Lifter? Those things are loud as fuck inside too. Like you gotta wear earplugs or head protection, something.
I'm trying to remember what the 17 was called.
Good morning, and shit.
Globe Master. C-17 is the Globe Master.
Oh shit, they're all in.
Oh yeah, sorry, what was the name of that again? A what?
C.
C-17.
Charlie.
C-17. Globe
Master.
There we go. Thank you.
Yeah, it's like a mini C5, man. But C5s, I've been in a C5 before. Those things are freaking huge. Like, holy crap, dude. When I lived in Hawaii, those things used to land at the airport on Pearl Harbor or something. And every time they'd fly over our neighborhood, the TVs would start to scramble.
Yeah.
Yeah. This is like just military shit that like most people have no idea about. This is how you know these are the kinds of stories that you get from people that are actually doing this shit versus pretender clowns. It's crazy. It'd be like watching the news or whatever, right, on TV, and then you'd start to hearing like, oh fuck, here we go. And it'd start screeching like in the distance. And then the TV would start to scramble. So I learned within the past couple of weeks that NASA has 2 C5 galaxies. Wouldn't it be interesting if they could retrofit the inside to look like the ISS? You know, like how many modules can they replicate inside of a C5? What is something like 3 going one way and 2 going the other way? 3 going one way and 1 going the other way?
Yeah, usually when they present their footage, right? It's we don't really see all of the different modules anyway, so they would could just put 1 or 2 up there and go and do 30 or 40 different takes, 40 seconds at a time.
Right. I think they can go longer than that.
I think
like, let's say these things can go to like 55,000 feet, just hypothetically. Not that I've ever been 55,000 feet before. It's something like that. Pretty freaking high.
Yeah. And then
I
how
could
long
probably
could
push
you
it to
keep that
60.
parabolic arc?
Right. You know, and you do this like over the Pacific. Again and again and again.
Well, look at what what's his name? Richard Branson had. The Virgin Galactic. Wasn't that 3 minutes or something? 3 minutes of weightlessness?
Then there was the Big Bang Theory, where they put those dorks up in a fake ISS. It was like the space station episode. And on the DVD set, man, I need to find that. The DVD set had a special on the making of for that Big Bang Theory episode where they showed them all doing weightlessness and like playing with objects in 0G. Like they had like necklaces floating around and the necklace string was like looping and crunching and floating around. It was all fucking CGI, like augmented reality.
Mm-hmm.
And this is like 10 years ago.
Yep. I mean, just the budget of a TV show in 2004, they were able to trick people into thinking that they actually went to space. Space cadets.
It's funny. So, like in American English,
Yeah.
calling someone a space cadet's like calling them a retard.
Yeah. This was in 2004. 2004 technology on a TV show budget, and they literally tricked multiple people into thinking that they left the Earth in a capsule, went to space, and then the look on their face when they were looking out the window at the globe on a screen, but they thought it was real. They were all freaking out that they thought they were in space.
Then you found out that one of the astronauts for that Dragon capsule, that SpaceX mission doing the circumpolar flight, that she specialized in like augmented and virtual reality, cinematography, special effects, and space shit on top of that.
Yeah, she was an expert on faking
Faking
what
space.
it looks like faking space from a capsule.
What are the chances, right? What are the chances you get an astronaut to do that? And she just happens to be like one of the world's foremost experts on faking space.
Yep, and it was meant to be the first proper pole to pole to pole orbit. And then it also, she just happens to have been one of the main employees on One More Orbit in 2019.
Oh.
It's just another coincidence.
I mean, she's got the experience.
Yeah.
That's right. I mean, they loved her resume.
So just to read out the official breakdown, Space Cadets 2005 was a Channel 4 reality show where British contestants were tricked into believing that they were training in Russia and flying to space, when they were actually on a former RAF base in Suffolk. Costing $5 million, it used actors, a flight simulator, and detailed sets to create the hoax, which lasted 2 weeks.
Damn.
So imagine if they never told them that they were being pranked. And they never told anyone that it was a prank, and they just told everyone that, look, we've sent people to space. Here's footage of them floating around. Well, here's footage of them in space looking at the globe from a capsule. Right? Here's the training they went through. Here's all the footage of the training. Here's them giving interviews about their experience in space, and you know, why would they be lying? They saw it. We could put them on a lie detector, and they're going to pass the lie detector test. But they didn't really go there, and that's the way it happened.
Raise your hand if you ever have to take lie detector tests for work.
No, not me.
No.
I have.
Same.
You know, but they probably weren't lying either. Like, for all we know, they were told that it's just going to be a simulation, and you're going to mimic, and you know, you're doing a bit for kids because they want to see what it looks like in space. So you're going to simulate that.
Who are you talking about?
This person y'all were just talking about, where they were.
Well, this was a reality TV show. They had about 10 people or something like that, and there were a couple of them that were in on it. And it's interesting if you watch it because they did interviews and they're like, wow, this is crazy. They're like, these people will believe anything that they get told as long as it sounds like it's coming from an expert. And the people that were in on it were just shocked at how gullible these people were.
Yeah, I thought the same thing when I would watch that show Pawn Stars, and they would bring experts in to talk about these objects that people were pawning. They're like, "Oh, that object's worth like $50,000." I'm like, "How do you figure that?" Well, like you said, if they're an expert, anybody will listen to them. So that was what the show was. It's kind of like Big Brother, where they have like one or two people in on it, and everybody else is just following along.
Yeah. Yep. They got
It's
told
worth
that they're. Yeah, definitely watch it, Skidets.
Did they tell them at the end?
Oh, go ahead. Sorry.
No, you go ahead, Yoder. My questions are becoming more redundant.
I was going to switch gears a bit and maybe ask DJ to review. I could debrief him on the debate between Ruhif and Nathan Thompson. Might be good to talk
Dude,
about.
I used to like Nathan Thompson. I used to think he
Me
had good
too.
arguments. Now, Nathan Thompson is either a complete retard or he's just like playing a character. He's playing some sort of role as a flat earther for his income or something like that. I'm not sure because I don't believe that he could be that disingenuous and have such bad arguments.
I watched the
if
video
anyone wants
too.
to, did you watch it?
Dude, yeah, I came to the same conclusion. I'm like, no, there's no freaking way he's saying this shit. Like, he's playing a character.
Yeah. Just like he was playing a character when the apparent Harvard students in the chicken suits tricked him, right?
Yeah.
There's no way he can be that retarded. I will use that word because it's the accurate word to use, right? That he could have been tricked into dressing up in a chicken suit, right, and being in a mockumentary against Flat Earth and thinking that it was genuine. Like, if you watch the series of that unsuccessful prank on Flat Earth by the so-called Harvard students, which were just pretending to be Harvard students, they were just YouTubers, right? And they apparently tricked Nathan Thompson, paid for him to come out to this place, and they said that they were going to test if the Earth's a globe or flat, and that they were flat earthers and blah blah blah. But the whole thing was clearly just a prank, and Nathan Thompson was clearly in on the prank without a doubt, and lying to everyone about the details about it. Now, yeah,
it's interesting.
The other day he had this debate with Ruhif. Ruhif is a slimy snake anti-flat earther. Okay, and but he absolutely demolished Nathan Thompson in the debate and just made him look like an absolute fool and made flat earthers look stupid as well. It wasn't really Ruhif that did it, it was Nathan Thompson that did it. If anyone wants to watch it, just go to Modern Day Debate and watch the most recent debate with Ruhif versus Nathan Thompson. It's shocking.
I think what I've just witnessed opened up a wider discussion, a discussion that's been ongoing within the undercurrents of some of us in 24/7 for years. And that is, it almost looks like the whole flat earth movement today, when you look at those people that were involved in the beginning and watch what they've become now, and look at their evolution over the years, it's almost like flat earth may have begun as some kind of like stupid freaking psyop of sorts, but it got legs and ended up being real. and some of these people, these early folks that were involved in it, call them fucking agents or plants, I don't care. They've been exposed, their mask is dropped, and we're left with actual real world measurements and proof that the earth is not a globe.
Womp womp.
Yeah, like it backfired. And like some of these ass clowns continue to make embarrassments of themselves, almost as if to drag down our community with them, right? You got like Jared, you got a few other people in the mix. Nathan now, I would probably add to that after his piss poor performance.
And that stinks about Nathan because one of his arguments is one of my favorites. You don't know you're moving. How do you know you're moving? Like that's one of my favorite questions to ask. And oddly enough, Ruhif is the reason why I started looking into refraction for bottom up obstruction because he showed me that laser bending upward. I'm like, wait, why is that laser bending upward and not downward?
Oh, when it bends up only over like 20 feet, but then you see that it's a mirage.
Ruhif butchered
you can
the shit
see
out of
the-
refraction. Ruhif was saying that. So Ruhif doesn't seem to know that there's something called sinking, right? Which is like it's like a light version of an inferior mirage, where you don't have the total internal reflection, you don't have that mirroring effect noticeable. It just looks like something that would normally be visible on the geographical horizon apparently sinks beneath it. That's the actual definition of what it is. Sky Free demonstrates it hundreds of times in their videos brilliantly. Okay, and Ruhif doesn't seem to know that that exists. He says that nothing can appear to disappear bottom up unless there's an inferior mirage, and if there's an inferior mirage, you can see that obviously there's an inferior mirage taking place because of the mirroring effect, the band on the where the ground and the sky appear to meet. But yeah, unfortunately, Nathan Thompson had no idea what he was talking about. He was invoking what's it called, atmospheric magnification as the reason why things can appear to disappear bottom up, lensing or whatever. Don't think that's a good argument personally. There's no evidence that that happens other than using something that's not analogous to the atmosphere, like a Fresnel lens or a magnifying glass.
There is one observation that does show it, but like you said, he was making a bad argument. He didn't understand what he was saying. If y'all
Are you talking about the one
anything,
where they're driving down that road and it looks like the yeah, I think that's just an optical illusion, in my opinion.
could be, but there's heat coming off of that thing, and so like I mentioned before, talking about the temperature inversion, the trapping of heat under cool air, and
Right, but why wouldn't that happen? That would happen all the time then.
I mean, it happens, just not.
Yeah,
just
have a look
not
at this
everywhere.
in the side chat though. Right, which moon's the bigger moon?
Yeah, no, I get that.
Yeah, you can have more extreme versions of this. I've seen optical illusions where you're like, no freaking way are those lines the same length. No way in the world. That's impossible. And then someone will just move one line next to the other one and you're like, what the hell? Like, that is crazy how easily we can be tricked like that. I think it's something along those lines. I think there is also some merit to the magnification effect, and we absolutely know it can happen vertically. Whether it can happen horizontally is a different question.
Yeah, well, we can see it happen horizontally with the windmill video that I put out there.
Towering. Yeah, it happens. Yeah, it happens with towering. We see it with the sun. We see it with Skunk Bay. Super common effect. Yeah, towering absolutely, and stooping the opposite of towering. And I think that.
Now, I'm not complaining to know exactly what's going on. I'm just saying, like, this could be a reason why.
Yeah, it's compelling, and it does act. I mean, the actual mainstream go-to definition of mirage, right, from the American Meteorological Society, says in the first sentence that the atmosphere acts like a lens.
Right.
But
and if you take
not like a magnifying glass, really. Go ahead, Chief.
Well, yeah. Well, so you see the shrinking mill, and you see as you get closer, like what happens when you with a camera, right? You want to zoom into something far away. The camera lens itself, it expands right away from the camera, and it creates that it narrows the angle. Refraction that occurs in that lens is bringing the image closer to you in that aspect, and that's what I say is happening in the shrinking mill. If y'all find a shrinking mill in Canada, where they drive down that road and you see the mill, and it literally looks like it dead ends into that. But as you get closer, it shrinks, and then once you get on top, you realize the mill isn't even there. There's a berm there. It's actually down below the berm, and so from the other end of the road, when you start to approach it, it's being lifted up and it's being magnified. And that's why I make that argument. But like I said, I can't truly explain it in full detail. That's just what compelled me to make that argument.
Well, Dr. John D actually demonstrates some of this. Sorry, go ahead.
I've seen that effect in person, and I implore you to find tree tunnels in your local area, find objects at the end of those tunnels, and drive towards them. You'll see something similar.
Yep.
So during the Rampion wind farm demonstration, Dr. John D talks about the width of the pylons of the windmills. And he says, look, those windmill pylons are conducting heat. You know, they're radiated by the sun's energy, and they're warm. They're much, much, much warmer, hotter than the surrounding air. And that's why some of the windmills that are further beyond the nearer windmills, miles beyond the nearer windmills, appear to be almost as thick as the nearer windmills because of the lensing effect, due to the heat of the windmills against the backdrop in the surrounding air that's very cold.
Great point. Never noticed that. Have a look in the side chat. Checks out.
Did Ruhev try to bring up the final experiment?
Nope.
He brought up LIGO and totally butchered and misrepresented it. It was disappointing.
That's good. They've given up on the final experiment.
Ruhev claimed that LIGO. Go ahead.
No, you go ahead. No.
Just say, okay, so Ruhev brought up that LIGO, during the construction of LIGO at the Louisiana version, so there are several LIGOs, right? There's one, I think, in Chicago, one in Louisiana, one in Washington State. But he said the one in Louisiana used earth curvature in order to do the excavation and the alignment of the laser through the tunnel. And they had to basically, on one end, if you can imagine a dome of Earth, a globe Earth, on the far right end, you would have to be basically bent up from the ground. And on the far left, you'd have to be bent up from the ground. And it meets in the middle, right? And by bending them up from relative to the ground, you make a straight tunnel. So he's saying that this is basically what they did. They excavated a cord, essentially, through the curvature of the Earth. That's the claim, but I've got some survey notes from surveys that were done at all the sites. And what I have written down here from the notes is that at each of the sites, they use differential GPS. Differential GPS is a very highly localized GPS reckoning that not only takes into account the GPS satellite network, but also local radio stations, cell towers, and even people's Wi-Fi emitters in their houses for their routers. And all of these different sources allows them to produce very accurate, very high fidelity coordinate fixes. And the other interesting thing is DGPS, differential GPS, uses a localized tangent plane. That is to say, they do not consider the curvature of the Earth when using DGPS. They render your location and all points relative to you as if it existed on a flat plane. And I've got these survey reports that describes how DGPS was used in order to construct the LIGO at the Washington site as if Earth was on a flat tangent plane relative to WGS-84 in accordance with how DGPS works. In other words, they did not take into account the curvature of the Earth. I've got one more paper. Holy crap, what's going on? Sounds like a bunch of chickens cackling in the background. Can somebody mute the hens? Freaking cackling hen. I've got another report that says that that an independent survey company was brought in to validate
the z-axis of the LIGO arms. So basically, in other words, they were brought in to make sure that the tunnel was straight and not curving with the curvature of the Earth, but actually straight, even though Earth may be curved. And in this report, towards the end, they say that they were unable to validate the z-axis that was provided by the original construction of the LIGO arm, which means they were incapable of discerning whether or not the LIGO arm was curving with the drop over distance of the curvature of the Earth. So both of these are on 24/7, our home server. I think Indio has them, so if you like do a name search for Indio and type in LIGO, you're going to find all this. Definitely worth researching, and it's really interesting how Ruhif seems to have misrepresented the claims.
Yeah, so exactly. Good point. Check out what Sheepdog posted. Just taking it back to the last conversation about magnification. That is a trippy one, right? 2 minutes after the hour. But that's not just vertical stretching, right? That's a point Ruhif made when Nathan Thompson tried to bring up magnification. He said magnification does happen, but it only happens vertically. But we can see in this, what looks like an inferior mirage, they're not just magnifying vertically, they're magnifying in every way.
All right, so Ruhif, if you're listening and if that's true, can you show us an inferior mirage where boats are going over the horizon and they're flipped upside down and disappearing from the top to the bottom?
Well, he basically hand-wave dismissed any observation at lower altitude. So he shat on all the surveyors, every single glober that's made a claim from any lower altitude. And his argument was that you have to be up at a certain altitude, and then you can accurately just predict what the refraction would be. And he used the Canigou observation where the sun passes over Canigou, it silhouettes it, and the top of Canigou should be well below the curvature of the Earth. You shouldn't be able to see it, but he said that that's a globe proof because the flat earthers didn't take refraction into account, so Ruhif decided to guess the refraction based off the globe, I'm guessing, based off the refraction coefficient, which presupposes a globe. And then once you take that into account, then all of a sudden it's a globe.
Wow, so he needs to put up where his back-engineered refraction index corresponds to the true meteorological conditions as measured at that place throughout the day. We're talking
it's just predictable. It's just predictable. Yeah. He said you can just guess it.
Yep. They should get like the weather for that day, the water temperature for that day, and they should go, oh, the air temperature and the water temperature, if you ratio that together, the refraction should be this. Plug it in and say, yep, see, there's the refraction.
Hello, everyone.
Hey, what's up, buddy?
Hello there.
General Kenobi. Yeah, the other thing Ruhif said was in a Canigou photograph, he said the black was the horizon, whereas no evidence that it is the horizon.
Uh-huh. Good point. Yeah, we can't be guessing the refractive index. Okay, anyone can go to Google right now and they can type in mirage in mountains and you're going to see all sorts of crazy shit from altitude. So to say that the atmospheric refraction, once you go up past a certain height, is controlled not by the temperature gradient, by the natural a decrease in the atmospheric pressure as you go up in altitude. Well, no, we can see mirages from planes. We can see mirages from mountaintops, like crazy ones. Right? If you have a look in the side chat,
You can see mirages over ice lakes.
Yep.
Yeah,
Well, that's
I've
not
got a
proven
mirage
visual.
which the ground level is not miraged, and then higher up is miraged.
Yeah. You can
Yep.
see an inferior and a superior mirage of the same thing at the same time.
Yeah, absolutely. And quite often, these mirages have nothing to do with some sort of uniform change in the vertical temperature gradient, which controls the refractive index. Usually, it's caused by some turbulent layer of air, right, or some pocket of air where you have like a sudden change, a drastic change all of a sudden in the refractive index, and that's what's going to create this chaos.
Yeah,
But
it's
yeah,
like
more
a
in the side
temperature
chat there.
inversion or something.
Yeah, it's turbulence, a turbulent patch of air, like you know, you can be walking along and then all of a sudden you get into like some hot patch of air. You're like, damn,
What
it
always
just
happens,
changes.
DJ? Sorry.
Mm-hmm.
What always happens too is whenever there's a mirage, refraction, whatever you want to call it, reflection, TIR, total internal, you're going to get some kind of reduction in fidelity. Always, always, always. And it's because the medium, the conditions that you're looking through is chaotic and random and doesn't know what the image is supposed to look like that's well beyond that the light from the image is being distorted through. Right? I mean, it's not like the air says, oh, that's a boat in the far distance. There's a Jimmy Neutron over there. We're gonna flip the boat upside down and move it further lower towards the surface, and we're gonna increase image fidelity so Jimmy Neutron's gonna see a perfect spitting image of that boat flipped upside down underneath it.
Nice.
You know, there's going to be some reduction in image fidelity as a telltale sign of when the conditions that are present are not clear, are not uniform. So when we have perfectly clear, uniform, high fidelity images, hyper zoomed with a shitty sensor like on a P900, and we can resolve amazing detail, things that are in the far distance, I like to ask, what is the evidence that there's refraction? You're going to have to demonstrate that there's some kind of loss in fidelity due to the medium that we're peering through. This applies to terrestrial refraction claims. Absolutely.
Yeah, definitely.
Yeah, the image is going to be warbled and distorted, and not due to sensor resolution limitations. It's going to be due to meteorological, atmospheric limitations. It's going to be due to the chaotic soup that you're looking through, if that is indeed happening the way they say it is. So when you can see the bottom of an oil rig at 9.4 miles from 10 inches off the ground, that's one hell of a claim that over miles you don't have a loss of fidelity and you're claiming terrestrial refraction at the same time. That is just fucked up.
Well, yeah, what they're claiming is extreme downward bending of light. And that would be allowing us to see further, but even according to the mainstream, when we have more extreme downward bending of light. So when we have a little bit of downward bending of light, we could have a little bit of looming, right? This all falls under the category of superior mirage, the opposite of inferior mirage. Okay, when the light will be deviating downward towards the cooler air down lower. And then if you just have a little bit of downward bending, okay, it's just a little bit cooler down lower, then you have looming. And then if you have more, then you have the superior mirage. And then you have even more than that, right, of a change in the refractive index gradient. Then you start to get crazy, extreme superior mirages like Fata Morganas and things like that. Now, they're trying to tell us that we should be able to see further. The more the light bends down, the further we should be able to see beyond the curvature of the Earth. But if you have a look at the images that I just posted in the side chat, we can see much less distance when we have what they would consider extreme downward bending of light, and we have the same oil platforms with extreme Fata Morgana situation. Okay, we don't see further. We see less distance. It's more destructive when we have more extreme refraction.
That's a lot of inversion layers. That's crazy.
Yeah, so when they're saying, like the original Black Swan image, that's extreme refraction, no. This is extreme refraction. This is way more, right? This is a Fata Morgana. This is a textbook definition Fata Morgana, which would be an extreme version of a superior mirage, which would mean you have extreme downward bending of the light. So they're all over the place. They contradict themselves. They're butchering the mainstream claims of how refraction works.
So I'm tempted right now to steelman the globe. And let me steelman the globe by suggesting something that you probably haven't heard of before and nobody's ever heard of in chat. Ooh. All right, here it goes. The water temperature above the surface of the camera and the Black Swan, right there at the shoreline, is going to be warmer. And the water temperature cools with distance as it gets deeper and deeper and deeper out towards the oil rigs. Therefore, the observer is staring through a gradient of air that cools with distance and thus bends around the curvature of the Earth.
Why would it bend around the curvature of Earth?
Because it's cooling, so it will bend, but it looks straight. Because if it cooled over a flat surface, then you'd have the sinking.
How much temperature change would be required to actually cause the refraction of the light to curve at the rate that you're claiming it ought to?
I don't know exactly, but if I were to take a wild guess, the shoreline that has the water lapping up against it is quite warm, and the water over at an oil rig 9 miles out is going to be freaking freezing cold.
What if we just went up in altitude to say a lookout that's quite high, like 50 feet up in the air?
That'd probably do you a bit better.
All right, I'll post one.
So you're talking about a horizontal gradient.
Yeah, the horizontal gradient. Horizontal gradient, sorry. This is the horizontal gradient, guys. I'm steel manning the globe. It's the horizontal gradient that is often shown deridingly in these images with the vertical columns that increase in density, with the observer over the curvature of the Earth. There it is. It's warm at the observer from 1 foot off the ground and freaking freezing cold above the oil rig 9 miles out in the deep ocean. Increasing in density. The reason why it looks flat is because the Earth is curved, bitches.
Right, so we could just go up a bit in altitude, and then that would
Right,
kind of
where it mixes
dismiss
more
that.
uniformly. Yep. So
Right, I got that. "76-foot height, Black Swan 76-foot height." All right, let's go.
I see what you're doing. Shut them down, sheepdog, with the road, but the road is not that far. It's not that long. You have a relatively uniform temperature above the road, the entire sight line. Therefore, I would expect to see some kind of subrefraction effects like that. Again, I'm
And how
still
do you
manning the globe,
explain?
still manning the globe, guys. Caveat.
Yes. How do you then explain not having?
Whoop, roboting.
How do you then explain when there's not as much refraction and you still see farther?
How do you know there's not as much refraction and you're seeing farther?
Well, I'm using distortion as my ruler for how much refraction is actually being observed
Yes,
between me and the
look,
object.
you get a gold star. You were listening. There's a loss of image fidelity, and anytime there's kind of an invocation of refraction, there has to be. It's absolute. Very good.
Very nice. You have done it, tactical droid. You win the prize.
Tactical droid for moderator. You get a green label in 24/7.
We have the 76-foot observation in the side chat with the math and stuff in the GIF.
Love it. Yeah, that's good. So, you know, in this way, like you don't just need to be low on the ground. You need some long distance imagery work from higher off the ground, and even higher, and even higher. Like the more data, the better.
Yeah, yeah, I agree. You know, some globers will try to dismiss certain arguments based on the height of the observer. So we could go all the way from 3 inches from that Canada Lake experiment all the way up to 30,000 feet, Jay Tolan.
Boom, yeah, and then infrared, which is just like holy shit.
Turns out that air to ground observations or ground to air observations aren't considered to fall under the category of terrestrial refraction.
Ooh.
It's a subcategory kind of thing that hasn't really been defined as yet, but they kind of just throw it in there as vertical refraction. It's more on par with astronomical refraction. Even though
what if we were standing on Mount Everest?
Light hasn't entered from outside the atmosphere, as is claimed by the globe when it comes to
Sounds
astronomical
like super and subrefraction. Have you heard of those before?
Yeah, I heard it mentioned.
I come across super and subrefraction in surveying. They're different than terrestrial, different than astronomical refraction.
Right, but terrestrial refraction is going to involve any type of refraction which is coming from a point source on the surface.
Yeah, terrestrial refraction
requires
point surface.
the curvature of the Earth to be present in it. But super and subrefraction, not necessarily.
I disagree. I'm just going to point out my disagreement. We've already gone back and forth with.
I know that it's descriptions of super and subrefraction don't necessarily take in the curvature of the Earth. They just take into consideration the density gradient above and below, like going up from the Earth. There's no Earth curvature in there. Now they can add it in.
From the research that I've done, it seems very consistent that atmospheric refraction is just the claim. It's like the blanket statement for any refraction in the atmosphere. And then we have subcategories starting with the ground level, which would be the terrestrial, like the Earth. Okay. And when you're looking at something that's a terrestrial object, okay, like an oil platform or a mountain or anything like that, it's just refraction in relation to looking at something that's terrestrial. It has nothing to do with whether the Earth's a globe or not, but it is very, very often butchered by people that believe that the Earth's a globe, and they will presuppose that and add the globe, right, add the radius into their terrestrial refraction calculations. That is, I think, fallacious and incorrect to do, and that should be called out. But just in general, terrestrial refraction should just be referring to anything that is related to the deviation of the light in relation to a terrestrial object that you're looking at.
I would get that, but there is the standard terrestrial refraction that incorporates the R value.
Yeah, that's where it comes to butchering the actual definition of it, because none of the actual definitions of terrestrial refraction have anything to do with an R value or anything like that in it. It's just only if you presuppose the Earth's a globe and then you add it in. What's that?
Did Andrew Thomas Young butcher it?
Well, he doesn't have a definition of terrestrial refraction on his website. I don't think. I'm sure I have.
7/6R.
Yeah, that's not in the definition of terrestrial refraction. I got tons of definitions. Like
I know, I do too, but I thought he was like famously parading 7/6R.
Yeah. That's when the globers start to butcher something simple that's terrestrial refraction. Like you could like terrestrial refraction would count as like a sky-free observation, like on a flat floor inside their house. It's still terrestrial refraction. You would never obviously add 7/6R in that case, right? Because it's a flat floor, but it's still terrestrial. Or if you were to do it over, say, like that one with the little boat or something like that on a flat piece of ground that's been leveled out like that or flattened out, it still counts as terrestrial refraction because it's a terrestrial observation. But yeah, I think we kind of do agree with each other that the mainstream subject matter experts think that they're on a globe, so they will incorporate the radius value when they talk about it.
Well,
which is butchering.
What's up, guys?
Hey, what's up, India?
Well, Andrew Thomas Young on his page admits that 7/6R is simplified. It's just a simplified model. I don't think he makes any claim to it being accurate. I think it's more like what would you call it? An intellectual exercise than it is. This is what's happening.
Yeah. And a rule of thumb.
Well, what I don't like is when in the literature they have the K constant, the K value, which is the reciprocal of the radius to, some other radius ray.
Right.
They're literally making it a unit of measure. They're making the globe in the deviation, the globe a unit of measure, which is crazy, dude. So you start with the globe and then you measure the light. And whatever it is, that means that light curved at some radius which is proportional to the globe. Right? A K constant.
Yep.
Yeah, and that's assuming you have a uniform conditions.
Well, I mean, whatever it
butchering
is,
it.
right? They got 20. Yeah, exactly. So they got like you've seen it in Walter Bislin's, right? With the K constant's like 200 or something or 20,000. When you max out the where it has the effective radius, that effective radius is he calculates the K value and then that will spit out the quote unquote effective radius, meaning how flat it looks.
Which means if you net out the curvature of the Earth, you should be able to get the meteorological conditions at that time.
Should. That's impossible.
Yeah.
Good
Well, I was
luck,
going to
man.
with that.
I'll give you like $100 if you can just take some video and then write down the weather conditions that day. It's like 40 degrees Celsius and 30% humidity, and I'll give you $100. You can do that.
And then
You can
solve
do
for
it
the
one out
curvature
of
of the Earth.
1,000. If you can do it once out of 1,000, I'll give you $100.
That'd be funny, dude. Like, yeah, here's the weather report. We can derive the Earth's radius from it.
Well, and then they get, oh, here's what I see. And since the Earth is a globe and everything is displaced by this much, the weather should be this. Right? That's what it
Yeah,
should be. It should be
works both
reversible.
ways. Yeah. What I was trying to say now, what I've read in the literature is that like super and subrefraction don't necessarily take in the R value at all.
Well, in radar, I haven't really seen the subrefraction thing in radar. In
Yeah,
reference
me
to
neither,
radar,
actually.
yeah, I've
Not
never seen
radio.
it in like the microwave or visible light. I've never seen it in that
That's a
or
good
X
point.
band or anything else. Wonders, is this GPS refracted?
Yeah, like at low glancing angles to the satellites. Maybe that's why they don't acquire signals from below 14 degrees or whatever the fuck.
Oh, that's why they use the tangent plane. We solved it. That's why they're doing it. Because it's
Yeah.
locally flat.
To me, the smoking gun is that the horizon is the only thing that seems to move in relationship to other things, right? So in the black swan, you have what should be, right, a geometric physical earth hump move behind two oil rigs, right, magically by refraction. It changes its actual physical position or apparent position based on the weather. I would figure that everything physical would be moving consistently, staying in the same location or relationship locally to whatever the other objects are around it. So if you're just going to arbitrarily make the Earth flatter with an equator or a K value, well, then you've already told us that on this day you just see farther.
I'm glad you brought that up. I mean, that's in Indio's video with the black swan and talking about the behavior of light. Like it's basically mathematically moving the curvature of the Earth, and this creates a speed of light violation. Besides an obstruction issue.
Right.
Yeah, you would need superluminal light to, whatever it is, to leapfrog. It's like the light that's propagating from the further away horizon is somehow leapfrogging, or the light that's close is leapfrogging to the behind or something.
That's
which is
right.
Yeah.
And I've pointed this out a few times in all the demonstrations. The Glovers do their butane and their dry ice, CO2 gas, and their methane, and go, look, refraction can pick things up over the curve. In none of those videos do you see the horizon in those videos move around, right? The horizon being the edge of their butane container or piece of cardboard or whatever they're using. You never see it move 1 millimeter. You don't see it shift at all.
No. It usually just looks like turbulence, honestly.
And they're still using flat gradients too, not curving gradients.
Can you simulate a turbulent curving gradient? How would you do that?
I don't know. It's like how do you get a bunch of gas molecules to not only curve in a gradient but also rotate themselves in the gradient? Oh, gravity does that.
But hang on, if you claim a curved line of sight, then you're throwing away any ability to use it as a tangent plane.
I agree.
Well, if your line of sight, yeah, it's supposed to be the horizontal reference itself. And you don't know if it's curving or not because you're a glober. Then your measurements are all fucked up. And then they try to rectify that, right, by dropping a plumb line. But then they're like, oh, fuck, I don't know if my plumb line's curved either.
Just in relation to the super refraction that people try to claim, I don't think there's such a thing as this super refraction where you can have a long distance observation that doesn't show any distortion, right? And everything looks nice and clear, and we do it during the day and we do it during the night, and everything looks exactly the same.
Yeah,
right?
horizontal.
Like the 21 mile Great Salt Lake observation, perfect example. And they're claiming it's this super magical refraction. They're calling it super refraction. I think with visible light, there's no such thing. And I think this super refraction already has a name, and it's extremely destructive, and it's called a superior mirage and a fata morgana. And it's obvious, and we're not going to use that in an observation if that's happening to claim anything.
Yeah, if they're claiming super refraction makes the curved surface look flat, and you're looking out into the distance over greater and greater amounts of curve, then they're claiming that in order for the image itself to not lose fidelity, that all the light that you're seeing that's being reflected off of that curving surface are taking different curving angles, arc angles, in order to reach your eye. And that somehow the atmosphere is modifying each angle such that they conform to the curvature of the Earth, the same lapse rate as you would see.
Yeah.
And that's just fucking insane. Because it's in reality, that's not going to be the case. And in reality, what would happen as a consequence of that is a loss of fidelity.
Right. And, prove us wrong, right? I was talking with Cosmos and Mez and all of those idiots in politics over the other day about this, and they kept going on about super refraction. I'm like, all right, well, okay, if you want to make a claim that there's something called super refraction, show me the definition from a mainstream source, not ChatGPT, okay, that explains exactly what super refraction is. I can't find that definition. And then show it to me, right? Show a situation where we have super refraction present in an observation where they took everything into account to the best of their ability that they could, and it matches up with a globe. And
yeah, without any detectable chromatic separation either.
Yeah, exactly. Yeah, and they just spazzed out and got angry at me for asking for them to back their claims up.
If refraction existed the way that they claim it is happening all the time, then you'd see fucking rainbows everywhere.
We'd see all kinds of crazy shit, man.
Like a
like we'd see like double images of stuff and upside down stuff. I mean, occasionally we do see upside down stuff, but like it's really weird that how not only is the air acting like a lens, it's actually like a perfect lens that just magnifies everything evenly and most of the time, right?
because it has to be magnifying everything like generally most of the time, according to those guys. Like it's just so selective. It only picks things up over the curve. Like that's the only thing it does out of all the stuff lenses could possibly do. Just that one thing.
Yeah.
And then you look behind you, and it's the same.
Right, exactly. That's why I like the Great Salt Lake one once again, because we don't have a horizon and sky in the distance. We have mountains, and then we have a look at some of these closer up images, which I'm uploading now into the side chat. And not only do we have all of the water perfectly lifting up beyond the geometric horizon to the exact right height, we also have the entire shoreline, and then it's 2 more kilometers from the shoreline to that smokestack. And then we have a mining town, and then we have all the mountains in the background. And they're claiming that in these next images, okay, so this is the nighttime from 21 miles away. This is the daytime shot from 21 miles away. That this crazy super refraction is happening. It's not only lifting up all of the water to the perfect height, it's doing it with everything in the background as well, including the mountains.
Yeah, the exact amount to make it all look flat. Even though it has to pick it up differently. Yeah, it has to pick up like because it's supposed to be an exponential curve, right? So it has to be even more refraction further away. Because it has to pick it up even further. Can't be linear, has to be exponential refraction. That's why Matt pisses me off with his, it's only 0.0007 degrees per mile. Dude, that is so dishonest. It's just the most dishonest false equivalence. I mean, it's technically true.
No, it's wrong, dude, because every point of light is going to have to bend at a different rate to reach your eye from different distances.
Yeah, I looked into
yeah,
that.
that's right,
It's
because I
total
pointed
bullshit.
that out.
That's the wrong math.
Yeah, that's right. It can't be linear. Yeah, I pointed that out to him. Now I think about it. I think the last time I talked to him, I said, Matt, that would be linear. How could the deflection be linear if the curve is exponential? Then he said I have to go or something.
You guys see what the real boss just posted? Oh my god, radio transmission. That definitely must mean there's a fucking orbit in tin can, you know, going 17,500 miles around a sphere Earth that doesn't exist. Brilliant.
Y'all are gonna have a field day when it gets deorbited in like 3 or 4 years.
Yeah, or when hotels are built on the moon.
Yeah, that's bullshit. It's like Gru Space. There's like a Y Combinator startup right now that's pitching that. And I'm like, how the fuck are you getting investment on that idea?
Yeah, man, like back in the late 70s, Pan Am Airlines were selling tickets in advance of a moon hotel that they were supposedly building.
Yeah, I've got a lot of those articles. Those see if I can find some.
Which is funny because they went out of business.
Or like the ISS movie that Tom Cruise was supposed to do a couple years ago, and then he got into a spat with the Trump administration and canceled it.
Oh, that's hilarious.
Is this a real ad? This one, I'm putting it in the side chat. It says "Soon to the moon."
Probably. This looks like the stuff that I remember seeing. I mean, it was so over the top that there was a lot of Apollo skepticism back then. The idea that like Americans wholesale bought the moon landing story is not really founded. And there was a lot of skepticism regarding the Sputnik claim when that came out. It's funny because, like today, you'll read, "Oh yeah, Americans were scared of Sputnik because the Russians were promising to weaponize space, and they beat us to the punch," and all this that. But back then, I mean, people were insanely skeptical of Russia's claims. You know, it really took America's validation of Sputnik to help people accept it. The American government, rather. But we've got all these news articles, letters to the editor from people calling themselves physicists, whether they were or weren't, who cares? But they're like, yeah, no, I don't buy any of this. There's no way that they could put 80 kilograms of metal into self-sustainable orbit. As I mentioned 100 times before, Secretary of Defense Charlie Wilson called it a cheap trick, or a scientific trick, rather. Yeah, you said that. You know, speculatively, I could come up with a reason for American policymakers to say, you know what, this Sputnik thing was bullshit, but we will pretend to believe it. And this is going to require Russia to dig in even harder into their space story. Plus, it can give us a chance to respond with a program of our own. It's even better.
Yeah, Real Boss, if you've got questions, you can get on the VC. Well, yeah, if you can hold off with filling up side chat until you can get on mic, that'd be preferable. It's easier to have these discussions in VC.
Oh man, this guy's about to step on a rig.
Broken Mic Gang checking in.
What's up?
No, he's like another guy who's got an excuse. You know, my mic's broken.
Yeah, I can't do VC.
Like, if you've been here before and we know that you've been in VC, then, you know, fine. But if you're brand new, you come in shit talking, nobody knows who you are, and you're gonna claim you can't VC. I mean, come on, dude. He says he spent hours in VC. In this VC, I don't think so.
Hasn't learned anything, if he has.
Yeah, he looks very familiar.
Yeah,
Oh, I actually have a note. Hold on, I have a note.
BFP.
I have a note that he whines in VC and runs and hides whenever he's asked for evidence. I actually wrote that.
I got to remember to leave those notes. Great idea.
Yeah, I normally date these notes, so this means it might be an older note.
No, it's super helpful because then you get people with like, you know, they change their names and profile pictures and voice changers and all that shit.
Yeah. Like, who the hell's this ban on site guy? Let me check the notes.
Yeah, fuck.
I should probably note the server that I typed the note from so that when these people follow us around like, you know, sick and
good
twisted
idea.
groupies.
Yoder, what are your thoughts on the dual pole model?
I think E1 built a globe and is too stupid to realize it.
I mean, yeah.
You know, and his explanations are incoherent. You know, he talks about lines of longitude being magnetic meridians, which they're not. And if he's going to claim that your airplane is going to orient itself such that it goes from like the 10 o'clock position to the 3 o'clock position to fly from California to freaking Hawaii or something, then I would like to see evidence of that, like meet out and perhaps maybe gyroscopes or whatever. There's got to be some physical orientation of the airplane as such to be doing all that. But he also built inadvertently a Pac-Man model, because if you were to go longitudinally north-south across whatever prime meridian he has, like centered on Africa or something, he'd end up back where he started. Same with going east-west. And so that's why I'm saying he built a globe. If you go east-west on his equator and north-south on his prime meridian, you end back right where you started in a straight line by his claim. And I'm like, dude.
Waka, 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 waka.
Yeah, I mean, yeah, I've had some back chats with people about this. I mean, this is just like the celestial theodolite, and they're on like the 40th revision of it. And about, I think now almost 2 years ago or something, no, a year and a half ago. When did that first come out? It came out well over a year ago now. They wanted to get my thoughts on this in back chats, and I'm like, guys, first off, you're using Stellarium as a flat Earth simulator. So you don't have real observations. Yeah. Second off, you know, you've got these synthetic observations without any real world verification. Third off, if your claim geometry is true, then you've got parallel light rays, you've got ray parallelism from an effectively flat surface far away that's emanating light to a flat surface on the Earth. I said it's geometrically incomprehensible. And then, you know, I later recorded Dr. Heffron at least twice. I've got actually 2 recordings stating, yeah, the consequences of this is ray parallelism from the stars to a flat Earth. Well, I mean,
which only works with distant sources, right?
Well, I mean, how would you get the parallax effect? Which you would need in order to have diverging angles to the light in the sky, because you need the parallax effect. You need a differential of angles relative to your position in order to map distances. And in this case, what they produced were the same angle to the star from 2 locations separated by 50 plus kilometers. So if that's really happening, great. I want to see physical evidence of it, which they haven't produced. You know, and this would have extreme consequences for the field of astrogeodesy and celestial navigation. I'm open to the possibility, but I mean, until then, all they have are, you know, flat Earth simulated observations with Stellarium. So, I mean, there's a lot wrong with it. I actually wrote a paper hoping it would get into the hands of Dr. Heffron and send it over to them. But by the time I'd finished it, they'd already moved on and moved their own goalposts a bunch of ways. And then because they moved the goalposts, they used that to attack my paper. And I didn't realize they'd moved on from certain arguments. Basically, there's like what I think he called it like the Heffron Delta. And this delta was basically, it was first assumed that the difference in timing of the star above the mountain peak was attributed to the optical device that was used. In Heffron's earlier presentations, he blamed it on his theodolite. And then later on, they decided to ditch that and say, no, it must be a property of atmospheric refraction.
Weird.
Yeah.
I'd be interested if they're engaging with folks outside of this community.
Say again. You were a bit bubbly wobbly.
Sorry, trying to eat my breakfast. I'd be interested to see if they're engaging with folks outside of the flat Earth community.
Yeah, they're outside their own. I mean, because it seems like anytime they do, they get some criticism and then reject it and then go about their way anyway. You know, like with this dual pole model. I mean, when they were developing it, I had a couple folks in my DMs presented to me, and I'm like, no, dude, you just built a globe. But then they went forward with it, and I'm like, all right, well, have fun with that, and don't affiliate with 24/7 Flat Earth. And there's another one regarding starfield rotation from a private flight from Germany to Brazil and back. And they claimed that the starfield did not rotate as you would expect, that the polar regions did not barbell themselves, you know, tilting north to south and south to north as the plane flew further south and then returned and flew back north again. And I'm looking at this and I'm like, well, if that's the case, then you can throw out pretty much everything that anybody's ever written about with regards to the behavior of the stars, flat or globe. And it also calls into question whether or not the image, the video we're looking at could have been doctored. I mean, how would you know? How would you be able to tell the difference between somebody who set up an equatorial mount with a camera to record the night sky, and then would take a video from inside a plane, and then superimpose the airplane's cockpit and windows over the starfield rotation taken from someone's backyard? Because that's exactly what it looked like.
I agree with that. I agree with that. The cockpit looked fucked up.
Yeah, there was so much fucked up. It looked to me exactly like that. It looked like art.
The lighting on the cockpit doesn't change; it's static.
Yeah. Yep. Good point. Good point. I mean, I had found that there, like, you can buy old like DVD sets of this kind of stuff, of like nighttime flights from cockpits. People would record this shit and upload it to, or and then record it to DVD, and people would buy it. I don't know why. I mean, people buy DVD sets of like train tracks, of trains going over train tracks for hours.
Hey! Don't fuck with the autistic.
Yep. So, I mean, who's to say that this wasn't somebody's art project? So they put that out. They also put out the claim that that the island of Crete was visible from the shoreline of Israel. I'm not so sure about that one. The one that, there's a bigger one than that. The claim that from a hilltop in Wales that you could see the French Alps.
Yeah, that one's ridiculous.
700 miles, yeah, no freaking way, dude.
I just did the angular size calculation, and I was like, nope.
Exactly. So this group of people keeps cranking this shit out, one after another, and this is just the latest thing. This dual pole flat Earth map is just the latest attempt, it seems, to put something out. And I think it's trash. It makes us all look like retards, and I'm kind of sick of it.
Well, it's kind of like AE, right? Where it's like easily dunkable. And then if they get notoriety and just sort of besmirch the entire community because they think that now y'all are doing Pac-Man shit.
Yep.
%
was on last night trying to Pac-Man. Nonsense.
I got something to say about that, Indio. When I was doing my skepticism, my speculation on just for the sake of an academic argument, I brought up the hypersphere, which I was intrigued by something called the world universe model. And you can reduce it to simple algebraic expression. It's being indistinguishable from a globe Earth, except for the lack of curvature. Percentage and a few others seem to have heard me talk about this and have borrowed a lot of what I'd put out there.
regarding
Oh, I
this.
didn't even know that.
Yeah, that they started on that after I had been giving little clinics on this. I guess they thought it was good, but it's just a thought experiment.
Yeah, and I don't even think they don't understand what. I doubt they understand what a fourth dimension means mathematically.
Yeah,
It's a
they
hard
don't.
thing that I mean, I can't really blame them. It's a hard thing to kind of wrap your mind around.
Right, it allows for a curving radius.
You're just embedding the information in another dimension that you can't perceive.
Yeah. That's exactly it. And in my opinion, this is how ECEF is able to function as a dual coordinate system. I don't mean dual like north and south. I mean it's both a coordinate system with respect to the center of a conceptual Earth, as well as a local tangent plane system relative to each observer's receiver. And
we embed information all the time to do certain things, right? In these, like the imaginary numbers, right? We're embedding information in another dimension, and like we can't actually perceive for some reason that dimension or whatever, but we'll just use it in electrical engineering to model voltage and current and resistance and all those things. But like the imaginary part technically isn't real, I guess.
Right. You know what might be analogous, Indio, is the Doom engine being actually a 2D engine, embedding engine in a fictitious 3D space relative to the engine,
Yeah,
and creating that environment.
Saving on processing power, man.
Yeah, it's brilliant. So, like with GPS, all the local tangent planes are chained together. But I mean, if you continued with the chaining, eventually they'll repeat on themselves in any direction you go. But the surface is flat.
I mean, I just can't stop thinking about it as if it's like the god of the gaps. That we don't know what this extra information is, so we've modeled it mathematically, and somehow it manifests it in reality in some way, but we don't actually know what it is. You know what I mean? Like its ontological property. Like where is it, right? Where is this imaginary, you know, waveform? You know,
Yeah,
I
you
calculate
can't.
how a wave travels through a medium, and I'm using the imaginary numbers to do the calculation, and the imaginary part has some nonlinear contribution to the real part, but I don't. But if it, but like that imaginary part is not real,
Yeah, but you need
right?
it.
Is it? Is it real? Maybe we don't know. Like there's something we're missing something, right? We're missing the part where that imaginary part actually connects to reality, and we're just basically, well, we have the math and the math works, so we're just like God of the gaps it or something, you know?
Right.
I mean, imaginary numbers pop up in control system theory as well. Like if you're trying to model an unstable system, some of the like equilibrium points are going to be imaginary, and it just means that it's unstable. Like
Yeah, but
flying
what's the
helicopters or like
ontology?
oh, go ahead.
What's the ontology of that though? Like what is actually real other than the output?
Well,
right? So there's like information embedded in this imaginary part of the calculation. There is information in there. But where is it actually in the real world?
yeah, how do you relate it to something? Yeah, like you got discriminants and they're imaginary. What the hell are they?
At least my interpretation when it comes to control systems is that the imaginary equilibrium points are basically, the thing is trying to approach equilibrium, but since it's imaginary, it can't actually reach that in reality, so it goes unstable and crashes. When it comes to like helicopters and things like that.
Here's a thought piece related to this, real quick. You know how you've got ray parallelism on a globe, which means you can't triangulate the altitude of like Polaris or any celestial body. Well, flatter globe, right? Your local tangent planes of GPS relative to the center of the globe, you can't triangulate the center of the globe from multiple local tangent planes.
Can you run that by me one more time?
Yeah, just as you can't triangulate the altitude of Polaris and flat or globe, I don't care your topology right now. With GPS's local tangent planes, each receiver, you can't use the location of each receiver to triangulate the center of the globe. The distance, it's a calculated distance. You aren't actually able to triangulate it.
Well, I don't think you're able to triangulate it, but that's why you need four. That's why you need four satellites, not just three. The fourth satellite for trilateration, not triangulation.
Yeah.
Gives you that altitude.
What he's talking about is like people go, "Oh, where's the sun? How far away is the sun in the flat Earth?" And they expect us to be able to triangulate the position of the sun, right?
Yeah, you'd need a real rotational vector that is not measured or accounted for, but calculated post fact.
Because there's like a fundamental contradiction in the model about whichever way you look, all that shit is parallel. You have multiple parallel directions, which doesn't make really sense.
I guess I'm not understanding. My understanding of GPS has nothing to do with parallel.
We're not talking about GPS. We're talking about.
Oh, sorry.
You
Sorry.
inserted GPS. We're talking about trying. He's just saying from the GPS coordinate system itself, you can't get from the ECEF, Earth-centered, Earth fixed, which is a tangent plane on the surface of a sphere. From that coordinate, you can't reverse the triangulation from invert it, right? Invert it for a convergence point at the center of the Earth. Because if you extend that, those are also parallel with no convergence point.
Bingo.
I mean, well, let me show you a diagram, Josh.
Local tangent planes would have to demonstrate some measure of rotation with respect to each other over a distance.
Can you define local tangent plane? Apologies again.
Yeah, so each receiver calculates a point of origin for itself using east-north up or east-north down. That's X, Y, and Z. And the surface is flat, not curved.
Okay. No, that makes sense. Well,
look at the diagram.
It's just okay. Appreciate it.
So check this out. So no matter where you are, like on this ball, like if I look up from the top of this circle, the rays are also parallel, but they're going in a different direction. Anyway, the point of this is that because of the parallelism of the rays within the model, that if you take a bunch of tangent planes that are tangent to this surface, let's just call them tangent lines, fuck it, tangents that are to the surface, they would also be parallel at that along that plane. So they would never actually converge. There would be no convergence point. It's just these are just mathematical. I don't know what to call them. They're not artifacts. They're just consequences of the assumptions of the models that they're using, that if you try to extend them into some other context, it ends up not self-consistent.
Huh.
So what they would expect the flat Earth is like, if we have a sun and we have a point in the dip angle, where you have the angle of the elevation angle of the sun. So you have this well, right, which is a person standing here, and it's a flat Earth, and then you have this angle. Then you should be able to get the height of the sun above the surface of the Earth, its elevation. But in the gold model, they say, wow, the sun's so far away, we have these parallel rays. And using these parallel rays, and because there's a length to the shadow, you can calculate where the shadow converges with no shadow, and that will be some point, and that would be where that intersection point is. That's how far away you are from the center of the Earth, right? Now, if you try to but if you actually reverse this and use like GPS with a bunch of tilted planes, you wouldn't and use the same parallel ray pre-assumption that you're never going to get. You're just going to get a bunch of parallel rays and no actual convergence point. If you invert, so basically invert this problem, but it kind of doesn't make sense in a way to invert it.
Yeah, they do. And my contention is, the way you'd mathematically store a value that would tell the user at what point at what point the looping repeats itself. You could embed that as a radius value in a fourth spatial dimension, a radius that is equal point to the surface of a flat looping surface. And it sounds incoherent because in three-dimensional mathematics, it is incoherent.
This is what we're talking about, Josh.
Hey, Kara's got a hot mic. Just heads up.
Yeah, they probably moved her in here because that's what the assholes in here do. People have a hot mic.
Oh,
How
really?
the
They
other
throw
cats want to
in
move them
flat
in
Earth?
here. Yeah.
Jeez.
They just throw their garbage in here. It's freaking rude. Anyway, the diagram I posted, the GPS puts you on this red square. That's like the raw coordinate will be on this red square somewhere, this tangent plane. This is where the receiver will be. Now, to get this ball underneath, they go from the orbit, where they think the orbit height is, right?
Yeah, I was gonna say, do y'all know? I mean, y'all know that like the pre-calculations for GPS is in Cartesian. It's in Earth-centered inertial first, and then they do a transformation to get to that red square.
Yeah, and before
it's just
ECI,
raw
it's in
distance
Kepler.
from the nodes.
Yeah, and before ECI, it's in Keplerian orbital elements.
Correct. Yeah. So you back out. So you have your orbital elements, and you have your time since the epoch. Your origin, your t equals 0. And then, it's basically like 4 spheres getting pulsed out from those 4 different points, and they all converge on a single spot where the receiver is. And then you're able to.
Well, here's the funny part. The loop completes itself because the satellites get their KOE from where ground stations observe the satellites to be. And the ground stations place themselves in lat and long. And then they all send their observations over to get the data crunched, and then the data is crunched and transmitted up on the backhaul to the GPS system to tell the satellites where they are in the epoch. And then the KOE.
I guess the only way that it makes sense there from a circular point of view is that the ground stations are the source of truth as far as like absolute position. Right.
No,
They aren't moving.
because their source of truth came from looking at the stars in the first place.
That's right. Now,
But
if
then,
you could do
oh, go ahead.
a ground survey of the real distances using planar methods without the celestial sphere, you will have a different coordinate system and you will yield completely different results. And I have to go to a meeting for half an hour. I'll be back.
And they'll work. That's
You're
the
good.
thing.
Right. And it'll work, yes.
Enjoy your meeting. Appreciate you, Yoder.
Cool, man. If you guys are still here in 30, I'll be back.
Yeah, I'm gonna be in and out all day, so I'll be here. My God, this stupid cruise ship video, man. This shit's so old, and like it's like been making the rounds for the last 2 or 3 days.
Oh, just Glober evidence?
No, dude, it's not. It's been around for fucking years, dude.
Well, no. I mean, like, just like bottom shelf, like easy to grab.
Yeah, well, yeah, because if you just watch the video, right? Yeah, if you watch, oh my God, I only see half the ship, but you also see that the fucking window's doubled in size at the bottom, so it's an obvious inferior mirage. But they don't pay attention to that. There we go. Oh, I can't see the bottom hull of the boat. Yeah, because it's just sailed into an inferior mirage. Because the windows at the start of the video, there's 3 rows of windows, and then one of those rows gets stretched to half the size of the boat. One way you can test these videos to see if that's happening is very simple. With perspective, everything has to sync proportionally. Okay? So you can take a frame of the video from the end, right, half the ship, and a frame of the video from the beginning, the full ship, right? And if it doesn't flip its orientation too much, you can measure by counting pixels its vertical to its horizontal proportions, and then later on you measure that again, and if they haven't changed proportionally, now something that's visible the whole time, not something that ends up getting hidden, like something that's higher, right? So say the deck of the ship, right? So say there's like a freaking painted line on the ship. It'll have a vertical to horizontal proportion. As the video goes forward, it has to maintain that vertical to horizontal proportion to scale. So if it shrinks in the vertical 10%, it should shrink in the horizontal 10%. But if it shrinks in the vertical 10% and the horizontal stays the same but merely sinks down, that's a mirage. And that's what happens to this ship. I mean, I can't believe I'll post in the chat because this is so old. But yeah, I'm gonna just look on the server for the first time I freaking dealt with this. Fucking YouTube short. Oh, God damn it.
Yeah, crazy. YouTube went down yesterday.
Did it?
Yeah, it was down for like a couple hours.
What happened?
I haven't looked
Hello.
into it yet.
Hello?
Well, who are you? Here's many people.
Hello there.
Yeah, we're chilling, man. What are you
Who are
doing?
you? Why are every people silent?
I'm literally talking to you. What are you talking about? How can 30 people talk at the same time?
Yeah,
Wait,
yeah,
everybody
I
talk, hey,
understand.
everybody, please talk at once and make a cacophony of fucking noise to make this guy happy.
India, you don't hear the voices?
No,
Uh,
no.
Those are other voices.
Oh, fuck.
They keep saying, why do they come to me to die?
Something about a videotape in 7 days. I don't know.
Hello.
Yeah, do you have something to say? Or are you just practicing saying hello?
I am just practicing.
Okay. What do you need to work on?
What?
What do you need to work on to get better? You said you're
I do
practicing.
not. Yeah, I practicing, but I do not understand what I say.
Okay. So this is intermediate advanced English channel. You might want to go to an easier one.
Okay. Okay.
Okay. So you ever do an armed robbery? You say, stick him up, give me all your money. And he says, you know, you're just practicing. I mean, he's broke. If you arm rob somebody that's broke, you're just practicing.
My phone cut out for a bit. Did anybody have evidence of a geometric horizon?
I watched Unsolved Mysteries last night. It was Where is the Geometric Horizon? They never solved the mystery. No one could find it.
Still an unsolved crime. That's a good way to put it, too. A crime. Crimes against humanity.
Swipe or no swiping. He stole the Geometric Horizon.
You know, that one alone, I've talked to a few people about it. Well, I'm thinking of one girl that showed up at my last meeting. Nice kid, friend. Uh, Talked her into coming to one of my meetings, and some of her friends came, and she kind of walked them through the evidence of where's this geometric horizon, and she's still on the fence. I don't understand. how can you realize there's no evidence of curvature and still be on the fence?
There's a psychological issue in all those things, right? There's the
Oh yeah.
There's social pressure. There's peer pressure. Let's call it what it is. It's just they're afraid of social pressure, peer pressure, being called stupid, being called an idiot.
Yeah.
Those things.
Judgment.
Yeah.
Yeah, for sure. And they're a pretty young group of kids. They're probably very susceptible to that kind of pressure. So I totally get it, but I just don't understand how you can see the argument and be on the fence. Next month we're making fun of NASA, so maybe that'll get her.
Just so some Ron Pettit or Don Pettit videos, man. That should be enough. Just listen to him talk for 5 minutes.
Yeah. Yeah, I'm definitely going to include his really good engineering and I'd go to the moon in a nanosecond videos. Maybe him playing guitar, right? Yeah, I think that's the other hang up people have is, well, there's pictures, and but are there any photographs? Let's take a look. So I think I'll get some of them next month. Remember, Obama said there hadn't been any from 72 to 2015. So all those pictures between then had to be fake. If those were fake, what about after 2015? Why would those be real? Any of you guys remember the moon photobombing the Earth one from the Discovery satellite, 1.5 million miles away? I think that's my favorite.
Oh, yeah, it's pretty good.
The moon's.
They forgot to rotate the moon. I mean, I don't know why they did that.
Bunky.
From
What
that
you think?
viewpoint, you would see the moon. You would see a different face of the moon.
Come on, bro. Hold low.
Hold on, bro. Listen, because the moon is phase locked with the Earth. It's not phase locked with a fucking satellite in space. Right? It's tightly locked to the frickin' Earth, not the fucking satellite. But they forgot to rotate the moon.
Yeah, for sure. The imagery was just ridiculous. And then the moon's 30 Earth diameters away, 238,000 miles. And I don't think you could have fit half an Earth diameter between that Earth and that moon in those series of photographs. It was so crazy, but that's got to be one of my favorite. The moon's like just buddied right on up to the Earth. You could probably throw a rock and hit it. The other one, did you remember? Was it the X-47, the Boeing space cruiser, and they sent 3 guys up to, I forget the altitude. It was like 3,000 or 5,000 miles or something. I can't remember. It was a ridiculous claim. But they sent a picture of the Earth. I showed this when it happened in one of my meetings, and they showed like a half hemispherical picture, maybe 2/3 of a hemisphere down the fuselage of this craft. And oh man, it's amazing. They're in space. There's 3 guys on board. That's just what a feat of engineering. And you look at the Earth, and there's like a diamond-shaped continent that takes up half of a hemisphere. So what continent is that? If you look at that picture, it's so crazy.
That's why I don't know who came up with this, but like when they say, "What about the pictures of Earth from space?" It's like I think it's D. It could have been DJ. Somebody that figured out that when they do this, you go, "Do you have a particular one that you really show us a particular one you really believe in that you think is the most accurate one that there's no way it's fake?" And it's funny. A lot of times they post an Earth that even NASA claims is CGI, proving that they couldn't tell the difference anyway between a CGI one and a real one in the first. So it is kind of funny. Like, because NASA can just put anything out there, literally anything. I've asked these guys, like, okay, what could NASA show you that you wouldn't believe? And they can't even think of something. Like the only thing that they wouldn't believe is if NASA showed like religious stuff, like Jesus walking on water. Then all of a sudden they wouldn't believe that, but they'll believe everything else.
Is the indoctrination that powerful, or are people that stupid?
No,
Maybe a little.
Indoctrination's that powerful.
I believe it. I mean, I was there. I wouldn't have questioned anything 5, 6 years. Well, NASA wise, yeah, I questioned the moon landing way before that, but I wouldn't have questioned heliocentric 5 years ago. I didn't know any better. After looking at it now, I have no idea how I didn't see it.
or you're changing topics. And if you're changing topics, let's get to a full logical conclusion before we change topics in the first one.
So Eratosthenes only came to the conclusion that the Earth was a sphere by looking at stars
No,
and
he
the sun's
started.
angles, and
He started with the premise the Earth is a sphere.
so he did
never
more. You're
concluded
agreeing.
the Earth is a sphere. His premise was the Earth is a sphere. He started off with that. That wasn't his conclusion.
How did he reach that conclusion, Crit?
He started with that. He started off with the Earth being a sphere.
No, he didn't.
Yes, he did.
But he didn't. But
Yes.
just because, like,
Yes.
are we
Yes,
right
he
now?
started off with
Why
the
don't you-
premise the Earth is a sphere. He started off with that premise.
Why did he start with that premise? It's because of his observations, Crit.
Because
the same thing that you said.
Okay, I'll answer the question. The state-sponsored religion, the Greek mythology, was a state-sponsored religion that Zeus defeated Atlas in one-on-one combat. Then, as a punishment, he gave Atlas two choices: either spend the rest of eternity in oblivion with the other Titans, or he can hold the Earth up for eternity. And Atlas chose to hold the Earth up. So Eratosthenes started off thinking the Earth is a globe because of a state-sponsored religion.
Do you have any factual information to back that up?
Yes, the Greek mythology. This is historical fact. Greek mythos.
So you studied Greek mythology?
Yeah, I wouldn't say I studied it. It was taught to me by the school system, which would be part of your conspiracy theory. That if they taught and didn't teach at exactly the same time, that would walk you into a contradiction about why they would lie.
So, for anyone who actually cares,
the school system
didn't just look.
Okay, yeah,
he looked at the
23. The school system taught me that
Why are you talking?
Eratosthenes. Okay, do you know this? Do you know who this is? Do you know who Eratosthenes is? Did you forget?
Are you serious right now? You're just proving to everyone you're back.
Okay, Eratosthenes was a Bronze Age gold hoarder during the Greek Age, who supposedly measured the angle of shadows cast from a sun that he said was an infinite distance away.
Correct.
Okay. He started off with the assumption that the Earth is a globe. Because he was following his state-sponsored of religion.
So you can't take another scientist's work and observations and try to calculate and see if it's correct.
I don't know.
You can't do that.
I have no idea what that means.
Yeah. So like, the other person told you that 1 + 1 is 2, and then he tried to find out if 2 + 2 is 4. Would that be a bad thing to do?
You're talking about standing on the shoulders of giants?
What?
Can I stand on the shoulders of giants? Is what you're asking me.
We're getting nowhere.
You're getting frustrated with someone that can be more frustrating than you. It's just funny to me. I won't say much because my mic's up, but I'm enjoying myself. Chris. Thank you.
I'm just realizing that nothing I say will ever get through your skull, and that's fine. I'm just hoping it gets through to your audience. That's
It's
it.
because you're not backing it up with anything.
That's how I feel about you, because I only have to say, well, you can take Eratosthenes' assumptions, measurements, use the moon, and come to the same result using the moon. I'm not going to spend the next 2-3 hours telling you what's wrong with that.
No,
because I know
you don't
should
want to.
Yeah, remember 23, I told you that I believe that you're here to preach.
This is what I mean. See, that's what I mean. Like, I said what I said. It is substantial enough for you to latch on to go, wait a minute, what are you talking about? You're saying that they can use observations of the moon to get to the same result when the moon is 230,000 miles away, but the sun is so far that they basically said it was infinite because the rays are parallel. Those two things can't be used to come to the same result, which is what your brain should be thinking, but you don't give a fuck about what I'm talking about. So, but anyway, thank you so much, Chris.
You're ignoring every other observation that the Greeks made to determine that the globe was indeed a sphere.
What you don't understand, 23, is they made assumptions. At around the same time, the Chinese did exactly the same thing, except they differed in one thing. They assumed it was flat at the start. And guess what? Their results came out perfect.
So do the Chinese still hold on to the flat Earth model?
They did until quite a couple hundred years ago, and it was something. One of they were infiltrated, not infiltrated as such, but they would change their doctrine for whatever reason.
Conspiracy.
Well, at the moment, all you're telling us is we should accept your word, and you